Друзья, всем привет! Итак, рад вас
Dear friends, hi all. I'm glad to have you all here. It's our second day at PH Days. Let's kick off our track. A bit of a background. We have a lot of very engaging presentations for you and store today. I'm glad to see you here at this early hour, representing our community of security specialists and IT professionals, championing secure apps. A bit of housekeeping. There are mics in the aisles for questions, so be ready to stand up and walk to the mic if you have an interesting question. Second point, we have a giveaway for the best question, as always, so you'll be assessed by speakers. Last but not least, speakers always appreciate feedback, so do take a moment to fill it in. Those who do this right after the presentations and stay in the room will be entered into a poll with a prize at the end of the day. Babbage and Lovelace Adventures is the name of the book that will be given out. First up, we have Lev Hakimov to tell us all about breaking containers. He is an expert in Kubernetes, head of Kubernetes security at MTS Web Services, a university professor as well, and a member of Go Committee, the programming language. Please come up on stage. You're welcome. Without much further ado, you're up. Good morning, everybody. Container Hacker to DevOps. Let's start. We'll discuss the design of containers, the ways to break into them, and why we, as infrastructure security people, have to check and double-check them before committing to prod. So, the most contained security presentation and the most secure container presentation, I'm guessing. I'm a security lead for Kubernetes at MTS, its division, Web Services. We're developing a new cloud service that will be released soon, so you'll be able to get a hands-on with it, just in a couple of days, actually. I'm a DevOps engineer, or I used to be, but it stays with you for life. It's a mindset that you carry through life. I'm now also an InfoSec expert, and I also teach at universities. ITMO, VGU, that would be in Voronezh and St. Petersburg, and I host CDFs. Just recently we had an event for school children and college students. It's a lot of fun, prizes are nice, so if you have some up-and-coming young professionals or you yourself as a student, come to us, to Voronezh, to participate in our CDF. First, we'll address the anatomy of containerization, how it's designed, what it does, why it does that, a bit of a background for you to ease into the substantive part of the presentation. Next, we'll be speaking about the main ways to break out of a container and why you have to mind your T's in certain configurations. In closing, we'll apply this to Kubernetes, how this works there, what configs need to be by default and always by default, and where you have to be very specific. After the presentation, I think you'll see why it's like this. Let's start with the anatomy of containerization. You've seen this a million times. Everybody is aware. Just one thing to keep in mind is that there is a shared core for all containers. OS core is shared by containers, unlike VMs. A container still constitutes virtualization or isolation, and it's enabled by the tools that are available in the OS core. Why is this important? Let's assume we have a company. There is a nice developer. Here he is, or she is in the picture. They develop great features. Then engineers come in, they release it to production. They do everything for it to compile faster, to work efficiently. We optimize it for different situations and use cases, even undocumented. It's all great, but then you have security review, and it all goes down the drain. It all has to be redone. You're nice and dirty, but you just can't do these things. And I'm speaking about business services as well as infrastructure services. And in infrastructure, you have networks, hardware, file management, tapping different devices, add nodes. In this latter case, you have to provide as few privileges as possible or deviate from some standards. So we'll focus on what we look at when we review containers. But how do you qualify a container? There is a set of mechanisms that you've heard about, most likely, and others maybe not. So here is a crash course on containers. First, you have Linux capabilities. Don't get anxious. It's just a list for now, then we'll make a deep dive. Linux namespace, C groups, AppArmor, C Linux, and seccomp. These are the main things that qualify a container. Let's give it a bit more thought. Capabilities. What that is a way to segregate a superuser's root privileges into small bits and assign those privileges to a process. They've been out for a long time, kernel 2.2, and they're an attribute to a flow. We can look them up in proc, and they're all included in capabilities page. We'll get back to cap.sh, the utility to look up capabilities. In the system, they are described as bit masks, and for human reading, we'll be using cap.sh. Other utilities are getcap and setcap. You either set them or look the capabilities that are set. And there are different capability sets: permitted, inheritable, effective, ambient. These are to make authorization of superusers for certain tasks easier, to not use setgit, and bounding. They used to be restrictive in terms of available or permitted capabilities, but now it's part of KSV process. And then here is cap.sh. That's our current capabilities that are installed in the system and that are operational, that are running. That's what we need to look at in the container before we go on. Then we have Linux namespaces, abstractions on top of the OS. The ID UTC network, host names, for example, mounts users. You can hand over a process to a new namespace, and some things that are seen in the parent process cannot be seen from there, unlike the other way around. So that's pretty much like parents and their kids. Kids live on their own, think that nothing of what they're doing is seen by the parents, but parents have a look over them. Then PID namespace is the parent namespace isolates a tree of processes. The parent process sees everything, unlike the derivative processes. So the numeration is different. Then we have mount namespace. It allows chroot, a great thing that you've heard about, I'm guessing. You change your root directory, and the process will be confined to this root directory. Everything above will not be available. That's the second thing that qualifies a container. By default, we cannot see what's going on the host if we did not pre-mount anything. Then there is network NS. It isolates the entire stack, IPv4 and 6, routing tables, firewall rules, ProcNet, and network interfaces and devices, as well as the communications between them. So the container would only see the packages that it receives, but it doesn't see what's going on the host machine, unless you let it or forget to configure something. Cgroups is the most popular namespace, I'm guessing. It limits processor time and RAM. It merits a separate presentation. Their behaviors are diverse and interesting, where you have OM killer, how the processing time is sliced, but it's not for today. Just letting you know that this is the mechanism for the container to limit the processor time that it can get at and the memory that it can access to. If it asks for more, it will be killed in case of ROM. Then there is mandated access. It can be CLinux or AppArmor. Let's think of AppArmor as a file where there is a profile for the app, what it can and cannot do, what files it can handle and not, what privileges it has. So the container will not be access things that it hasn't been expressly allowed to. Under the hood, this is enabled by LSM, Linux Security Modules. Again, it's supported at the kernel level. If you try to do something that's forbidden or prohibited, the kernel will send a hook notifying this, and you'll be prevented from executing that action. And then we have CCON. It limits the system calls that the container can execute. System calls are basically the main thing in an OS for user space to interface with kernel space, and we can remove actions that can be a vulnerability or what our app just doesn't need to do. If you're interested in eBPF or LSM, you can review your the other slides at your convenience. It was from a presentation focused on these two topics, so pretty hardcore in a way, where I was laying out ways to bypass those checks. So at your convenience, the slides are made available. But there are ways to ensure secure airtight isolation, but not everybody does this. We have this sandbox, which is a container. Let's look at ways to break out of it. There is a repository of examples. I recommend you review this, you try this at home, this you try at home. All attacks from today are detailed there and analyzed. It has code bits, split, descriptions, demos, So everything I will tell you today
дома развернуть ноутбук, потыкать и посмотреть. От
is available for you through this code
сложных. Там
to
будет
stand and run at home,
middle атаки. Ну, в общем,
breaking out of the container, manning the middle attacks. Very curious to give it a go.
обзорно вообще, какие техники побега из контейнеров есть.
Let's look at the high-level view of different ways to break out of a container. Not all containers can be broken this way. If it were possible, containers would make no use. Why would you need isolation that doesn't isolate things?
Проблема только в том, что
But there are containers that are secure indeed. But
их в продакшене крутится большое количество.
in production, there is a whole bunch of containers that can be broken like this potentially. The first attack is to mount a host file system. The minimum requirement for this is for the process that the container runs on and the capability called sysadmin. Most of attacks require specific set of capabilities or isolation being switched off for a namespace.
Второй вид атак, ну, про сисадмин вообще поговорим для начала.
And then we'll have C groups as well.
Это такая
Let's talk sysadmin first. It's a very interesting capability.
рекомендую про нее запомнить и сразу
Do keep this in mind, commit this to memory, and if you see this, it should trigger you big way.
достаточно давно. И она
It's a very relatively or very old capability. It's quite comprehensive. It's a capability that basically has root privileges. It can do very many things.
И варианты там и
If you go to man, it lists how it enables BPF, how it can mount and unmount things.
распиливают. И относительно
And
недавно ее распилили, вот вытащили CAP BPF, которая
it has been in development
обычно, когда вот
to be broken up into smaller capabilities,
очень часто
but
ну, куда приходят
it's very often that in case of a super user,
Overflow, до недавнего времени приходили, искали там
you would go online mostly until recently to Stack Overflow. So the difference between junior and senior expert is that juniors copy their code from the LP and seniors go into comments. So Container ATE, Creo, that so Docker Escape is
конкретно этот вариант используется в докер-сокете. Почему? Потому что у нас все еще есть раннеры.
is what it's called. This is used in Docker Socket because they have runners for builds and deploys.
И вот вуаля, мы уже
You
менеджерим.
add a socket to a dynamic runner and you are already capable of managing a Docker on a host. That's very convenient, but there is a number of vulnerabilities in the runners that you need to keep in mind. Then shellcode injection can be done versus ptrace. We'll be trying to deliver shellcode in debugging. Sometimes people just leave it hanging in production, but this is just for debugging, so you should never have it there. Kernel module injection, a less frequent one, but if your app engages modules of the kernel and it's been containerized, or if you have this capability on, it's an attack that you're exposed to. This module enables import and export of new kernel modules. Well, it's in the name. Reading secrets from the host through DAC-read search. These capabilities can be in place, and then sysadmins come in
Это получше, но файлы к хосте вы все еще сможете получить доступ.
and reprimand you. It can be
И, наконец,
then changed to DAC-read search. Override is slightly better, but still vulnerable.
нельзя сказать, что совсем, скажем так,
And then there is the last one.
это еще Notify and Release в C-группах.
It's not outdated yet, but mostly notify on release. That's in C groups. That's if you run C groups version 1.
Мы сейчас посмотрим.
There is one feature of the scripting part that we'll look at. So, mounting a host file system. The most basic attack that there is, and you're probably well aware of it.
В контейнере
You have to have
выключен AppArmor.
the container in cap sysadmin. You have to disable AppArmor, otherwise it won't work. So you have sysadmin capability, you disable AppArmor.
Подставляет профиль
Both Docker and Kubernetes enable this by default, but
AppArmor Unconfined, чтобы ничего не мешало.
some people enable AppArmor unconfined to get full creative license, but then you don't switch it off and you get what you get.
На слайдиках, но потом можно будет проверить.
My demos are in the slides, but you can do this at home at your convenience. You run capabilities, you install all, you do sysadmin, you disable AppArmor, and you mount dev.
Сделать, например, вот такую операцию.
So out of the container, you can execute this operation and see that it all works. This can be done from within the container.
У нас есть просто доступ к докеру. У
Let's
нас
say we have access to Docker.
операционная закрытая, например,
The
на основной системе, которая
user
не может делать. Но мы можем
is restricted in the main system,
которые мы не можем попасть, запустить
but
контейнера.
we can mount the directories that are inaccessible. You run a container where you have root, but then UIDs will be the same and you just swap them. You'll be able to access the directories that you were restricted from. The same attack works in Kubernetes. If you have privileges to set up containers, you can execute code there where you'd be able to mount the entire file system of the node that this code runs.
Это не самое интересное.
You'll be able to steal secrets and worker nodes. That's not very dramatic, but if you go from your node to control plane, you'll be able to manage the entire Kubernetes system there, and you'd be having cluster admin privileges. So it requires monitoring to be detected, and it's really hard to respond. If it's open, then there is no monitoring, probably. Then there is Docker group. If the user is in the Docker group, it can be done. It's specific to Docker and Kubernetes. This will not fly, but it's something to be mentioned. If the user is in this group, they'd be able to execute all commands, even if they were not given the privileges. Then there is set UI and set git. If you have these bits in your Docker, the Docker will run with super user privileges. The second option is remounting a Docker socket. There are some caveats here. Not as many, but you have to keep it all in mind. Remounted Docker socket container, that's usually done in Docker and Docker. You mount a socket, you do all builds through host, but that then mean that from this container you'll be able to manage host Docker. So you can make it more secure by applying these. You set the flag privileged. In Kubernetes and container runtime, this flag is a bit different. Your app will not have AppArmor. So it'll have all capabilities. Just one flag that destroys all of your security. These are the things that you shouldn't do. In sys apps, people often do privilege true. Everything gets working and people forget about it.
Ну и что у нас тут происходит?
Here is a demo.
Если у нас есть Docker-сокет, то мы можем...
We have a Docker socket. It means that you can stand a new container on the host. You're not prevented from this. And then you can chroot into host. Again, you have access to the entire file system of the host operating out of the container. Docker socket is open to all users. We are not part of the Docker group, we're just a user in the system, but we can set up containers with Docker sockets. That's what I've just demonstrated.
Третья штука — это shellcode и вариант
The first
Все-таки
attack is shellcode,
надо убирать. Это
and how you inject it through ptrace.
иногда я просто забываю.
That's for debugging. It shouldn't be in production, but when manifests are copied over, it gets overlooked, and this capability can end up in production. CSP trace is dangerous. It also requires PIDNS from the host to be shared with the container. That's for the container to see the process tree of the host. So the exploit and the shellcode are out there in the repository. We'll briefly look at some highlights. That's assembler shellcode. Nothing particular. Nothing particularly interesting, except that it opens the socker and it calls binbash at port 5600. That's how it's encoded, and then you inject it with the start address, and then it will be called. And here is the shell script that assembles the injector. You run a server, you look up PID, and you inject your shellcode. So that allows you to run a web server out of the container. You can connect to the host and do anything. You use Netcat and do your research. That's what you get from debugging. Let's look at kernel module integration. It's available online. You have this reverse shell, for example. You make it a kernel module and you ins mode it. The rest is the same. You inject reverse shell, you get access to the terminal command line. Just because you were able to output kernel modules from the container. Tag read research, tag read override gives you access to files on the host machine. You have this function open by handle add. As this call, we'll be reading TC shadow, and then we'll be brute forcing the password as well. Here is how this works. That's a function that I called out. If you have capabilities for DAG research and read override, you'd be able to go through the files on the host. That is through open by handle, and we'll be able to extract data from there. It's not as likely as this.
Стандартный John Reaper справится на ура. И как показывает,
as this, but then you can use any run-of-the-mill brute forcer for passwords, and the host passwords are pretty simple usually. So it happens pretty often. You have a dev stand, there are VMs with Dockers, there are containers maybe. Nobody is concerned about it that much. But then you get access to the container, you get a hash of passwords, you see that it's one of the easier default passwords, and then it's reused across the infrastructure, which will be a big problem.
Sometimes there is no isolation. The next point is C-group release agent. Not the very best thing today, but nevertheless, if you have C-groups version 1, low probability, but at legacy systems you might have it. Those C-groups have such thing as notify release, and script release agent is executed in the end. What you put in will be called. This is an example of the payload. Let's look at it step by step.
Запускаем контейнер,
Actually, we run a container,
записываем скрипт в
put
release agent,
ourselves there, write the script into the release agent, and if we have access to C group, what was written in the C group will be executed. So step by step, but let's skip it, because actually we just write our script into the release agent through the variables.
Тут по поиску пида, забить это в релиз агент, и дальше уже
So you
запустится.
put it in the release agent and execute, and it will run.
Эта штука
In version 2 of C groups, it doesn't work. But if you have C groups version 1, pay attention to it. And this option can be switched off. If you put 0 in the configuration of C group, it will not work. And finally,
тоже не везде работает.
ARP attacks, it doesn't operate everywhere. If you have Docker hosts, it will work. If you have Kubernetes with an old CNI, simple
Вполне себе
one, it may work. I saw installation of K3S in production, simple cube, flannel inside, and that's all. Such attack will work in that place. Is ARP attack. ARP is Address Resolution Protocol between level 2 and level 3. It helps us to use IP address to get MAC address of the host. It's one of the most important protocols in Ethernet, one of the basic ones. And there is ARP spoofing, man-in-the-middle attack, which helps us to respond faster than the host. And this protocol is built such that if we respond earlier, our response will be valid, our address will be entered in the table, and all the calls will go not to the host, but to us.
Хост назначения фактически станем
We
такой
can resend it to the destination host, and we'll become a man in the middle.
неуязвимый в сети. Не стоит
And we cannot be detected. Even in the most advanced systems, we may get such systems where it works. Let's have a look. In repository, we have a script which helps us to launch a demo stand. And now let us have a look. Let's see how it works. We have server 1, server 2, and a hacker who uses computer 1, and we have a router or a switch. It doesn't matter. For example, server 1 wants to talk to server 2 and sends an ARP call.
Верни свой MAC адрес.
So return your MAC address. The server responds to server 1 and everything's all right. However, if the hacker is going to send his MAC address, if server 1 gets his MAC address earlier, so it will believe that 140 will be the destination address and all the traffic will go there. It works very well in the container environments because we have a root namespace. Also, we have Ethernet 0 for a network card, and all our containers are in their own namespaces with virtual Ethernet, which is connected to the bridge, Flannel, Docker, everything is there. And if you send ARP attack, it will work in this environment. For that vulnerability to work, you need CapNet raw. and it works by default. This capability enables you to catch traffic in the container, analyze, change packets, and do anything you want. So we can replace packets and do a lot of malicious things, and no one will detect you, no one will see you. Let's see how it works. To launch it, we have to plan the scripts, launch the scripts, and then launch the ARP spoof script. And the picture will look like this. We have a customer, a hacker starts responding, and our customer will get the traffic from the hacker, although the destination was different to container 3, but traffic will not reach the destination. And the last thing, how can you move all that to Kubernetes? Because we often use Kubernetes and we configure it there, but we can do all that because it is specific for container runtime. Docker and Kubernetes have the same container ID. If you don't change, you can choose a different runtime, but fundamentally it's the same and universal. It is applicable to any container environment. First of all, you have to remember that Kubernetes by default uses the standard set of capabilities, Capchon, DAC override, we mentioned it before, and NetBeans service, NetRaw. We also mentioned it. Not all of them are vulnerable, but some of them are. When you deploy a new application, you must drop all capabilities. For business applications, it's universal. It should be done always. They need nothing but go to database or something else. If it's a system application, then you have to go to developers, create profiles. CComp enables you in the audit mode to audit all system calls of the application. What kind of system application do you use? If developers doesn't know it, you launch the application with CComp profile, open the monitoring mode, and see what kind of system calls are there. Then you can use that information here and it will work. And you will know what kind of system calls you really want. You can minimize the list.
User namespace.
Then user namespace. It's a recent option in Kubernetes. Remember that by default, we have to make host user false. Root container and root host should be different. And security context recommendation. Privilege is always off, should be of privilege escalation also off, so that even if a hacker will be able to launch the containers, it should have privileges higher than the host ones. Add only what you need. CComp profile should be visible. AppArmor is also good. Read-only root file system. No write. And run as on root, by all means. Sudo user 1000, group 1000. Of course, it's configuration. There are other practices. Simple images, the number of tools in the container, elimination of excessive tooling. It all works. If you go to Offstack, you will see it. It's a standard list of configuration that works for all applications, and you have to use it in your development teams as a universal set. As far as deviations are concerned, they are to be discussed separately. We have our hubs where you can read everything, how we develop in the cloud. You can look at our track and vote for my presentation. I think you will like it. Your feedback will help us make our presentations better. Thank you, thank you. Now it's time for your questions. Questions should be asked through the microphone. Hi, Leo, I'm Alexander. Thank you for an excellent presentation. You told us that you have to use profiles. If we understand that we need a dangerous privilege, what are the guides, the recommendations, how to provide such privileges if we need them? Yes, that's quite important. Development of large systems is related to host operations. To begin with, you have to be in touch with the developer team, with people who support a certain service, talk to them, explain how it works, what you can do. Very often there is a big component of the system which does a lot of things and something dangerous. And that dangerous thing should be moved away into a smaller component to work with it individually. Second, if some components and capabilities cannot be deleted, then look at the infrastructure wider. Where is the cluster? How you can get to that cluster? Very often there are some managed networks, and we can change the configuration. You can think how to get to this cluster, limit the number of customers, so reduce the attack surface. It's impossible to eliminate everything, but you can make the hacker's work much more difficult. He wouldn't have the time for his attack.
Слышно? Лев, привет. Спасибо большое за доклад, очень понравился.
Hi, I liked your presentation very much. Recently, I saw an interesting situation.
Есть RCE, blind RCE.
We have RCE
Docker контейнер с BusyBox.
in Docker container with EasyBox. BusyBox without netcat in get and sh. Can we escape in this situation? Because I couldn't escape.
Тут в данном случае, да, зависит отчасти от инструмента.
Yes, it depends on the tools that are available.
Какие-то они доступны.
Some of them are available, but others are not. If, for example, the intruder, well, if it's RCE in POP-C, you can attach a side container. You have to look at the specific situation, at the environment. Maybe from the container, if you cannot deliver the packet with destroyed image, you cannot do anything. You get RCA on the root. Well, this is not the worst situation, anyway. You can rebuild it with a different image. There are different options, but we have to look at the specific situation. Thank you. I remember what IPMI was there, and I downloaded something else instead. Well, any more questions, please? No questions? Then I have a question. Leo, Please tell me,
Технологии AI, в своей
did you use
Kubernetes очень интересно. Может быть, какой-то
AI?
experience,
Did you use AI?
что-нибудь, может
Have you
быть,
got such an experience?
будет, мне кажется, очень
Did you automate? Did you teach AI?
Хочу показаться очень ретроградным, но я
I
редко обращаюсь
don't want to be an old and retrograde person. AI generates manifestos, rules, lightweight rules. Of course, they have to be validated and checked, but some simple things, well-known things, which are available in the networks, can be done, and you can use it in your work.
Это в любом случае очень интересно.
But that's rather interesting. If you generate something through AI, you can reduce your workload anyway.
Тогда давайте поблагодарим
Well,
спикера.
then let us thank the speaker very much, and the speaker should choose the best question. Well, it's about RCA.
Можно, пожалуйста, подойдите, пожалуйста, к стоечке.
Please
Выдадут ваш
come here and get the prize. And I remind you that it's important for you and for the speakers to get your feedback.
Прекрасный доклад.
Send your feedback. Thank you. Thank you for the excellent presentation. And we move on. Good day to all of you now. What do we have next?
Рассказываю. Сколько у нас сейчас времени?
Let me tell you something else. How much time have you got?
Так, а сколько времени?
What's the time?
сказать, что именно в этом зале
Well, in this hall on Saturday in the morning, we'll have a competition, an Olympics competition for developers, where you can solve different problems, develop algorithms, and develop an interesting code, if you like. So Saturday morning here, and I'm going to announce the next speaker, Dmitry Shmoilov, head of the Security Development Department of Kaspersky Lab. He will tell us something about threat modeling. Hi.
Да, что-нибудь
Yes.
расскажем.
Yes, something about modeling. I'll show you something. We'll discuss something. We can start, or we can just talk. How did you get to that? Why did you start doing that? Why? What for? Well, security in your brain, it's okay. Well, without threat
in a big company,
modeling,
you
you
cannot
cannot do
but model
anything,
threats.
especially in big
If it's a big
products.
product, it's unavoidable.
Почти с нуля.
So we had to build it from scratch, almost. There was a patchwork. Some units did part of this work. They did threat models for certain sections of the overall functionality, but
Этими руками.
it was non-existent company-wide, and I had to build it with these very hands.
номер один, что моделирование угроз
There are two contesting opinions. One is that you don't need this threat modeling, and the opposite is that this is one of the fundamentals that you cannot do secure development without. You're a supporter of the second one. Well, I can give you a justification for either of those. But yes, this holds true.
Да, можно
There are cases where you can save
но
some resources on this practice. It's not cheap, but there are cases where it is essential.
ответов на ключевые вопросы.
Otherwise, you wouldn't be able to address key security concerns for your app. Well,
Окей.
let's start with that. That's enough of a tease. Dmitry, please. Once again, don't forget to rank the presentations,
Поехали, рад видеть,
score them, and provide feedback.
физически в
Sure.
аудитории. Сегодня
Let's start.
поговорим
I'm glad to see you all offline.
У меня, кстати говоря,
We'll be talking threat modeling.
куда-то потерялся. Ты унес.
I've misplaced the clicker. Do you have it?
Небольшая техническая заминочка.
Друзья,
Спасибо.
Small technical issue.
Давайте я пока в двух словах, наверное, расскажу про
Let me first say a few words about myself and our department. That's what you'll be seeing in the next slide.
Касперского. Ну, проводится по большому счету
Kaspersky Lab does threat modeling
безопасности.
under product security. That's our department.
Рассказывать про эту тему я. Меня зовут Дмитрий Шмойлов. Мой
My name is Dmitry Shmoilov.
Павел Буренин по техническим причинам
My co-author is Pavel Burenin.
как бы не
He hasn't been
на сцене. Ну, в общем,
able
здесь
to attend,
была
but
техническая нехватка, чтобы рассказать об этом вдвоем, но
there was an overlap. We intended to present it together. Anyway, our department
Касперского для всех
does this for the entire Kaspersky Lab company. So we cover all of our releases, starting from antivirus to other bigger products.
важно
Why and how is this important?
про эту тему.
We just began discussing this.
Моделирование угроз дает
with Alexei.
возможность выявить такие прям самые
Threat modeling
резкие
enables you to identify the most critical risks at the earliest stages.
ну, вообще в опыте разработки команд. Команды сами на первом
Development by teams
ребят, вот у нас есть вот такие проблемы, раз уж вы
usually leads them to us,
как безопасники, спасибо.
and they lay out their security problems.
Мы вам сразу
Since we've reached out to them, they're trying to
ну, собственно говоря, наверное, поехали, раз уж у меня
give
появилось.
it all from the very beginning.
Проговорю Надеюсь, что аудитория пришла послушать именно про моделирование угроз, а не
I hope you are here for threat modeling, not for a nap.
вспомним школу.
If you'll be sleeping,
Спасибо.
we'll be doing some intermediary exercises, just like in school.
Еще раз, мы представляем
Once again,
отдел продуктовой безопасности в лаборатории
we
Kaspersky.
do product security at Kaspersky. We provide the entirety of SDLC and other security development processes at the company. It doesn't mean that our small unit reviews all the code. We are an orchestrator or an administrator, rather, for a swath of architects, seniors, and middle developers specializing in AppSec. And then there is a whole group of security champions. I presented on this at other conference 2 years ago. We discussed it at Positive Hack Days as well, the processes for escalation.
Связанная с моделированием угроз и как следствие Secure by Design.
Threat modeling and what it translates into, which is secure by design, has evolved in Kaspersky Lab as a patchwork, and then it has grown into
Собственно говоря,
large scopes and in-depth analysis.
на которой построена, если кто
Secure by design is a technology that Kaspersky OS is built on.
адаптирована
And now it's not a white label Linux,
тезисом
it's a microkernel which has
фактически фундаменте. На самом деле
security at its foundation as the main driving idea.
спонсирована
That
достаточно
idea was
безопасной процесс.
co-sponsored by the founder
А дальше by design.
some time ago. So it was security by idea, and now it's secure by design.
Но архитектура там действительно
The details on this are available online.
в начале в самом разрезе.
So we came up with an architecture that's, well, again, secure
Много сборок,
from conception.
команд, все они вместе.
Kaspersky does a lot of coding, a lot of builds, a lot of teams that need to be aligned to deliver any given release.
Есть друг
There are
от друга
parallel tracks, there are things that are done in sequence,
вот интегрируются по большому счету и
but all security development processes are coordinated by our team.
этому слайду, как я всегда говорю,
Today we are focusing on threat modeling. This slide is 20 years old,
про
right?
безопасную разработку всегда говорил там
Previous presentations on secure development
дизайна софта.
I used to say that we have
Штука, как модель
cases of software design.
наконец
This includes threat modeling, but it merits a separate discussion, at least an hour. Finally, the day has
об
arrived.
этом более плотно.
We'll be
Понятно,
diving deep into this. Within DevSecOps,
тоже место
there is a place for threat modeling.
порядке. Многие будут
It's required.
доклада, если будут
At
вопросы.
the end of the presentation, if you have questions, once again,
Будут
questions are rewarded.
там жить в Agile. Вот проговорим.
There'll be questions about integrating this into Agile. I'll be addressing this as well.
Выкидываем. Нет.
DevSecOps doesn't preclude threat modeling.
Даже люди далекие от
Let's
безопасности.
take it bit by bit.
Просто IT.
People are not security specialists, just IT professionals,
Автоматизировать. Надо
deployments,
все, что вы можете.
engineers.
Оптимизируйте.
Their role for automation and optimization,
Сегодня еще поговорим.
how to
Этот слайд нужен для того,
run faster.
чтобы пояснить, что не только
We'll be delving into this as well. That slide was needed
системной
to
разработки
explain
это необходимо.
that
Это необходимо делать
threat modeling is required
в continuous режиме.
in all approaches. It needs to be not just a step, but a continuous process.
Мы занимаемся моделированием.
We have more than 7 years of experience in
Это не один релиз в год. Это
threat modeling in a pipeline of releases. It's not a release per year. We do threat model reviews every month, several of them.
команда
Our team is responsible for that.
артефакты моделирования угроз. Моделирование угроз занимается.
As the product security team, we accept and validate the artifacts that
относительно всяких
we receive as input from product teams who do the modeling.
задавайте вопросы,
We have been through the stages: anger, denial, acceptance.
этапе были
Yes, we've been there, done that.
кучу шишек, багов, проблем,
We have
технических,
seen and fallen for all the pitfalls,
разных.
legal, administrative, technical, what have you.
Этим опытом делимся.
We have the experience, and I'm here to share it.
Практика это дорогая. Мы с Лешей начали об этом.
We now know they're expensive. I mentioned this at the top of the presentation.
На каких-нибудь стартапах
It's not always justified.
нет.
Some startups do not do this for obvious reasons.
Конкретно рабочий модуль хорошо, если
People develop a functional module.
нет.
If someone thinks about security, is
Истории по безопасности.
it's good. Sometimes, most of the times, they don't. But there are many publicized cases of security breaches of startups.
Поговорим, это одна из целей.
And then we'll discuss automation as well. That's one of the objectives of the presentation today.
О чем не будем говорить, если вдруг
What I'm not going
послушать
to touch upon is methodology.
Нет, сегодня про это не будет. Почему? Потому что
Methodology from the regulator in Russia.
предназначено для того, чтобы
I'm not going to discuss this because this methodology is for you to understand what security tools you need to integrate into your infrastructure.
софта непосредственно для вашего
We are speaking about threat modeling for your software,
вашей организации.
the application that you are developing.
Поэтому вот вопросы, какие фаерволы поставить на периметре, это немножечко
Selection of firewalls is
я проговорю.
a bit different.
Они, к этому
The principles that we'll be discussing are applicable for that case,
Итак,
but my focus today is a bit different.
различные методологии,
Threat modeling.
какие про
There is a bunch of techniques.
возникают аббревиатуры в голове сразу. ЦВСС.
What are the abbreviations related to security? CVSS.
Немножечко это про другое. Что не
Not now.
а у
OWASP.
может быть ближе. У ВАСПа есть, в принципе,
That's warmer.
методологии описаны.
OWASP has
Про ВАСП я сегодня
good methodologies published on their community website. I'll get back to OWASP
скорее классификация. Классификация угроз, классификация.
several times, but their top 10 is
Но в меньшей степени
an inventory. It classifies issues and attacks,
наверняка многие из
but they have threats separately.
Stride, вот это прям ближе.
You might be aware of Stride.
И чуть-чуть
That
подробнее
hits closer to home.
остановлюсь.
I'll get back to this in a bit more detail.
Есть ли варианты каких-то других вещей? Кто не
There
знает,
are other similar things.
кто не слышит.
Is everybody aware of Stride?
Методология,
If not,
разработал Microsoft в свое время,
it's methodology developed by Microsoft.
как раз угроз.
They did this to describe threats.
В канале у нас может быть спуфинг, да, нам нужно от
There is
спуфинга.
a channel,
Вот
and we need to protect against spoofing.
в этой
That's
аббревиатуре
what S stands for in Stride.
буквы, они, собственно говоря, и
And as you can see in the slide, these are the classes or main types of threats.
рисковые модели, что с этим делать.
We'll be also discussing risk modeling,
Вопрос не отвечает.
which is not addressed directly within Stride.
С нашей точки зрения,
So, vanilla methodologies,
не сказать, чтобы не совсем
as we see them,
работают. Они дают
are not
много выхлопа и
entirely useful.
даже в такой
You
детализации.
get a lot of value out of them,
Итак,
sometimes with a bit more detail than necessary.
с выбором методологии
So you need something more.
мелкий шрифт, но
The first step
QR-коды вам
is to select methodology, perhaps.
классификацию методологии
The slide is a bit crowded,
бывают,
but you have the QR codes that you can use
что почитать
to look at the
конкретно в вашей,
classifications.
Ситуации
Then you can see what fits you best.
и посмотреть. Но еще раз,
Look it up at your convenience.
основной наш выбор, что ванильная методология, взять ее из
Once again, I reiterate that you cannot implement vanilla methodologies as is. They need to be tailored
команда понимает, они
to your teams
например, на своем опыте
and optimize them as well.
в прямом видео, но он не зашел, пришлось делать
We
второй.
weren't able to use Stride directly as is. We had to have a second iteration with training and all that.
Переводили под язык
We
понятный
still had to
разработки наши.
translate it into our own internal parlance so that we will all be on the same page, for example.
Окей.
Or a certification exercise, or to please the boss, it's going to be a paper that will be collecting dust on the shelf.
Рисовать
Not
диаграммы,
useful at all.
обсуждать во время обсуждения и рисования, включая
Do
голова с точки зрения
architecture diagrams and flowcharts.
модель.
This is what jogs your mind in terms of security. An architect that has modeled and put on paper
Безопасности. Когда вы приходите и задаете вопросы про безопасность,
their system doesn't always consider security. But then you start asking questions,
забыл вот про это,
and a lot of things come up
задавать вопросы, что если
where security
это
could be
внимание
lacking.
обсуждения, это очень важно.
As you have these discussions and
Начинает,
drawing board exercises,
разработчика
ask what-if questions, because that shifts the mindset,
реализации.
and identify risks
Если вы сразу
unrelated to implementation. If you start discussing actual implementations, you'll omit things or you'll go for the option that is too expensive.
моделирование угроз, это а чем, а как?
The next question is about tools.
Хорошим инструментом можно сделать и
Here's a few words about tools.
если вы хорошо им пользуетесь.
Good tools can do bad things for you.
Плохой инструмент,
It requires skill.
если честно,
Worse tools are limiting, but I've always stood for this approach that
хотя бы на бумажке,
start with something. You should start with something. Use Excel. Use back envelope notation.
в целом, когда вы начинаете
No automation,
инструменты уже
but threat modeling is better than nothing. And then you'll be evolving
иногда можно
and you'll be selecting, picking and choosing tools.
непонятно, да? Они все делают неправильно, но у них уже есть документация, надо встраиваться.
If developers have documentation, even if it's all wrong, you need to become part of that process.
Но если это
It's not as comfortable for us as security people, but if they have something standardized and universal, integrate yourself into that. Embed security into what they have.
надо понимать, что при
And then you can start considering automation.
кроме вот того самого моделирования угроз, про которое мы
Apart from threat modeling,
еще и
software development
моделирование.
involves system modeling as well.
Какая-то документация на софт в командах.
There must be some documentation on the side of the teams. That's probably what they're documenting. Architecture.
Вот на этом слайде я подчеркну одно, что
The takeaway from this slide is
из системного моделирования можно сделать модель угроз. Не всегда.
that you cannot always translate
Можно интегрировать.
system modeling to threat modeling.
Иногда придется перерисовать, иногда
It works sometimes you have to rework this entirely. It can be initiated by the teams as well. But at first glance, the schematics would give you a snapshot of the product. There are different tools for system modeling. Enterprise architect is used by large companies, so if you represent one, you'd be aware. Threat modeling tools are a bit different. Here are the main examples that are easily Googleable. That's what people usually start with. Vanilla Stride is implemented in MS threat modeling tool. Other entries in top 5 would be this and the rest of the slide. The other tools are based on OWASP. Look at the top right corner of the slide, which has architecture as code in it. But usually people start with Visio. It could be Paint, even, but pen and paper and flipchart is better than nothing still. There is a link to a good list of tools. It'll go through the presentation and it'll be restated at the end. Next, let's briefly cover a bullet point view of the main tools or elements in threat modeling. What are the main elements in threat modeling? Usually it's a sort of diagram. Any one-on-one course would tell you to lay out components, links, their properties, scenarios, and then external elements. Any architecture is abstract, so you can represent it in any way you like. It depends on your ultimate goal. An architecture represented for one task may not be suitable for security-related tasks. It may be lacking certain attributes or details. So you take it as input, but then you enrich it.
Классика, ванильная методология, да?
Here is an excerpt from vanilla methodology. That's what you'll get, most likely. Again, back of the envelope diagram, but architecture is not about CWE or CVE. It's not about CVEs. Do not try and use architecture for this. It's about CWE. It's not about vulnerability. It's about weakness. Looking for soft spots, looking for problems. We at Kaspersky call it security risk. And then you rank order them by priority and criticality. But this is not about CVEs. If you drill down to CVEs, if you're mature enough at this stage, hats off to you. But most likely, this is just too expensive. Even in our case, it costs you a penny and some. There are some projects where we see that it's possible, but it's rather an exception. That's because that was the intended level of deal. Yeah, insecure by design. The main set of rules is hard-earned with our experience. One of the rules is that the threat model should be understandable to both security people and development people. At the end of the day, it's an expert conversation, an architect or a senior developer, and an OPSEC person. And then you add detail to this. Communication channel. How do you represent it? A green arrow? Well, HTTPS green, but then does it have authentication? Is it required? Are there checks? Are there cipher suits? Are there thresholds? This can be in the diagram, or sometimes it may not. The arrow is green if it satisfies the security requirements. As for additional detail, we'll get back to it. Then you have a process. What does that mean? It's something that executes the business logic or the service logic for your app. The microphone cuts out intermittently. Could we swap it?
У нас сегодня раз-два. Что-то технические накладки есть. Не везет.
One technical hiccup after another.
Что такое процесс? Это
An unlucky day anyway. A process is an entity that does something.
примерно вот так.
What can go wrong there? Well, here is a pie chart.
Громкие уязвимости — это,
Most
как правило, эскалация привилегий.
widely publicized vulnerabilities have to do with escalation of privileges and executing malicious code. This is usually done in the processes.
Приоритет поменьше.
Storages, data segregation is a lower priority relative to processes, the privileges that it gets, the capabilities that it has.
Это все
The orchestration of the process itself are the things that have direct impact on the criticality of any potential problem. That's why you have containerization to isolate whatever you run in it, to have some guardrails there. And next up, we have a storage.
Жесткие диски.
What kind of data could you have?
Детализация
RAIDs,
этого всё
HHDs.
зависит от точки
Again,
зрения на вашу
the granularity will
Может быть, что
depend on your perspective on the threat model. It can be anything through to RAM,
регистра в процессоре.
a section in the register of the process.
Что мы защищаем? Задумайтесь, когда вы
You need to focus on what you are securing.
что мы защищаем, какая
As you are
информация,
describing
от чего желательно.
a storage,
Но это чуть-чуть дальше.
you need to have an idea of what's in there
Такой выбор
and
по
who could attack it or how.
Read,
And then there is a small selection of access lists, read, write, execute.
Граница доверия. Вот здесь вот я, наверное, чуть побольше остановлюсь и проговорю про
Trust boundary. I think it requires
Почему? Потому что
a longer discussion because it's important.
того, где у вас может что-то пойти не так.
It's the trigger
Вот две стрелочки,
where
видите,
something can go wrong.
проходят. Это и есть те
There is the red
истины, на
dashed
которые в
line,
первую очередь надо
and
обращать внимание.
arrows
Если
go
у вас в
through it.
программе нет границ
These
доверия, у
are
вас,
the priority
вы
risks.
можете ошибиться.
If you don't
Ни со
have
стороны безопасности,
trust
ни
boundaries
со стороны,
on your diagram,
потому что они так
you can
писали
make a
свои
mistake.
модули, как им
As
необходимо.
security people, not
Вы
as
можете
product
ошибиться
development people.
и,
They
не
have all the models in place, but if you don't have the boundary,
проходят в
you'll miss some of the risks.
Здесь могут быть проблемы.
Two arrows go in, into your perimeter, a malicious payload can be delivered.
И так далее. А,
You can be
например,
parsed,
вот с этим хранилищем, с файлом,
or the
здесь
process can
безопасно,
crash.
потому что нам как бы неинтересно, они все равно
And within
крутятся в одних
the
привилегиях.
perimeter, the connection to the file in the storage
Бежим
below
дальше.
is not as
И немножечко поговорим
critical
про
because they're in an environment.
инструментарий, для чего используется. Здесь, наверное,
Now,
больше погрузимся в то, как
let's speak a bit more about specific tools and how they're used.
там артефакты.
And we'll see the artifacts that you can use to build models. Once again, store all artifacts. Anything that you've analyzed
Как говорится, машина все стерпит.
needs to be stored. Storage is not that expensive.
От человека читаемого к машиночитаемому формату.
You need to make the transition to machine-readable formats from human-readable.
Ну,
You'll see why it's needed a bit later.
Вы используете.
And then,
Архитектура может быть разной. Она может
regardless of your architecture, you can choose your tools. Your entire architecture can be a few boxes on a sheet. This kicks off the discussion. But the picture to the left is a real architecture of a real product. It's just that the details were available and they could be analyzed. That's why they were put in the architecture. The standard approach is to divide and conquer. You split things into smaller elements, something that you can wrap your head around, and then piece it back together. That's what you'll get if you try that. Things fall by the wayside. Things do not jive together. The arrows do not arrive where they have to go. Some elements are lost, overlaps. Some things are left hanging in the vacuum. Nobody knows. Is it ever used? Is it even from this project? So you need machine processing for this. The challenges are breaking down complex diagrams into smaller ones. It's not a workable solution at all times. We tried one thing, but I cannot recommend it with certainty yet. We are trying StrideGPT.
Почему нет?
Converts graphic architectures into JSONs.
А как вы применяете ML в
And I was asked already about ML in threat modeling. That's part of the answer. Then you have consistency. Manual checks have their limits, especially when you're pressed for time. Again, humans can process only so much information. So the tools have to correspond to the actual objectives.
привести в
That's how we've tried
модели угроз.
to
Происходит. Смотрите, здесь
visualize it all in one place.
наших
Our
внутренних
inputs of
для вас
of
может
that modeling.
тиражироваться. Здесь
It's specific to our company.
Я сейчас подсвечу через два
There
слайда
is just one key point that
Вопрос в том, что
I'll be
мы
discussing in two
мы,
slides.
когда,
After the
внедрили свою
slides.
автоматизацию, мы вот такую
We were developing automation
ввели. То есть у нас есть
for
какая-то
this,
архитектура, в
which
которой
required an analysis first. We have an architecture, it has its own format, it describes different subsystems, different usage scenarios. We're trying to identify risks there with or without automations. We started without and then with. The output should be mitigations and priorities.
кусочком, чего бы в ней не забыть. Да, это в первую очередь.
So what shouldn't we miss? It's a small checklist. Check completeness of all subsystems. Check the legend. Check the descriptions. Otherwise, you'll do an additional piece of work. Check all the connections. Are all the pieces connected to each other? Is there any isolated one? Are there any isolated ones? Check the consistency of subsystems to the scenario.
Проверка
Then check
пользовательского ввода, хранилища.
all the parameters of user networks, storage, external subsystems, and how it's reflected in your requirements. What else do we get?
Экспертная работа.
Expert operations, security expert operations, and architect works are not scalable. This all is done by human beings,
В последнее время становится немножечко сложно по этому поводу.
which is not bad at the moment. We're not replaced by machines. So we need human expertise. One person can say this way, the other man can say something different. Our human expertise may be different in different people. So if you come to the same project, if different architects, different security people come and say, why are you doing that? Well, the previous one told us to do that. They didn't deceive us. So those two people saw your project from different angles. They had different ideas. So this is part of our checklists. The main idea is that such work is not scalable. Maslow pyramid. Maturity of architecture. What do we begin with? One step back. How threat modeling is growing. First, non-formalizable architecture. We don't know anything. Nothing is described. So it's too expensive, and so on. So there is just a picture on a sheet of paper. This is already better. A picture in a graphical editor. You can save it and version it. So in a better format, it's better because at the next stage of the life cycle, you can try to automatically process it. Then picture by text creator. We take picture from the text. One of the tools can do it. So we have a tool to build architecture, which is good. Here we already have a model. Software tools to build architecture, automatic building of your architecture from the code. Super. If you add dynamics, then all the product can be seen in different slices with different filters from 3 cubes to a very low-level coverage, going down to interfaces. Who of you reaches that? Tell me. We have one project where we can do it to a certain extent with different limitations, and automatic building a product from the architecture. This is a dream somewhere in the future. You have an idea, click, there is a code, another click, there is a product. A golden dream. Now, visualization, a picture, something that we need. We believe that this is the architecture. Picture is not a target. Picture is a tool, is a means for manual analysis. As long as you get a picture only, you cannot do anything but manual analysis. Then the picture should be correct, and you need a model. What is important? When you build a threat model, you have to ask question, what for? Not the question, which instrument are you going to use, but what are you going to do next in the end? How we are going to prioritize the problems, under which conditions, what are we going to do next? Description, software, tools, and storage. It should be stored in one place. Next slides will show you the pyramid. What does it tell us? In the previous slides, we were talking about level 2 and level 3, mainly level 3 visualization. Now, what is inside? The theory on which the model is built. It's the answer to the question why, not how, but why. What are we going to get in the end? We want to get security. We want to understand whether it's good or bad now. What do we have to do? Then we can build a description, and the description will dictate to you the attributes of the model, which describe your architecture to detect security risks, and then visualization in tens of formats, PDF, vector graphics, drawings, frames, anything. It doesn't matter. It will be done by a generator. You go to ChatGPT and say, this is a chat, make a drawing. This will be a square, this will be a triangle, this will be a circle. Draw the picture. Let's go on. Now, this is key. This is the key, really, of this presentation. The model of threats consists actually of two things, two types. The essence and the attribute. The essence is any element of your diagram, a circle, an arrow, a square. This essence can have attributes, privileges, for instance. The arrow must have ciphers, suits, ports where the arrow points one-way, two-way, protocols. These are all attributes of the essence. Pavel Burenin, my co-author, told me that this makes me possible to see what to do. Take JSON, describe architecture in the code, and then take visualizer. You can make it green, blue, red. If such an attribute is attached, it will be yellow. a few minutes and it's all right. Because this is done at the design stage. So level 2 and level 3, entity attribute. Now, formal theory, several formats of storage, XML, JSON. So entity attribute, a lot of algorithms of visualization. We are not limited. Different tools offer different visualizations. Notations can be different. For this stage of security modeling, you have freedom of action. Now, architecture as a code. What can we offer here? Building the model from the code. Well, it's the simplest thing of all. Let us agree on definitions and keep it there. If everything is described properly, then you will have correct modeling of threats. Visual modeling through code is good for developers, especially if later it can be merged with links and interfaces. That will be very, very good indeed, because you'll have consistency everywhere. It's better to do it at the level of code review in architecture. And text, XML, JSON, anything. The main thing that it can be read and the attributes are correct. Everything seems to be clear, what we have and why. Before we set architecture as a code, well, somebody generates a text and how to check that text, how to read the text. This is the text which describes graphical representation, and the attributes can be any. Links between attributes as many as possible. I am coming to an end. I think it wasn't very tiresome presentation. Now, secure by design. What does it mean? Secure from architecture. Architecture which can be secure by design. What is the worldwide practice? What do we read in the foreign sources? We in Kaspersky Lab, as a group of experts, and we started from looking what is done abroad. They have standards which say, well, it's nice to use secure by design, but what is it? Each standard describes it differently. In Europe, they have one definition with principles. In AWASP, there is something else, secure product design, check sheet. I do recommend to you to create checklists. Checklist, and then the knowledge base, it's also good. You have it, I'm sure. Now, secure by design, they have a checklist at AWASP, there's the GDPR, but the Europeans tend to use secure by design. They call it privacy by design. Secure by design and privacy by design together. And also safety by design. Safety is more about motor cars, so that the robots do not bring any harm to people. Safety by design. Just safety. Do not put cats into microwave. Something like that. So there are the main points here and the main trends. There is no one centralized step-by-step solution. We in Russia started thinking about it. We have a project of a government standard with a definition. It's not just a translation of the Western description. It's a rethinking of what they did and description of what we can do. It's a system which is secure. When we developed it, first we think about security, then we start developing, because most of the systems, I don't want to harm anyone, offend anyone, so they developed on the as-is principle. We develop, and then we try to secure what we have developed. Secure by design means the other way around. First, security, and then design, taking into account the security principles which are already available. What you can read is as follows. On your left, the tools.
Справа несколько книжек.
On your right, a few interesting books, classical books for threat modeling.
Очень известный товарищ,
The author is very respectable member of AWASP, who wrote the first books about threat modeling. From O'Reilly, a nice book with a list of important things, including bibliography. And then, when I prepared this presentation, I looked at what is happening in the world. Next week, in Lisbon, if I'm not mistaken, or maybe in Spain, you'll have a conference. Same conference, but it will be the AWASP conference, the European ones, with a presentation about threat model libraries. People want to develop and share knowledge, and this is very important indeed, because the elements, the attributes, and mechanisms of identification of various problems, they all will be there. Let us wait and see and monitor and exchange views on that subject. And the final slide of my presentation. You came here, so you are interested in threat modeling. Then you can sign the threat modeling manifesto. Who is going to model threats? You. Thank you for attention. I think my knowledge and knowledge of my team will help you to work. Do not relax. Continue modeling threats. Thank you for your attention.
За отличный доклад. Друзья,
Thank you for the excellent presentation. We have some time for questions and answers. Of course, you can get a prize for the best question.
Дмитрий, спасибо за доклад.
Thank you for the presentation. Hello. Hello. You said you have an architecture, but what about the model of threat? Is it made as a code?
Архитектура as a code и модель угроз.
The architecture is as a code, threat model is as a code, but the threat model is not equal to architecture. There is a whole process and understanding on what is good and what is bad, and division of those two things. Actually, modeling of threats as a service. It's better to say, to put it this way, as a service. It's specific. In different organization, it's described differently. In each organization, acceptability of risks can be different. Criticality is different. What is stop for us, for you, it's all right. At service modeling, you are not going to discuss what we are discussing. We have automation of threat modeling as a service, but not as a code.
оптимизируем, скажем.
Of course, all the scripts are there. We try to optimize that, but applications operate in the dynamic environment. It's not static, and you get feedback, incidents, new threats. How do you take it into account? How do you get the feedback? How do you correct and update your architecture? Yes, actually, if it is necessary to update the architecture, it happens all the time. Architecture of one product can be different from the architect of another product. It depends on the developers. It's not done from the code automatically, which is not always the case. To put it mildly, how to react to new threats. Plus, minus, we have a list of typical risks, which we process all the time. Last year and a half, we had a meeting where we wanted to add one typical risk because of what you say. And we did it very cautiously because one risk is translated to many scenarios, about 20 of them. So we have to do very careful. So after 3 more conferences, we added it. JSON scheme makes it possible to add new risks. Yes, we have no limitation here. Thank you. A question. Fedin Alexei, system analytic. You have already answered this question, but very briefly. Your team is InfoSecurity. InfoSecurity is a separate team. We are inside R&D. So you are security team, but your vis-a-vis, you work with IT people, with developers who know nothing about InfoSecurity. They don't have such notions. They use different words. Audit and monitoring, incident for IT is not what an incident is for you, for security specialists. IT people try for themselves to see some threats the way they see it. From the viewpoint of InfoSecurity, it's not a threat. Or what is threat for you is not a threat for them. What is your approach to such relations with IT people? We are all human beings, and each of us has its own knowledge base and opinions, and we cannot make all that uniform. Let us install security into this brain. No, it's not possible. Security champion is responsible for threat modeling. He knows something about security. Of course, there are some teams where there is no security champion among the developers, or there is a startup person. So we try to explain to them what really happens. When a person starts thinking about security, he switches on and starts thinking. Sometimes people try to mitigate the risks which shouldn't be mitigated, which can be missed, but not very often. My name is Peter. I have 2 questions and 1 idea, 1 comment. The first question is about microservices. You have an application with a few microservices which interact. How do you regard them? As a monolithic entity, as a set of microservices, or are you going to secure them one by one? Which is more optimal? Honestly, the question is not about threat modeling. Microservices and threat modeling are different subjects. Microservices is type of mitigation. They can serve as a kind of mitigation. A microservice is just one of the processes. You can have a lot of more. You can, if necessary, you can create a lot of trust zones for them. For example, escape from our cluster. Can it happen or not at this stage? Well, your question is about hardening. My colleague at the previous presentation tried to answer that question. Well, it's not exactly about threat modeling. We have at the time for one more question. So let us discuss it offline. You're not leaving. We can discuss that question later. The system for which we model threats is changing at a time. How can we update the model? Because the system is changing. How can we automate the process? Well, the question of incremental development of the product, release from release. What about agile? What about small changes? Of course, there is a question. All the textbooks, all the manuals say you have to review and you have to update the threat model in accordance with the changes. Not each change and not each business requirement provokes changing the threat model. So we have to have certain slices or layers, thinking whether this new requirement affects the threat model or not. From release to release, we build a threat model on the basis of a template of the previous release. So we have 20 new business requirements. These 3 or 4 change the format of the threat model, and we have to deal with them. Thank you. Thank you very much. One more, very last question. Very last question. Thank you. Well, I would like you to specify whether you prioritize your work and how. Whether you prioritize threats or no. Threats or risks? Threats? Yes, I thought threats or risks. What kind of prioritization do you do? You have to do it. Yeah, I understand it. It's a very good question. And I would give the prize to that question. How much time do I have? 2 minutes. Let me try to explain. Why is it important? Why is it good? Because it says whether we can prioritize threats and threat modeling. The question is not always, maybe not at all even, because from the viewpoint of threat attack surface, they can be prioritized. What do they pay for? For RCE and for zero threat. The attack surface and severity of the problem. It's risks, not threats. First risks, then everything else. As far as threats are concerned, well, it's very difficult to prioritize them. This is more, this is less. Any threat can produce any kind of risk, unacceptable risk. Threats can be regarded at one level, while risks produced by those threats, they have to be prioritized. Thank you. So the best question has already been selected. Please come to the audience and get your prize. Oh, thank you. Thank you very much. Thank you. Thank you. Thank you all. And the next presentation will be by Michael Parfenov about security of
FrontSecOps.
FrontSecOps
Фронтенд приложений. Михаил, попрошу нас...
front-end applications, security of front-end applications. Warm welcome to the speaker. You have a clicker, you have a microphone, you are welcome. Oh, the clicker. Please give it to me.
Микрофон есть. Все. Тогда...
The microphone is there. Michael, the floor is yours. Can you hear me? Hi, everyone. I am Michael Parfenov. We're going to talk about secure development of front-end applications. Let us discuss content security in Russia and what we can do about it. A few words about myself. I am in cybersecurity for 10 years. 5 years as AppSec architect of DevSecOps. Right now, I work in DPA Analytics. We develop products.
I'm responsible for development and roadmap
try to
of Russia's
develop
first
front-end application security
fast
testing
analyzer
and
front-end
have a channel about secure development of front-end
analytics security
application.
testing. I'm also a community lead. Today we'll be speaking about specific features of front-end security for apps. I'll showcase our research into security of Russian front-end apps. We'll be speaking about our proprietary threat modeling framework for front-end, and then we'll be applying behavior analysis to achieve secure by design. Front-end is a blind spot for InfoSec. It's a given. You might have heard me last year at PH Days or in fall at SafeCode, where I delved into this more, but I'll give you a bullet point view. Secure development for front-end and back-end, we use SAST, DAST, OCA, SCA, and some vulnerabilities can be missed, or there is a transitive zero-day. The backend is secured on the perimeter level. WAF and GFW. Even if it misses an attack, we have EDR container security, anomalies, SOC, CM. There are additional lines of defense that provide us a safety net, but then you get to front end. It's user side. There is a browser. We send a JavaScript file, a good bundle, 100, 300 transitive dependencies. And then we never know what happens next. Front end is a blind spot, as I mentioned. And then it gets even worse. Some of front-end code can be loaded dynamically in the browser's runtime. This can be third-party CDNs or partner services like Analytics, and then JavaScript can import code dynamically into the page. In a classical sense, breaking front-end doesn't make more sense. It's a white box running in the browser. You need a different angle for front-end security. For example, what if the attacker were able to deliver malicious code within our app? Why would they do this? What's the snatch? They can steal data, they can add malicious modules to the page, they can do transactions or actions on behalf of the user, like share, repost, or something to do with money. Then there is front-end phishing. That's one of the more destructive attacks. Most of the drills or trainings tell you that check the domain name, the address line. But in real life, you open a legitimate app, and then in the name of your company, there might be a phishing element, just one element. Enter your details, you'll get a bonus. Then users' browsers can be used for cryptocurrency mining, and then users can be infected through browser vulnerabilities. Just this year alone, to date, there were a couple of 0 days in Chrome. If malicious code is integrated into popular services, this can be used to deliver malware and then jump to some corporate environments as well. So what are the vectors? First and foremost, dependencies.
По сравнению с другими языками проблемный пакетный менеджер.
This is one of the more problematic packet managers. There can be hundreds of thousands of dependencies in JavaScript. Then you have compromised external services. If you use some analytics, they are compromised and there is malicious code, you'll execute it. Google Tag Manager or similar services. If the Google account is hacked, there are triggers to integrate malicious code into your page. Then web server breach, it's attacked on the back end, but then monetization happens on the front end. Then there are bad actors on the inside, developers, marketing professionals, admins who have access to front-end code. And then there can be unintended bad actions. Developers copy code from online or from LLMs. Here are some cases. The first front-end-based supply chain attack that was widely publicized happened in 2017. Ticketmaster of the UK was hacked through a third-party analytics. They integrated a sniffer into that. It's been active for 8 months, and they stole bank card details of more than 40,000 users over that 8 months. And there were actual debits to those cards. Investigation has revealed that. 2017, I remember the day, that morning, that I fire up my laptop at work, and I saw cover publishing that there was a malicious iframe on Gossuslugi, the Russian government services portal. We saw it firsthand, yeah, but it was eliminated quickly. Then, next year, British Airways got hacked backend. There were static JavaScript files. Again, a sniffer. It was up for 15 days. They stole more than 300,000 bank cards. Similar attacks were mounted on hundreds and thousands of online shops. CMS vulnerabilities were used to get in, and monetization happened in the front end. In 2019, according to the Russian monitoring agency, there were JavaScript miners on Russian government websites. Next year, attackers became more covert. They added their own code into Google Tag Manager, and through this, they added sniffer as a pass-through. 2022, as Russian audience should be aware, one of the Russian marketing analytics services was hacked. A lot of companies were affected. It was a political action, so it was 1 or 3 days, and the websites were defaced. But if the intent of the attack were monetization, it would be more covert. The widget from the Ministry of Economic Development was hacked like that, and whoever used that widget were affected. Last year, Polyfill.js, a library and a service, is quite curious as a case because developers added malicious code on their own. They redirected users to online bookies websites during the night. That's the developers monetizing their own service. There were complaints on GitHub overnight, but it has been out for 3 months. So malicious code ran on hundreds of thousands of devices. Last year, there was another library, LatiPlayer. It was a phishing attack. A developer's account was hacked, and then they published a version of the library, including malicious code in their name. As you entered the page, there was a form asking for your cryptocurrency wallet to operate the service. It was noticed in 3 days, but some people fell for it, and it's estimated that the losses were over $700,000. A similar case, but with Solana, they had a front-end library, including malicious software, several $100,000 in losses again. Again, front-end is a blind spot. Actual defenses and analyzers cannot identify current threats, except for NPM. The malware operates for weeks or months, which hints that security people tend to ignore front-end. Attackers thus get more opportunities to monetize their attacks. This gave us an idea to research front-end security in Russia. Our approach was as follows. We sampled 3,000 publicly available front-ends, different sectors of the industry, of the economy, IT, services, media, banks, telecoms, remote banking as well, your personal accounts online. And then we have a separate category for Russian integrators and security vendors. More than 3,000 commercial apps, all publicly available. We used our fast analyzer on this. It's a front-end sandbox. It used a real browser to go to those front-end applications and never loaded the app itself. It just collected data for a minute. It was Q2 2025. Here are some high-level stats. The average number of scripts on a page is 49. Its average size is 3.3 megabytes. Then, 83% of front-end apps use third-party scripts, third-party hosts. 64% use third-party hosts that are outside of Russia. The average network requests from these front-end apps is 14. Over 70% of apps call foreign services. 35% of pages have iframes from foreign hosts on their pages, and almost half, 49% of apps, call the eval function, very popular among attackers. If your app uses this function, you cannot properly configure content security policies, and it harms your security in a big way. A few words about content security policy. 25% of apps have this header. That seems reasonable, but then we looked into this, and the configuration is scored at 7 out of 100. Sub-security integrity is used by just 2%. Browser console errors were present in 45% of cases. From experience, I can say that it's quite curious. I open the browser console in Chrome pretty frequently, and we see a lot of errors there in many apps. It's not good. More than half. Google Tag Manager, 26%, 38% for Google Analytics. Yandex Metrics, 72%, which is good. But Yandex Metrics with WebVisor enabled is 37%, and it collects a lot of data, which is not good. Here are some highlights. To the right is the total. The rightmost column is the overall score. And then there is, to the left, breakdown by industry. Third, from the right, will always be lower because these are remote banking systems. It's usually somewhat better than the rest. So, foreign hosts and scripts taken from there. Most of apps use it. But it's still not zero in online banking, 9%. Network requests. Online media perform the poorest. the number of hosts where they send the data to goes up to 100, and the average is 40%. CSPs,
Думаю, тоже многие знают. Это механизм безопасности браузера.
as you'd be aware, this is a browser security mechanism that allows developers to use specific headers
Какие-то ресурсы, например, скрипты, там,
to
стили.
whitelist resources, scripts, styles, and then there are other directories
Ограничить фронтенд
to
Вообще в спецификации
confine the front-end app.
в официальном
The
документе
specification for version 2
security policy не предназначена для использования в
says
качестве
that CSP is not intended as the main defense against content injection,
от таких атак.
including XSS.
Контент
It's
security
used as a mitigation.
самая жестко настроенная.
Even the strictest CSP
С фронтенда. Есть один
doesn't
канал, который она не
prevent leaks from front-ends.
Кому интересно,
It doesn't control navigation events. I have a Humber publication where
практически
at a test rig I show how you can get data out of a page even with strictest CSP.
Same origin, да, все, только same origin, больше
Default source, same origin is the best CSP, but business requirements prescribe business analytics.
дырочки, которые
That's why there are gaps that are left in
ослабляются из-за
purposely in CSP. And then
например, если
it's
используются inline-скрипты какие-то,
weakened by poor programming. You have online scripts, eval, JavaScripts, and event attributes, and so on.
в каких приложениях, в каких категориях
We have reviewed the apps
понятно, да, опять же,
and the categories that have CSP. It's somewhat better for online banking, again, but it's just 53%.
это неплохо для использования.
23% is not as bad when it comes to CSP.
Но дальше мы решили посмотреть, собственно, на конфигурацию.
But then we scored the actual configurations,
Крайне печально.
and it's really very sad. The average score is 7 out of 100. 100 score is default same origin. And then you take down scores for different configurations that reduce security. Even in online banking, it's just close to 30. GTM is a service that comes as a script. You embed it into your page, and then Google gives you a console where you set triggers to scripts from other pages. Time of day, URLs, usually used by marketers because they need different analytics across different pages. They need different marketing tool scripts. And Google Tag Manager enables with without additional development. It's a marketing tool. The scripts are stored at Google and managed through your Google account. It's like a front-end backdoor, a front-end shell, if you wish. It was used by attackers in one of the cases to obfuscate their sniffer.
Так вот, Google Tag Manager используется тоже, ну, практически повсеместно.
Google Tag Manager is almost universally used, even in online banks. 3% of banks use GTM.
Ну, вообще, желательно отказаться.
Here are some ways to reduce risks of GTM.
На российские аналоги.
Avoid it if possible. Switch to Russian analogs.
И какой-то change management вести.
Give access to GTM to your security department to provide oversight and change management.
Вообще, чаще всего вот какие зарубежные скрипты
Our analysis then focused on
чаще всего
foreign hosts.
выявили интересное. Мы
Curiously,
очень часто используют хост
the
Bittrex.
most common host is Bittrex Info.
Система, CMS-система Bittrex,
The Russian CMS system called Bittrex
система аналитики, и
has their own analytics service,
ее используют
and 21% of front-end apps use it, almost 650. It's hosted by Amazon in Ireland.
и туда же отправляет
So
данные.
the script is loaded from Ireland, and that's where the data is sent.
Компании, использующие CMS Bittrex, да,
It begs a few questions.
о том, что
Do the companies know
их пользователи, которые, например, Роскомнадзор
that
узнает персонально,
the behavior data, which is classified as
была рассылка,
personal data by Russian
что все компании должны
Consumer Protection Agency? Just a few months ago, there was a mailing list circulated stating that Google Analytics should be removed. So do they know? What if Amazon's IP addresses are blocked? Is it an undocumented feature? Will it lead to failures and crashes? Starting from 2023, trans-border transfer of personal data without notification to the Russian Consumer Protection Agency is prohibited. This can also be interpreted as collection of personal data using databases that are foreign, collection of personal data with foreign services. If you don't have it in your privacy policy or consent, you can be fined by Roskomnadzor Protection Agency. And then vendors should ideally check their front end for security. WebVisor that I mentioned, a Yandex module that's part of Yandex Metrics. It gives you virtually a video feed of what the user did on the page and how they filled in the forms. If you have it in the user's account, it's equal to sending all personal data and logins and passwords to Yandex. Front-end owners consent to this, but if an attacker does this, integrate their own module, they can use Yandex infrastructure to snoop the data. HTML comments. I saw a lot of funny ones. Some are innocuous, others can be dangerous. 2FA is temporarily disabled as per request of business user. Tester code password 123. Just clean up the comments in HTML before you publish it, right? We have a methodology to score front-end security. It's 100 points scale. There are different criteria that are weighted. That's what we get. The average across all industries is 39 out of 100. That's not a pass. Online banks score 77, which is some ways towards the ideal still. How to interpret this score? That's important. If you have GTM or if you send data transporter, it's not an incident, especially if you know that you're doing this. But this doesn't reduce the risk if you had it approved. By knowing about this is that you carry out regular in-depth analysis of the app, you manage the changes, and you get alerts about unsanctioned changes. That's what we mean by you know and you're aware. You can use our fast analyzer for this. It'll have a scan cycle of 6 to 12 hours, and then your score will go up 40 points, for example. Still not ideal, but you are on the situation. Here is a real-life case, eval. There is a corporate anti-fraud system that uses it legitimately, but then you have a transitive dependency, you get malicious code that uses the same function to do the attack. An in-depth analysis can show you who initiated this, what was the argument to the function, and a second such call to eval that's not legitimate will be detected. Why is the landscape so poor? I think people do not recognize the threats. That's the reason. How can you model threats for front-end? There are generic methodologies, Pasta, Terra, Stride, Dread. They're generic. There are tools that are a bit more interesting, and the threat catalogs. Starting with the tools. You know, Microsoft threat models, OWASP, similar tool. They don't usually include the browser part, actually. Or they highlight it as a spoofing threat. So there isn't much insight into front-end. These tools are more suitable for IT systems where you have an infrastructure and internal connections. Then you have catalogs like Mitra. We've looked at all the threats and classified them into 3 buckets: front-end plus back-end, and universal. Just front-end is DOM-based XSS, click-jacking, content spoofing, and things like that.
Фронтенд чуть побольше.
Then you add backend, it's a bit more, and then there are universal threats.
Фишинг, да? Кто, когда
Phishing
видит фишинг,
is universal.
до фронтенд-приложения. Или когда идет
But when you hear phishing, do you ever think about front-end?
несанкционированного. Тоже, наверное,
Screen capture if it's unauthorized, or audio recording for the mic. I don't think anybody thinks about front-end in this context.
то же самое.
Then you have
Так далее.
our Russian supervisory authority list.
Микрофона, но тоже кто об этом
Front-end
да, речь идет про
includes
в итоге, на мой
unauthorized access to your microphone, but nobody thinks about it
когда мы
in this
пытаемся
context.
или в целом смоделировать угрозы,
So existing catalogs of threats models
не вектора.
leads to a complete lack of awareness of the vectors or the consequences. I've heard it in my own experience from developers, security guys, OPSEC people. It's all user side. What's there to hack?
Построить свой фреймворк для моделирования угроз,
We've developed our own threat modeling net framework with risks and mitigations. We have threats, vectors, consequences, or impacts. We're trying to describe it in plain language. We have 75 plus threats.
Точка, скажем так, начала для последствий, то есть технический вектор, это размещение вредоносного кода.
We have the technical vector. That's your entry point. One of them. That's how you place malicious code on the page. The impacts, data leaks, phishing, mining, infecting users' devices, and
инструмент монетизации на фронтенда.
black SEO.
Бизнес любит деньги, да, считать.
For business, we have financial harms, loss of profits, litigation, reputation, personal data fines, and other regulators, central bank, GDPR. And then we add specific implementations that can be used. Sniffers, cookies, 25 attacks like that.
И отдельно угрозы несоответствия требованиям.
And then we have unsecure configurations or code development. Non-compliance is part of this. By vector, we have types. We supplement them with specific scenarios, of which there are more than 30.
К внедрению вредоносного кода
And then this all flows into a specific vector. It's our flowchart like this. Vectors, technical entry points, implementations, and impacts. Let's classify British Airways case under this model.
внедрен вредоносный код
Web server was compromised,
персональных данных. Для компании
malicious code, sniffer, personal data. For the company, it's financial losses, foregone profits, fines, criminal investigation, regulatory pressure.
То есть слепая зона, возможность динамического импорта кода в рантайме браузера.
Again, as a blind spot that imports elements dynamically in the browser, we will have to mitigate not just the vectors, but the impacts as well.
Все-таки может все это просочиться, да, к нам.
You cannot always address it through vectors.
90% митигации
Again, 90% of mitigation is done through observability.
Причем до релиза мы должны это пытаться обнаружить сразу
You need to do this before release,
и в любой момент после релиза.
post-release,
Если, например, будет
as you committed to prod, and after.
и там будет прописано,
If there is some backdoor in a transitive dependency, if there is a trigger,
да, то есть триггер по дате.
it can be executed after 2 months.
После релиза.
So you'll not be able to see it on release or right after.
На всем жизненном цикле его.
So you'll have to monitor your apps throughout their life cycle.
Для этого, чтобы было удобно работать, мы вектора
To make it more convenient,
последствия объединили в одну таблицу, с этим
we matched the vectors and the impacts in one table.
оценки риски, меры митигации.
We used our expert judgment to evaluate the risks, suggest mitigations, and then as an output, you can get an action plan to address all these threats,
Сейчас упаковываем,
expending minimal resources.
можно будет прямо зайти
We are repackaging this as an online tool.
в приложение и на выходе получить готовую
You can provide a brief description of your app and receive a threat model.
Поэтому подпишитесь,
It will be announced in 2 weeks on my Telegram channel, FrontSecOps.
собственно, что делать, как выполнять
Once we've dealt with threats, you come to the question of observability, how to detect them and mitigate them, again, at all stages of the app's lifecycle. Let's first compare against the classical security tools. You can refer to my previous presentations. I'll not go into too many details here. Why front-end doesn't marry too well with those. I'll just cite OWASP. Third-party JavaScript code can be expanded with new functionality at any time, so any testing that was done before production lacks validity, including IIST, SAST, and DAST. And then I'll also cite PCI DSS 4.0.1, which says that the only place where you can identify the changes in malicious activity is the user's browser, where the page is fully compiled and all of the JavaScript code has been executed. That's how fast tools work, front-end application security testing, because they run in the browser, and then you need to go through use cases and analyze behaviors. For example, if it's a sniffer, they would engage only as you click pay. They do not engage as you open and load the page.
Вы ему прописываете сценарий взаимодействия с вашим фронтенд-приложением, он его автоматизированно выполняет, и в процессе этого выполнения на контентном слое браузера он собирает профиль поведения.
So it connects to the application and develops the process of interaction, and it looks for sensitive data, personal data, critical data. All that is a profile. Behavior profile. There is a white list what is allowed, and if subsequent scan confirms that any deviation is an incident. So there are no false false positives. If something is wrong, it's the incident or a big change or in the logic which should have been agreed upon. If data went to a different host, which wasn't the destination before. Front-end applications today is an important target for intruders, which provides them with real monetization. So we have to ask a question: am I sure what my front-end application is doing right now? What is it going to do this night, for instance? You can develop, with the help of our service, a threat model for that application, and observability will be supported. It will monitor and support the application behavior in testing and in production. You can use ClusterFast Analyzer for that. When I looked at the result of our research, I make fast analyzers very well, but when I saw the result, I saw a picture in my head. This picture. Of course, I don't want to degrade all other areas, but the intruder attacks the weakest point. If your back ends are properly protected, but the front end is not properly protected, so the intruder will target your front end. Don't forget about front end. Security should be everywhere. These are the links to my previous reports, and I have a Telegram channel, FrontSecOps. In 2 weeks, we're going to publish the service for threat modeling, as well as full-scale results of our research. And we also discuss practices and incidents and so on. At this point, I complete my presentation. I'm ready to answer your questions, please. Thank you. Now, it's time for questions and answers. Hello. Thank you very much for your presentation. The question is like this. Apart from front-end application security, what about host-based security tools? Can they help? Which will be installed from host to the user machine. If we talk about usual internet users, no, we cannot affect them. If you talk about enterprise users, then it depends on the vector. If the front end generates an Office document with exploit,
Ну, взорвется эксплойт, если у вас стоит там XDR.
if there is a certain exploit, so the antivirus, enterprise-based antivirus could help. If it goes to the workstation, then XDR can help. Front-end phishing, if a person clicks to some link and then the attack will be channeled through another route, the host wouldn't help. If I got you right, the problem can be split into two parts. One is about the code interpreted by the browser, and second, vulnerabilities of the browser. So your analyzer solves the first part of the problem. Browser vulnerabilities is only one of numerous methods of monetization for hackers. So we disclose anomalies as early as possible at secure by design level or in production when we see what external services are doing. If you look at the incidents that we know, the code was there for 3 months, for 8 months, you'll get the result in an hour. You announced the threats in your research. What are the mitigating measures for browser vulnerabilities? We detect anomalies at front end, fix it, and prevent repetition at other user machines. Hi. In evaluating applications, DVO were quite different. Did you try to make a research without them? Well, on average, we had 39. All of them 30 to 35, DVO 77. If you eliminate 77, it will be about 33, because that was the average for everybody else. Yes, but in reality, everything is worse. Yes, that's true. These are huge companies with security departments. If you take Runet, everything is worse.
Привет, спасибо за доклад.
Hi, thank you for the presentation. If I got you right, PASP is a dynamic analysis using the existing scenarios. So there are certain conditions which trigger reactions. But if something is not planned, then you can... What about statistical analysis when we deploy all kind of dependencies and see the code which is executed and find the branches which are not described by the scenario? FASP is a dynamic analysis, because it works with a ready-made application. One of the entities of behavior is inventory of the element, full inventory of all scripts, including dynamically executed. SASP, no, because it has problems with JavaScript. XHR, for instance, for sending data for external hosts. In JavaScript, you can invoke a certain entity without naming it. You can... So SASP is not very efficient here. It's better to use not the code, but the behavior rather, and we'll find what we need. What about delayed triggers? FASP web API, save timeout, save interval. Even if malicious code is not launched right now, we shall see the anomaly because of the new triggers, new set intervals, and so on. Okay, thank you. Michael, hello. Before asking a question, there is one comment. You analyzed 3,100 front-end applications. What is the percentage of authorized ones? Well, we analyzed only public pages, one page. If it's a personal cabinet, we regarded only the entry page, no more. So it's entry plus DBO. Then the question, is it so important to protect front end of the SME applications where you cannot steal anything, maybe an additional media applications, mass media applications, what can be wrong here? You can skip it. Well, medical applications, okay. The insurance policy, okay. Yes. What about media? They are not specialized on user data. Well, you have to protect everything. Otherwise, it's an irresponsible approach. For example, there is a certain media site, 100,000 people go there, there is an exploit there, and 100,000 people a day will get the malicious code. This is not acceptable. It may be any side. We have to protect our reputation and protect users in all cases. That's important. So, of course, you can attach 10 security guards to each and every person, but is it feasible? No, I don't agree with you. Why 10 security persons? It depends on the cost. Security guard is a great cost, it's a great resource, but if you just monitor something, so it's not as important, as costly. You announced your tool as a tool for analysis of public services, talking about enterprise services. Enterprises with web for internal users would use your tool. It would be interesting for them. Then talking about web, which is available to a limited number of users, are you going to offer your service to enterprise customers with interface inside the perimeter and outside? Well, we had a research for public applications, but the product is local. It's an on-premise tool. If you are an enterprise, you can scan your internal network within your perimeter. It's a critical for enterprises. It's a tool for them. Hi, thank you for the interesting presentation about front-end applications. We talked about JavaScript, which contains 99% of vulnerabilities, templates that we have to clean the comment. What is my question? CSS becomes more and more functional, and is it one more blind zone which can be used to break the front end? Yes, you are right. CSS, JavaScript, browser is growing, ever-growing attack surface. CSS, JavaScript fast closes all problems of the front end, because if an intruder tries to keep the data from the bank card through a style in get parameter, Fast uses CSS as well at the content layer. It will fix the intruder in all kind of attacks. WebAssembler and all new things are taken into account. Hi. Yes, I wanted to ask you about scripts connected, published scripts. So Google Analytics, we have to delete it now. But do we have such external scripts with risks in PDN? Do you have any register so that we could, from time to time, check the scripts, that this script is bad and don't use it anymore, delete it from applications? No, we don't have such a register, but Fast Analyzer will show you the geography. You will see where the host is located, in which country. If it's a foreign service, pay attention, go to developers. Is it legitimate or not? Maybe you have a malicious code already operating. Well, we're thinking about a blacklist. We're talking about interaction with the antivirus supplier, so that fast after detection would put the script into the blacklist. But not yet. We don't have it now. So you promote your product, but do you have any open source solutions that could conveniently collect information about all connected scripts and analyze it? No, we don't have it in open source. In open source, we'll have a framework for threat modeling. We'll make it public. Then, what you will have in Telegram, will that be free? Threat modeling service will be free, and PDF results of analysis will be published. Thank you. Hi, thank you for the presentation. Is it true? Is it correct to send personal data there, or are they depersonalized? We're not going deeper because very often data in base64 can be shelled or encrypted. Some services collect a lot of data. We didn't go as deep. Roskomnadzor and GDPR collect data about user behavior, behavior profile, with some identifier like browser printer IP address in GDPR. It's personal data, which is maximally restricted. Hi, thanks for the presentation. Please tell me, are there any recommendations? Is it a fantasy? When a script tries, JavaScript at the front end tries to invoke dependencies, and the site provides those dependencies depending on geolocation of the end user. Have you got such cases, or did you regard such situations? Can you comment? In principle, yes, we had such a model. We have geolocation JavaScript, or you can look at the time zone. Time zone, that's an approximate region, Moscow region, for example, and then dynamically upload the script. It's easy. That's clear. The idea is that we can bypass this analyzer by using a blacklist. Well, in principle, we can do it, but we shall have a trigger there, a certain function, region or time zone, IP address. Well, if we talk about a front end, if geolocation will be provided by external. This is not front end, this is already back end. If you have a malicious code in back end, then yes. So it depends on the provider. The question is how the front-end script could understand who the provider is. For example, we call from a certain address, and a remote address looks at it and says, this is IP address of a bank, for example. And we can provide dependency which relates to a bank. It's front-end plus back-end. Is that right? Well, it's not our back-end, it's back-end of the provider. If back-end is also compromised, yes, it's possible. No, not us, it's the provider. If we send good script, unchanged, but it is connected to external dependence. And the external dependencies depend on geolocation. Well, I got you. So the provider somewhere inserts additional code in the script. Yes, if fast is tuned from the side, he will not get such scripts. And you can use control of integrity control. Well, integrity control. Fast can well be complemented by CSP. CSP is good. If you use it 100%, not 70%, but 100%, it reduces risks quite significantly. Use it, please. Well, are there any more questions? Did you choose the best one? That young man over there. Please come here and get your prize. Well, I have a question to you. The question is like this. You told us about PAST, about threat modeling. Tell me the most interesting thing you found at the front end, something wow, without naming the provider. We had an interesting case in my personal practice. Before AppSec, I was a usual IT person. In AWASP, it's called excessive data disclosure. There was a personal cabinet, and the person had several layers of support of identity. First, by phone number. If the phone number is the same as in the client base, then you go to his page. Then, if the user came to the office, there was the next level. Additional data was required, and developers were lazy enough to create different IPs with different data level. And even the first one with a phone number sent all the data of that customer, passport data, sales data. No, I was wrong. Not the phone number, the birth date. If you got the birth date right, you got all the data. We took a group in contact with the customers, and we parsed full name and birth date and wrote a script which took the name, surname, date, month, and in one night we collected passport data of tens of thousands of people. So then we added additional authorization levels and closed the gap. So you have to look at what developers give to the front end, because sometimes they are lazy. Thank you. In my practice, I had a story when I saw JSON and all the data, including PDM. Yes, it happened. Although, actually, I needed 3 parameters only, but they gave me everything they had. Thank you very much indeed. Let us thank the speaker. Then, and let's make a short 5-minute break. потихоньку двигаемся, потихоньку двигаемся.
Ну и, соответственно, для тех, кто оставит обратную связь.
Well, for those who left feedback after the presentation, they will have a chance to win interesting prizes from the Peter Publishing House. On May 24, on Saturday, in the territory of this conference, we'll have 3 workshops. Various interesting activities where you can practice in DevSec, DevSecOps, look at the agenda, look at the program. No registration is required. Just come and do whatever is necessary. You will see what else you need apart from your notebook, and you will learn a lot of interesting things. Let us move on. The next presentation is a story when you have to protect
The next presentation
API,
is
how to
on
protect
API security.
Andrei Kuznetsov
Presented by
will
Andrei
tell you,
Kuznetsov
Yandex
of
Cloud
Yandex Cloud,
architect,
an
you are
architect.
welcome.
Please come up on stage. Andrei, by the way, is the winner of Hubbard's publication contest. Thank you for the warm introduction. Hi, everybody. Let's start. My name is Andrei. I do work as an architect at Yandex Cloud, and my professional interests focus on authentication, API, security around all of that, identity management, and all. I research this, I do publications, I have a Telegram channel on authentication and other things, API. We'll be speaking about API gateway, access tokens, and how to make them secure. We'll review approaches on managing access tokens in API gateway, what they are, how they can be, what the differences are. We'll speak about the required restrictions for the tokens and how to achieve implementation of these restrictions. We'll see how API gateway can be helpful in this regard. The systems are distributed now. There are many services, and it makes our security tasks more complex, including authentication and access control. This is not just login and password and issuing session IDs that you then call for or request. Requests can be different, by the way. Requirements to requests differ too, including InfoSec requirements. You need to navigate all this, and there are approaches for that. Different approaches differ. There are ups and downs, pros and cons, that translate into risks that you need to mind. To manage a risk, you need to first identify it. Let's also assume, for the purposes of today, that we use OAuth 2 for tokens. We will not dwell too much on OIDC and will not dwell on back-end for front-end client side too much. Why OAuth? Nobody needs that at all times. It's a framework to delegate access, including through access tokens. It's an important point for today. You'll need to see who gets issued a token and who then asks for it. Key definitions from OAuth allow us to dive deeper into approaches as they are without getting caught up in specific implementations. Distributed systems are inviting to different terms from OAuth, different resources and clients. And there are many of those. Let's speak about authentication of external system requests, north-south traffic. We know a procedure for an external authentication can be a user or a system. We have defined receipt of tokens or grant fall, with grant fall. Now we need to integrate with APIs to call or request terminal services. An important example here for today is API Gateway. There are different pros and cons of using this pattern, but for the purposes of today, let's focus on these particular features. API Gateway allows us to segregate perimeters. As you hear perimeters, you might protest and suggest zero trust. These are two different approaches, and you can borrow the best from them. You still remain aware of zero trust, but you have an entry point for internal services. When you need to prevent it from the outside, you need to define the outside, and it will be different in different cases. So this applies to internal networks as well. API Gateway marries nicely with existing API management practices. We can automate checks and deliveries of APIs. This is publication of them to specific gateways. For different interface groups, we can ensure that there are required authentication procedures and authorization checks. In this regard, I should say that API Gateway is a nice point to do authentication, because that's where all the requests go to. That's why it's helpful to check tokens there. It's pretty much upstream, where you can screen out unauthenticated requests without forwarding them to actual services. In checking authorization, the preferred approach, where you have your policy enforcement point, PEP, is as close to the end service as possible, so that it cannot be bypassed or sidestepped. This remains valid, but your policy enforcement point doesn't have to be just one. There could be many PEPs. First, rough authorization at the gateway level can be helpful to cut out some invalid requests that arrive to services and provide a safety net, an additional layer of consistent checks. Then you have external entity identity propagation. Identity propagation through API Gateway allows us to pass identities safely for external things. These entities can be users or systems. API Gateway serves as a component to validate external identities and pass information on it to actual services. It ensures integrity and authenticity of information. Using API Gateway enables consistent application of these practices in a diverse landscape at a given company. This is a slide with a book. It's a render, not even a paperback. Quite recently, I mean in March, very recently, they published Cloud Native Authentication Security. They discuss API security architecture there, the authors. They mean secure access to API and the data that's fed through those. This concept relies on three pillars. There are three functions and key components for each. Identity access management is one of the functions, and the component is authorization server. Then you have API management, the component is API Gateway, and then you have entitlement management. The component is the policy engine.
этот слайд. На самом деле мне эта идея очень...
I cite this because this idea resonates deeply with me.
Такие задачи, да, как раз как
It shows clearly that security of API is a comprehensive task, which requires a comprehensive solution. You cannot get away with just one component that is isolated. It needs to be joint orchestrated work of several components. It's a golden nugget of a thought, and I think it will apply nicely to what we'll be discussing. I haven't finished this book, but it's very interesting. It's not as cloud native as it states in the title. It applies to other topics, including those that we'll be discussing today. So do look it up.
к основным подходам к работе с токенами.
So let's review the main approaches to managing access tokens through API gateway. The first approach
так называемого opaque access token.
provides for an opaque access token, where you have introspection at each component.
Получается как RFC, да, 6749 в the OAuth.
We have RFC
Так и спецификация OpenID Connect, они нам не диктуют.
specification and OpenID Connect specification that do not determine the format for access token server.
Да, 7662, который
There is RFC 7662 that defines introspection as a process where there is a component, a resource server, for example, or an API gateway, is used to validate the arriving token. Can be a refresh token as well, for example. There is an introspection endpoint that handles these requests.
Метаданные токены, как правило, его состояние.
The response has metadata,
При проверке
activity, validity, and other things to check access.
клиент изначально получает от authorization server
The client receives an opaque token from the authorization server. It goes to an API,
API gateway идет в
to the gateway.
endpoint у
It calls introspection endpoint.
ответ, выполняет
It receives a response,
на своей стороне, да, и
does the checks and validations, and then passes the request to the end server with the same token.
проверку авторизации у себя.
It does introspection as well on its end.
Ответ, да, допустим, вот introspection endpoint.
Data is the response from the introspection endpoint. This could be a JSON file.
Неплохой, да, у нас access токен обычная
It's a good approach. Access token is a line. There is no GWTs, no complexities that are attached to that. We have two-step checks, and we can assume that information is always current. But there are two calls to the authorization server within one request. It can drive latency and load on the authorization server.
По-хорошему, надо бы подумать о том, чтобы защититься от того, чтобы нам
Another point to consider is protect against a direct request to the service bypassing the gateway. The format is the same, so technically this is feasible.
данного подхода есть и определенные оптимизации, безусловно, да, как раз
There are optimizations to improve this approach.
чтобы сгладить факт
They aim to mitigate this many-step nature of the authorization. You can do caching at different points. You could consider making processing of introspection faster or cheaper.
такой подход, и
I've talked with people who implemented this approach, and they've been able to optimize it to a good degree, and the latency remained within tolerable ranges.
покажу, соответственно, в нем у нас снова есть
The next approach.
access token,
The
при этом
token is again opaque,
на API gateway
but introspection is only done by API gateway.
в виде
Then you have context that's propagated as structured data, unsigned,
или просто какого-то произвольного формата.
a JSON file or some random format. The client receives an opaque token, it calls API gateway, introspection happens, validation happens, and then it's passed to the end server, to the actual server, with some data, not the token. The problem is obvious.
Очень важного конечного сервиса нужно на основании чего
The actual service
доверять.
needs to determine if it could trust the incoming requests.
Аутентичность.
Integrity and authenticity are an issue here. There is no way to check for that.
Любыми данными. И таких
You can get a request with any data,
конечно, может
and
быть несколько.
there are many actors who could
Убирает у нас, да, один вызов
be wanting to do
И
this.
по-прежнему access токен это обычная
We have one less introspection process.
но вот
The token is the same, we don't have GWTs. But you get this extra task of securing trust, and it can be a problem. That information is important. It's used to do access control, after all. So things to consider include prevention of random data requests mimicking API gateway. Next approach. I'm sure many of you are aware, as knowledge and as first-hand experience, the token is always GWT, or, to be precise, it's one of the two manifestations of GWT. It's JSON web signature or encryption. We assume that GWT is the GWS representation. The client gets the token, it goes to gateway, and the same thing goes to the service. The diagram shows that there is no processing by gateway or the end service. The reason for this is that the access token is self-contained as a GWT. It has the information that's needed, and then local or offline check of the signature is carried out, so you don't have to make any requests. The component that validates the token has a public key. Out of the pair, the private key arrives in JWT, asymmetric. The public keys are propagated through the landscape as Jurukarai. It's a popular approach. It's promoted widely. Usually they say that you take GWT and it works like a marvel. It's good for microservices, of course, and then it promises horizontal scaling, as if everybody needed this. But anyway, they tout this approach as extra secure, whatever this means. If you know, do tell. Another important point here, adverts are adverts, but many of these promises will depend on the lifetime of the token. There are no miracles in this world, and the shorter lived is this token, the more requests there will have to be to the authorization server. So this approach is not as valid without adding a refresh token. The lifetime of the token will determine another important parameter, your approach to invalidating the token. Once you issue a GWT, you cannot revoke it easily. It is there by design. So you have to rely on its original lifetime. There is another approach where you have blacklisting. You blacklist the tokens that you want to revoke. There is an idea GWT or GWT. It's in the claim, and the component has to receive the identifier. There is this list that's maintained, assuming those tokens are invalid anymore. If it's blacklisted, the token is not accepted, considered revoked. This means that you presume the token's validity. This means that by default, a token is valid. So the burden of proof is to show the opposite by looking up the blacklist. If there is, for any reason, in this chain of delivery of tokens, there is a component that's malfunctioning for any reason, you might not get that identifier. So the validation component will not get the update that a token has been invalidated. That's what you get from presumption of validity. To improve reliability of detection of such failures, you can have the same chain with half checks, regardless of updates. That's how you verify that the entire chain is live and operational.
Место быть как раз презумпция невалидности. То
You
есть
could also presume invalidity.
валиден, обратно
Any
это-
token is not valid,
обратно, точнее, уже
and you have to prove or show
да, в authorization
that it is
Если authorization
by calling
server нам не
the authorization server. For example, if there is no
мы все равно будем считать,
response, if it's not available,
я предлагаю на нее
the presumption is that it's invalid. I think it's a important distinction.
про который мы с вами говорили. То есть, как и сказал,
Back to the approach.
как бы подход имеет определенные преимущества. То есть, да, для него действительно может
It has some advantages.
общий latency запросов.
You reduce the latency, you reduce the load on the authorization server,
Сервисы как раз таки
you're less dependent on it, so it's better for scaling. You have the gateway and the services handling self-contained GWTs
в какое другое место.
without any additional calls for
На
validation.
самом деле, все-таки есть ряд нюансов, сложностей.
But there is a number of caveats or challenges still.
Времени жизни.
You need to properly set the lifetime of the token.
Для отзыва, для
You need to have a mechanism for invalidation.
токена один и тот же. Если сервис
The format is the same.
напрямую, допустим, даже извне,
If there is direct access to the server, especially from the outside, you can make a request bypassing the gateway.
презумпцию валидности,
Then I've described the presumptions, validity or invalidity,
тоже как бы
can be important for some use cases, so do have this in mind.
в любом случае, да, у нас как бы раскрывает
GWTs
информацию. Может раскрывать ее как бы самим, да, клиент.
disclose some of the information
Здесь будет справедливо.
to the clients or to end users even.
Включаем в состав нашего
But what's important there, we do not
конфиденциальную секретную информацию.
put confidential secrets there.
Нюанс
Good point, valid point.
мы можем как бы раскрыть
However,
информацию как раз таки об устройстве
You can disclose
нашей системы, что
information on the internal design of your system, and it can be used by attackers
устроено. Поэтому
with better visibility into your systems.
и порой это бывает важно. Ну и
Sometimes it's critical.
мы передаем на сторону клиент access токен в виде GWT.
And then
Соответственно,
we give this token to the client as GWT. If it's GWS, the client can look at the payload
из payload GWT.
and reuse the claims.
У нас становится пусть неявным
This means that GWT is, in a way, a contract between the authorization server and the client,
поменять как-то GWT.
an implicit contract, let's say.
Нам придется
If you want to change the GWTs,
ресурс серверов.
you'll have to ensure that it's workable for all the clients, not just the resource servers.
Кстати, на мой взгляд, наиболее
Here's another approach. I think it's the most interesting one. We have two tokens here, a reference token, the opaque one, and then we have the self-contained token. As an example, let's use GWT. The opaque token is just a line.
есть GWT.
The GWT is, well, it's what it is.
У нас клиент изначально
We
получил
have a client
сервер,
who receives an access token from the authorization server. It's an opaque token.
отправляет его в запросе,
That's what it sends in a request
а дальше
to the gateway.
обращается в
But then,
абстрактный security
The gateway
сервис
calls
сервер.
an abstract security token server on the authorization service.
Содержит уже другое представление токена.
I'll get back to it. It receives
API gateway на
a
своей
GWT in response.
проверку данного
The gateway validates it.
Все хорошо, все успешно.
If it's okay,
уже конечному
it
сервису
sends a request to the actual service, replacing the original opaque token with this self-contained GWT. The service gets the GWT, it doesn't have to call anything,
поработать. Что здесь?
and it can handle it on its own.
Такие конечные сервисы у нас будут по-прежнему доверять
Curiously,
authorization server, то есть
the end services only trust the GWT server.
смотрели, помните, подход с
It's a good point that merits discussion. When we looked at one of the approaches where there is no signature,
тоже будем свои GWT
you
формировать,
could
и в них конечным сервисом
generate GWTs at the gateway.
тот подход я бы особо не стал
Could be
рекомендовать.
convenient, but I wouldn't recommend.
Доверительные отношения между
You'll complicate the trust issue. And here you have just one source of trust, the authorization server.
есть непрозрачные подобные токены доступа.
We have opaque tokens on the one hand, and on the other, we have a GWT.
Authorization server в рамках обработки запроса.
And there is just one request to the authorization server.
Открываем возможность прямого вызова конечного
This
сервиса.
prevents direct calls to the service, the actual service, even if it's exposed.
Без прохода через API gateway
The
подобное
reason for this is that without going through the gateway, you cannot receive the GWT, and the actual service will not be able to process the opaque type of token.
Вижу действительно определенные преимущества. Ну, конечно, когда как бы без...
There are evident advantages in this approach.
Здесь мы разделяем, как сказал, токены на условно внешние и
We have two types of tokens, external and internal, let's say, and our internal GWTs can be restricted.
разделяем на самом деле два представления токена.
This segregates
Два разных токена.
two representations of tokens. These are basically two different tokens. They can have different lifetimes,
Это нам позволяет сделать внутренний
and we should,
максимально короткоживущим. А еще
because
отдельно
we can set
воздействие. Про это
internal GWTs
поговорим. Ну, собственно, внешний токен, да,
as very short-lived and restrict its application.
это нам будет удобно для того, чтобы мы могли как раз-таки решать задачу.
It's a separate line. We can make it
Клиент в этом случае
stateful, for example, to invalidate them.
не получает и
That's the external token.
его
The client
при этом не будет.
doesn't receive GWT, so they cannot misuse it.
Работаем с GVT, и как бы в этой
At
части
the end services, we handle GWTs,
их используем.
and
Ну, конечно,
it comes with all the advantages from them.
более сложным, более трудоемким, да, нежели
This approach can be more labor-intensive, more complex,
из коробки. Ну и здесь у нас
so
остается некоторое
it's not always available out of the box.
latency, да, за счет как раз
And then it impacts latency negatively because you have an additional call to the authorization server.
зависимости подписи
And GWT
алгоритма.
signatures,
Данного подхода
depending on the algorithm, can be checked
стерилизации. Ну, сначала давайте
slowly.
обещали, да, расскажем про security.
Let's discuss STS
Известный как
first, and then we'll speak about implementations.
валидировать пришедших к нему на вход
Security token service can validate incoming tokens and issue other tokens based on that.
между различными доменами
This
безопасности
allows you to
в, так сказать, средах.
handle accounts and credentials across different landscapes and heterogeneous
Может быть реализован
environments.
в виде прям отдельного какого-то сервиса.
You need an access token. It doesn't have to be a separate service.
У нас
It can be part of the service
сервер.
that does
Теперь как раз
authorizations.
реализацию. То есть детали реализации, конечно,
And now on to implementations.
актуально такой подход.
Your mileage may vary in terms of details,
С помощью token introspection,
but
token
conceptually, you'd have either introspection or exchange of tokens.
introspection. Мы же недавно про нее говорили.
How do you do introspection of tokens?
Здесь, знаете, как
It
в
doesn't
анекдоте, где
require
предположение
GWTs.
Сейчас все объясню.
But then again,
Собственно,
let me explain.
такой
Bear with
подход,
me.
вот буквально в начале этого года он получил статус RFC.
Just this year, this approach was codified as RFC, where you have GWT response to OAuth token introspection. Here is an example. You have introspection request. It has a separate header that tells the server, the authorization server, that it expects to receive a signed GWT.
Как раз-таки authorization server
So then you see that the response
уже обернутым в GVT.
contains an introspection endpoint response packaged as a GWT. There is a IAM
Именно для решения
solution
задачи, про которую
where
мы
this is implemented to address, well, the topic at hand that we are discussing.
на стадии черновика. Но
It used to be implemented before, when it was the draft, but
тонкость.
not the point.
Да, мы, с одной
Here
стороны,
is-
отправляем запрос, authorization
Here is the
server,
catch.
передаем
We
непрозрачный
have a request to authorization server,
но стоит подумать.
send something opaque, we receive a GWT, but what's in it? There are different GWTs.
Но обернутый
It's
внутрь
a response,
подписанный authorization server.
an introspection response, packaged as a GWT and signed. It's not an access token per se.
Жизни по области действия.
It doesn't have a lifetime, doesn't have its
Но все-таки
scope of
применимость
application.
меньшую для решения такой задачи. Вот если
It's
интересно,
a valid approach still, but not as broadly.
как раз-таки решение
You can look it up.
предлагают
It's called Purity,
использовать. Но,
Purity.
как сказали, да, есть еще и другой.
available online.
Опирающийся на
But then we have token exchange, another means to achieve that. RFC 8693 or analogous
мы получаем
but not standardized approaches.
другого, да, то есть
We have just one token
такой токен, мы его можем
based
отдельно ограничить,
on the other, issued on the basis of the other.
как бы тоже нам это
Can be restricted in all the necessary ways
Итак,
as is provided for in GWT.
резюмируем. Мы с вами посмотрели, да, на разные
Let
такие
me
основные
recap
подходы
first.
по работе
We've reviewed the main
с
approaches
доступом при использовании API
in
Gateway.
dealing with access tokens
Существуют и различные другие
as
вариации.
applies to API gateway.
Подход называют его
There are different permutations of this.
Значит, там придумали,
like split
придумали
tokens.
GVT,
Just imagine they take a GWT,
payload,
header, payload, signature. They take the signature and they make it into a reference token. The client has it. It calls API gateway with this, and the gateway stores the header and the payload. They then merge it. That gives you a proper GWT, just like in Power Rangers, which goes to the actual service. So there are variations, but I think we've reviewed the main abstractions. How to view these abstractions or approaches? I prefer where you have two different tokens, if security is key, if security is critical. Yes, you can have opaque tokens with introspection at each stage, or you can have GWT tokens, but you'll have to do some additional work. As for the approach, where you propagate the context as structural data but unsigned, I think that it's obsolete. I've shown you a demonstration, but I wouldn't recommend it for production-ready systems. These approaches are all useful. It's something to know, to be based, but is this enough?
Let us think about secure usage of access tokens as such. So sometimes it happens that we have a task of protecting access token against unauthorized use and reuse, replay attacks. Access token has certain temporal data, valid data, because if they leak, it's not important what kind of authentication factors we had and how the client was authentified. The intruder can act on behalf of the user within the framework's life cycle and area of usage. So I can tell you that leakage can happen not only outside when all the evil is concentrated, but inside as well, at the resource server itself. I can say that mitigating such a risk is important, and we can have three areas there. Protection against the leakage itself, protection against the reuse of token by illegitimate intruder, and limitation of the usage zone of the token through audience, through certain resources. I can tell you that complex measures should not be limited to one of these three areas. We can look at the third area in greater detail. What is the problem here? Look, if the same token can be used for access to any API, it brings about a risk of building a super token with unlimited area of usage. Then there is a question: how can we take an abstract token and create a limited token so that it cannot be used in unauthorized areas? So we talk about scope and audience. For scopes, what kind of access the authorized token can have? It's not the identity of resource. Scopes can be used for dividing resources, distributing resources, but it is not always convenient for operation. Let's look at the audience. For that, there was an approach which we had in RFC 8707, resource indicators for OAuth 2.0, which limits the area of access token by a list of resources.
Соответственно, опять же, посмотрим на небольшой пример. Здесь у нас...
Let's look at the example. In the authorization request, we have a special parameter, resource, which can be used, and the same parameter can be added to token request. Why? For example, the user authorized access, and we want to have limited access, and we can say resource is here and limit the area of such token. Good approach, interesting approach, but it doesn't solve the problem to the end. The client gets only one access token, which should include all the necessary scopes and resources which are necessary for the application. That is good, but such a token, as we saw, can go not only through Pigitway, which is centralized, but it will go to the final services as well. And those services can provide it access to something else. We have certain limitation that is good, but this limitation is not always sufficient. And the teams might use such access token for access to something else with good intentions. Maybe you can start solving this problem by providing different tokens for access to different resources. This approach is possible if the client has BFA in AUF. For example, we have a server component where you have a refresh token with full area of activity. When we have a request, it will get a limited access token with only one scope for one resource. And then it will go to the service. Everything seems to be all right. The most privileged token will stay as it is without leaving its location, but we need a server location which all services should go through. This is not always feasible. Such limitations are used when the request reaches the server area. Outside, there were some general purpose session ideas. Otherwise, we don't know how the application will work at all without that. We can think about it, but let us think about how to develop the original idea. The idea is good, valid. Maybe it has some points for optimization, and we go to a Pigitway. In the schemes, a Pigitway had some calls to authorization server, and simultaneously it can make changes. If we know where to send the request, let us limit the request powers, the request limits. I'll show you the example with two tokens. It can always be used with introspection schemes. With GVT, it's worse because it gets other calls and it's not as interesting in this case. We have a certain client which is not shown here. He gets an access token for a number of scopes and resources. It goes to a Pigitway, and the Pigitway goes to the server to get access. It indicates a scope and the resource which are needed to process this request. It's necessary to note that in this case, it's very good for a Pigitway to confirm its authentication, so that the authorization service we can control access. So no random party can go and exchange tokens. If everything is okay, then authorization server sends the GVT access token. It was down-scoped. It had limited scope, limited resources because of the audience. A Pigitway validates GVT and sends it to the end service because it replaces it for the initial non-transparent token. It goes to the final service, and the final service checks the authentication, and the token is down-scoped, and it can act only within the area which is necessary for this operation. It's important to point authorization server should be sure that he downscopes and not upscopes the area. For example, we have the all scope zone, all resource zone. It's shown. There are some smaller zones, non-transparent token, blue, and the smallest one for the final token. We have downscoping 1 and 2. However, there is a logical question. How Epic Gateway could know what kind of resources and scopes are necessary for this particular request? Let's recall that we mentioned API publications. Who knows that? Final services. They are API owners. When you publish APIs, API management, route to APIs, they can also indicate necessary resources and scopes for different services and work with them. Also, the access token and the request from the access token, which tries to get access to unauthorized resources, will not get such resources. Look, the idea of using scopes in this way is not new. However, scopes are not always used, and they are not always well used. They are not always consistent. No matter how useful it is useful, but you cannot start using scopes and use it everywhere. It may be complex and it take a long time. This approach can be simplified if you have management of resources, and you can apply scoping, and it can improve the general situation. If you have audience for all services, you can downscope it by improving security. One API gateway is not sufficient. No matter what we write, if no one is going to use them, you will have no effect. We have to check not only API gateway, but at the level of each final service. We need recommendations and libraries. In this approach, we said that we have requests to authorization server, and we can think that for some loaded APIs, it can be important. Well, what about caching API gateway? The life cycle of the token can be small, and the scope is limited. And I see a problem here that now we have a place where a lot of access tokens are stored. If such storage is compromised, then you can have a large-scale leak of the tokens. So this is a risk. You have to mitigate that risk by a short life cycle, by limited scope, but still this problem does exist. Now let us finalize what we talked about. We discussed the usage of API gateways, which might be useful to solve the problem of secure access to tokens. We looked at different approaches to access tokens, how different they are from each other. We spoke why do we need to limit the scope of access tokens. We talked about super tokens and why they are bad, and what we can use with the help of scopes and audience with a list of resources. And we also say how we can use API gateway for additional limitation of access tokens. And to conclude, I want to say that the approaches that I mentioned can be complex and they can reduce the speed, they can reduce performance. But I believe we need to optimize this process rather than focus on insecure by design solutions. So this is the end of my presentation. You can write to me in Telegram. You can subscribe to my Telegram channel where I write about authentication and not only, and you can also evaluate my presentation and leave your feedback, which is quite useful. That's all for me for today. Thank you for attention. I am ready for your questions. Thank you, Andrei. Thank you.
Коллеги,
An excellent presentation. Now, colleagues, ask your questions into the microphone. I see hands rising, but please go to the microphone and ask your questions there. Hi, Andrei. Thank you for the presentation. It was technically difficult. It's difficult to analyze it at once, but I would like to focus on the problem of checking the verification of access rights. Can you specify so we can have scopes and claims into the token which define the access rights of the user? Yes? There are two approaches. We can put them into the token, or we can use an attributive model of access provisioning. We can provide access on additional elements like TP, decision points, and manage access dynamically through ABAC. Which of the options is better? What is better, to put access information into the token or use additional points with dynamic management? Expansion, downloading, downsizing, upsizing. Did you compare these two approaches and what are the benefits and of each of them? Well, these approaches are not contradictory, and I didn't tell you about detailed verification. I was only talking about tokens, scopes of the tokens, resources of the token for initial authorization, and you can use that for initial rough authorization. We're not going to validate if a certain subject can perform such operation. No, we just check the token, whether it can be used for this purpose or not. Authorization in general, it's a big question and you can complement it. So it's a rough filter. Yes, looks like that, as part of the more complex solutions. So they can complement each other, these two things. Hi, thanks for the presentation. You told us about authorization from API Gateway Resource Server, from scopes. What about authorization between client and API Gateway? How can we be sure that the client can get access? Is it the inter-service relations? Yes, GVT token scope. You authorize a specific token to the resource server, but each customer can make any request to any part of the API gateway, and your token can get access to any part of the gateway. Well, we are talking about service to service, or client going to any API, any client to any API. And what is the problem? Actually, when a client goes to API gateway, there is no authorization check, and you can send with the token anything. Between client and API gateway, you cannot record anything. how do you check that the customer addresses the area of API gateway that he is authorized? How do you check the authorization here? I am trying to understand you. The concept is not well understood. Well, let's put it this way. The client has access token. What is an access token? On his behalf, on behalf of the user, it gets some powers. It goes to a certain API through API gateway and gets to the final service. At the API gateway, what can we check? We can check the destination. Is the API, is the token authorized to go to the that API? I don't see any problem here. In any case, you check the scope. When you go to API gateway, no, it's access to a resource. We can filter out invalid requests at an earlier stage, but we do not eliminate any other authorizations and authentication tools and methods. Thank you. If you have more questions, please come to me offline. Hi, Andrei. Thanks for the presentation. My question is like this. We talked about access to API gateway from outside. What about services? Services also address each other. Are they going via API gateway, or can they do it directly, and how to do it securely? Well, I thought about that. A question. I was expecting it. Service-to-service interaction is another subject. I didn't include it here. That is a separate, interesting task which requires its solution. Yes, service-to-service interaction. In some cases, we can go through API gateway, but this is an overkill, and you can go directly. What about access control? What about request authentication? You can have client credentials. You can use long life certificates. Pluses and minuses are there. The SPIFFE is another for short-term certificates. And so there are different approaches, but it's a big subject and out of scope of my presentation. It's an important question, but I didn't touch upon it. Yes, that is a problem, and it's very important, really. Hi. This year, we started installing the gateway, our own gateway, in-house developed, and we see the teams that reject it because they don't see the problem, which cannot be solved by Nginx. How to convince them to use the gateway? Two things. Do I have the time? Yes, you do. Now, first, what is API gateway? So there is a certain component which implements this factor. Nginx and API gateway, I don't see any link here. You can use Nginx as API gateway. API gateway is a function. You can install that functions everywhere. You can use even Lua. It's your choice. You had lightweight Nginx. I don't know your specific situation. I am just talking in general. You have to look at your specific in general. If you use an API gateway, you have to have certain reasons for that, certain functions that API gateway has, that it can add to your infrastructure. It can solve the problems which different teams face, monitoring, multi-layer security, it can solve part of the problem and take the responsibility for such solutions. There is no universal solution. You have to understand why do we need API gateway, what for, and how do you implement it? Well, it's up to you. It's useful, it's convenient.
Добрый день, Андрей. Спасибо большое.
Hi, Andrei. Thanks for the presentation. My question is like this. We have API gateway, the service. We limit the scopes of the token for addressing this service. In this scheme, who guarantees that the configuration, the final configuration of the service and the API gateway would match each other, so that in the server we couldn't have expanded scope, expanded rights to get tokens from other services? Well, the token is valid. You check it. Yes, it is. Okay. It's authentic. Okay, it will do everything. But who is responsible for the overall configuration of API gateway and the final access point, so that they would confirm the configuration? Well, if I got you right, let me tell you this. Well, I guess I had an example with API specifications. If the service publishes the API, then the service is responsible for that. The service is in charge. As for verification is concerned, who is responsible? Everyone is responsible in different scope. API can roughly check for authorization, but you shouldn't rely on it 100%. We shouldn't trust everyone. We should trust, but recheck if necessary. Even if API gateway passes this token through, then each service should recheck it. Everyone is responsible. Did I answer your question? Yes, you did. There are different teams. Consistency. We have one team which is responsible for API gateway and another team who is responsible for the service. And through specifications, someone has to ensure consistency so that these two teams operate in conformity with each other, especially when specifications are updated. If I got you right, I look at such tasks in the following way. It's API management in the company. If you have no API management at the enterprise, if it's a transparent gateway, it wouldn't work. If you work with API, if you have standardization and specifications, if you cannot use any handle, you have to publish it, you have to be authorized, then these tasks they belong to API management at the enterprise. It's a higher level. Sorry. Let us continue discussion offline. Unfortunately, time is up. Andrei, thank you very much indeed. Let us thank the speaker. Evaluate the presentation. Don't forget to send your feedback. And as for me, Andrei, thank you. As for me, I want to say goodbye. We're going to change the speaker and change the moderator. What about the best question? We're going to choose the best question now. I think that's all over. What is the best question? That person over there. Please come to the podium and get the best, get your prize. The next moderator is Alexander Trifonov, my colleague, head of application security.
Всем привет.
Hi, everyone. So, are you ready for the next presentation? We have Alexey Vishnyakov next. He will talk about contemporary challenges to security of cloud services. But we need a microphone for that.
Привет, прошу.
Hi, you're welcome.
Всем привет. Меня Лёша.
Hi, everyone. I'm Alexey Vishnyakov, and I'm going to tell you about building security development in the cloud, how we solve the problem, what kind of problems we see. Maybe it will help other companies to avoid problems and maybe reduce the workload. I am head of the secure development in Yandex Cloud. I'm responsible for everything related to that. I was educated in the Moscow State University, and I am candidate of science, PhD in computer security. I'm a maintainer of outsourced instruments like RobGadget and Castor. We have links. You can go there and see, and I will be happy. Actually, the number of vulnerabilities grows with each passing day and year. These are the numbers of vulnerabilities. We have more and more every year. There was a report from Bagdak. It was called CIMACT before. Out of 86% of the 86 programs, they found at least one vulnerability. Secure development helps us to detect errors before deployment and avoid critical consequences for enterprises. Secure development is a standard of the industry. You saw that in Microsoft Windows XP. Actually, SDLs were there. Microsoft realized that we can do something about it and started creating
got around
reports.
to this and implemented this crash report. Leaping a bit forward, the article on deduplication of crashes inspired us in our fuzzing research. Then there are other companies who started working on this. There are ISO standards, there are GOS standards in Russia. In 2024, a new standard was published in Russia for secure development, describing specific methods for analyzing code. The main idea of this presentation is to share our experience in ensuring secure development, to present some new approaches that haven't been discussed yet, and to provide some practical advice on how to avoid errors. We'll start with the requirements, how we standardize our security pipelines, how we monitor the health of the process. We'll discuss our optimization efforts to release developers. We'll speak a bit about our research of SAST, automation of fuzzing. Closer to the end, we'll be looking at SBOMs to automate incident reporting. We'll also speak about the future at the end of the presentation. Here are the requirements as we have them in the company. There are three basic documents for this. Cloud Security Baseline. It's a list of requirement wordings. We have cloud regulations for IT security processes as applied to the cloud. And then we have the Security Cookbook. It provides technical recommendations on how to implement this through engineering. First, we have the security baseline. That's the one source for all security requirements, including secure development. It's a handy checklist for you to apply to your activities. It's structured like a standard. It has requirements, acceptable actions, and recommendations, things that are not mandatory, but that improve your software security. Requirements are broken down into different stages: training, architecture, security, external dependencies, build, testing, deployment, vulnerability scanning, SAST, test. And we have a lot of open source softwares, and we monitor those in our cloud as well, because these are the same services that we deploy in our production. This is for your motivation. The rule of two, I borrowed it from Chromium website. That's where you can use C, C++ and other vulnerable languages. You cannot have the overlap of three against the rule of two: unsecure language, untrusted user entry, and high privileges. That's a straight path to RCE. Here are some examples, pretty much copy-pasted from our security baseline. You can recognize the standards language. A developer shall do this and that. In versions control, for example, you have to have a review, a CI step. The CI has to be described as infrastructure as code and be reviewed in its turn as well. No secrets, no personal data to be included. Requirements to builds, static links, hardenings for your compilers, remove debugging information, no passwords or secrets. Once again, the builds shouldn't have access to the internet, and config changes shall be reviewed as well. Then there are requirements to deployment. For example, you can only deploy from release branches, not from debugging. All images should be within the cloud. Any databases or images should be mirrored, not call from Ubuntu, containerize, and all. Compliance management. We have automated checks, scans, quality gates, CI, CIEM, where we get alerts from. Then we have configuration, rules for code review, ACL, IAC. Then we have manual security audits that's applied to all new services and features. And then there are regular internal compliance audits. These are spot checks across different services to ensure compliance with the requirements that cannot be automated. Here is the composition of the audit. We have security engineers who look at the architecture, the roles, the data flows, threat modeling, as we've heard today. We do it in a simpler way, something more akin to Stride, and our models are standardized. Identification of the attack surface and fuzzing functions. There is a manual code review, pull requests, diffs, a bit of manual work. At the end, you formalize an observations list, changes to be implemented. It's done through iterations, and at some point, the feature is approved for public release. Our company uses different analyzers. We use SAST for our own code. We use SCA for external dependencies. We do fuzzing. We form software bills of materials. And here is the pipeline. We have voting builds, release builds. The events are twofold, either on release or every night. It triggers SAST, SCA, fuzzing, all passing through quality gates. By quality, it means security here. Then we have bombs for release builds. Artifacts are signed to be added to software builds. All of those pipelines need to be standardized and centralized so that different services do not become a mixed bag. We have centralized scripts for bombs, for gates, or initiation of tools. There are standardized artifact collection forms, which gives us the centralization that is needed to run our pipelines. This reduces the load on operations. We don't have a diverse mix of scripts. There is a single source of truth. All the amendments are introduced through there. Then you have templates for new services to initiate them. The process thus becomes predictable because we have the scripts on hand and we have developed them. And this centralizes security of changes as well. Again, it's a one-stop shop solution in a way. Then you have to constantly monitor the health of this process. Technical operability is included into here as well as quality gates to make sure that all services comply with security requirements. You can plot trends based on this data, number of alerts or triggers per week, per month. You look at the backlog of alerts in SAST and SCA in fuzzing, compliance with licensing, and compliance with quality gates. We have a threshold for criticality, and you have to be below it. It can vary based on the application business or security. We check the workability of each step in the pipelines. We do track the false positives, and we look at the monthly and weekly stats for alerts. Here is how we implemented this. Data Lens is our own cloud service. There is a dashboard for this that displays the metrics. It does snapshots of states daily. We have engineer on duty who looks at the dashboard, looks at the builds, fixes something that's needed or taps a service. There is the vulnerability manager separately as well who looks at the vulnerability and pushes the people who are responsible for tickets. Once we have a dashboard, it was quite obvious to use it to optimize SAST. If you have too many alerts that are not relevant and it's fuzzy or false positive, then it annoys people, annoys developers, and reduces trust. We want to alleviate their workload while maintaining the quality of detection. We've disabled some SAST checkers. Dashboard for false positive per checker. We've looked at the worst offenders. We disabled most of code quality checkers. We've removed reduplication of alerts. But then you still have to always have security checkers. If it's for injection, it can have a higher rate of false positives, but then if it catches something, it's very important. You can refer to the Russian cost standard for security development. It has a list of critical checkers that have to be always on. To the left is our stats before the checker exercise. To the right is half a year after. Our true positive is up from 30 to 61%, and the total number of alerts is lower. It used to be at around 33,000, now it's 7,500. So, quality up, workload for developers down. It's not as easy to calculate the fixed time, but you can calculate triaging. So if it's 15 minutes per ticket, so it's down from 6 to 2 FTEs. We are researching open source statistic analyzers. We want to migrate from heavy-handed enterprise solutions to open source. We want to have more control in SSL/TSC, as we can dig into the code. It's not a black box. We want to keep up with new versions of programming languages. We are keen on cutting-edge toolchains, compilers, and standards at Yandex. Open source usually moves quicker, and they keep in lockstep with the most recent standards. And then again, some vendors are no longer available, so you have to look for alternatives. Our challenges include the diversity of the stack. We have Go, Java, CC, TypeScript, so not all SaaS can compile this out of the box, and this can be additional development effort. Be ready, you wouldn't be able to cover all languages within one SaaS analyzer, and you'll have different ones. Our code base in the repository is really large. Some projects have dependencies tying it to like half of the repository, and the analyzer must be able to handle that. Here are our criteria for selecting SaaS analyzers. The quality should be on par with what we have. It needs to be able to do cross-validation with other analyzers, and we look at the maintainers. Microsoft, FAANG has to have a community around it with active contributors, a lot of commits, implementations, stars. Then we cross-check it with our Russian cost standard. It has to support the prescribed list of checkers. It's always useful when it supports serif standard, so you can integrate different analyzers and output it into a single web interface. It has to be compatible with our existing compiling infrastructure as well. We've reviewed this for the language Go, GoSec and Static Check. These two are complementary. GoSec focuses on vulnerabilities, Static Check focuses on quality, but it's useful for compliance with Russian standard. You can expand it with some additional checkers, and this will give you a full coverage. They all support serif, and they can be ran through lint. Our preferences can shift, so we are looking at multi-language SaaS, CodeQL, sysgrab. It seems to be useful to combine them with sysgrab or HotQL, for example, where you have a set of rules to look for vulnerabilities. There is Infor as well. It can do Java and C++. We're executing the code. Code Checker is also nice. It's available from Ericsson on GitHub. It integrates execution of various useful analyzers or checkers. As a platform, it has a nice web interface. You can do markup there for the results, so it can be easily integrated with different statistical tools. We are studying Swanner Cube, but the paywall is pretty high, and the freeware version is not as capable, so it's probably a no-go. C++ has Cloud Tidy, Cloud Tidy Analyzer. It sounds like a linter, but it includes simple checkers as well, that you don't have a class static analyzer that's for more complex vulnerabilities. It has intermodule and interprocedural analysis, runtime, and other nice features. Integrates nicely with Hot Checker, Code Checker, does aggregation and markup. Not as rosy for Java, spot bugs, Avast.
Все выглядит не очень радужно. Именно по специфичным
параметрам,
возможно, там для Java надо
when we speak in specific analyzers, it's not as great. Maybe Infer or CodeQL is better for Java, a multi-language tool. Specific to JavaScript or TypeScript, we have currently just one option. ESLint plugin security. There is a limited set of rules that you can use. And then, of course, you can apply CodeQL samgrep for this as well. And now on to fuzzing. Any fuzzing starts with the attack surface. The audit reveals the dependencies from the attack surface to the functionality. Functions need to be accessible through an external interface, not necessarily directly. Parsing of input data, and priority increases if it's more easily reachable from the surface. So we use gRPC in the cloud, and that's the high-level interface for us, where we do fuzzing. Archival library is buried much deeper. It's not as high as a priority, but we still do this in terms of reachability. You can do grep by keywords, parse, load, import, read. You look for format parsers. If the function can take a buffer, it's better than complex objects that need to be initialized. And, well, you'd be aware of OSS fuzz if you're doing this. It has a lot of packages, different shells. So you can make use of it. We have two approaches to fuzzing. We can fuzz gRPC handles. We use structure-aware fuzzing and protobuf mutadata, where we generate input data and fuzz the surface. It's labor-intensive, but it's really effective. Then we do fuzzing for specific functions. It's a deeper exercise. We can find some bugs with that, but we usually do a combination of two. Here is what we are preparing for publication. We are cleaning it up technically. We haven't been able to do this for PhD. We've developed a mutator analog for Go. LLM fuzzer test one input is a classical function. Proto messages are passed to fuzz. It's not even on the screen. It's a large handle, self-generated code with a lot of pass-through. There is the custom mutator who calls our library. It mutates the input data to generate new sets. Here is our fuzzing pipeline. We compile the goals or the targets. It's stored at S3 to replicate crashes. We download the set, minimize it, or the corpus. We fuzz it. We store it at S3 in logs. If there are crashes, we deduplicate them. I'll show this a bit later. So we only store new crashes relative to the ports that we already have in S3. This generates tickets for developers. We monitor coverage as well. Fuzzing is configurable. It's in the code almost. Press target, ticket addressing, and then we have crash analysis and severity report. It's an open source tool, Casper, that generates a report for crashes and deduplicates them. So that's what the report looks like. The section of the code, type of error, probability. It supports various programming languages and fuzzers. There was a report a couple years back at Ozone. There is a deep dive into that. So you can use it as well. Deduplication of crashes. We have Casper or Fuzzer as a tool. You run a session and it deduplicates crashes within one run. Reports have stack tracers in JSON format. You download previous reports from S3, you call the diff cluster. It re-uploads back to S3 just the new reports. It's a simple diff based on stack trace. We filter out sanitizers, abors, and other not needed functions, and we make a basic comparison for equivalency. There are approaches where it's clustered, but this bare bones approach seems to work for us. We don't have excessive tickets. Here's a bit of a know-how that we have, how we use SBOMs or CIEM. We have a lot of servers that are being deployed at all times. We want to know what their components are, who built them. Here are two cases. Let's say there is a login library that all services are using. There is a vulnerability. All services have replicated it. We see that services have deployed it as well, and they need to redeploy because the shared library was vulnerable. Or maybe there is Log4j, some other big news, and you need to see what services in production have been affected. We have specific alerts in CIEM. We have files in CI/CD. Developers do not bring in binary code from their personal laptops. We have deploy policies to prevent it from debugging pipelines or personal branches. We scan vulnerabilities ad hoc in production on top of SSL DLC, and we are trying to automate security incident investigations. That's for production, just for the case that I've just laid out. A service built and deployed with a vulnerable library. We are enriching BOMs with Java and Python. It's sent to CIEM, and SOC analysts can use them for investigations and additional data source. Composition analysis is done on build level, but we are trying to develop alerts in CIEM for this as well. We have OS query for file hashes, but we want to migrate to a higher performing tool. We are also developing SBOM generation for C++ based on the repository data. There are hints there for components, there are versions, and the repository has this in it as well, especially for third-party components. Well, you've seen a software bill of materials. It's a JSON. It lists the components. Anything can be a component. The example shows a microservice. It's something in the cloud. It has a component from the library. The library is files, the source code, and it has the hash. CycloneDX from GitHub provides you these BOMs.
еще дополнительная информация.
but we need to enrich it. It's not as informative.
Что за коммит был, какие параметры сборки.
The number of the commit, the build parameters, reference to the build, the packages as artifacts, versions of hash files, the same for Docker containers, including tags and so on.
Можно удобно в формате pedigree записать.
This yes info can be written down as a pedigree, which is very convenient in this BOM. If it doesn't fit in CycloneDX, you have a random feed under properties, so you can state the development branch and so on. For their packages, we look at the packages that you have within the build. We have hashes, enter this into the bill of materials. A bit more complex for Docker. Dive is a bit too heavy. We decided to develop our own code for this. You run Docker events. It has JSON format. It saves all the events. It sees the images, which constitute the artifacts of the build. We look at the pools. The hashes are provided elsewhere, so we do not go there. We save the layers, do hashing for internal files, add this to the bill of materials. Hash of layers, match ID, internals of files, and hashes. We have all the intellects through hash files. We generate and enrich as BOM. It's all uploaded to this special SBOM storage. The to be is to have drag on. So we can only use hash files, cross-check. If it's not present, this file was not compiled or built in CI, so something alien is in production, it's an alert. We are developing the other part, where this can initiate vulnerability scanning, so that it can issue alerts in CIEM for critical vulnerabilities. Then try user lookups on demand. SOC analysts can get a display, for example. Show me a list of all production components that were compiled from this or use that. A bit of forward-looking words. We are all implementing AI into security development. It has been ad hoc scripts, some manual development. Maybe there are going to be tools sooner or later. We use AI in 3 areas at this time. Automated triaging. You can compare SAST and SCA output with what LLM gives you. It can explain the errors. Sometimes it indicates the specific area of code to be fixed. The second application is reachability analysis, pretty much like the first point, but this is for reachability, where an LLM can indicate the section of the code where that library is pulled, so that the analyst can find this easier and evaluate the criticality. Our processes first give this to OPSEC. They prioritize the criticality based on reachability. Then it goes as a ticket to the service with the criticality stated. We have a code assistant in SourceCraft. It generates fuzzing targets. It works with simpler languages like C. More complex languages are not as accessible, but LLMs are advancing, so we'll see. Some other things to keep in mind for the future. We want to be vendor independent. In SSL DLC, we are looking at open source solutions. We develop our own things. We try to be part of the community. Come with pull requests. We want to scan IAC deploys because there are opportunities for statistic analysis. We are looking forward to getting source craft internally to be integrated with CIAM so that we can get events from there, SOC alerts, let's say review rules have changed, new admin has been added to a repository. This would generate useful alerts for our PCS. We continue developing SBOMs. We want to have a fully fledged asset management there, to have visibility of the entire landscape, all our services, how they were deployed, their stage in the life cycle, their vulnerabilities. This would be a centralized storage for everything that we have in production. With that, thank you. I was glad to share this with you. I have a QR code to score my speech. I'll be taking your questions now. 2 mics in the aisles, and the best question will get a book. Great. That was my announcement. So thank you.
Здравствуйте. Подскажите, пожалуйста, спасибо за доклад. Подскажите,
Hello, thank you for your presentation. What's your fuzzing strategy? It takes some time, takes a while. Do you run it for each build? Or is it once per night or some other schedule? It's the same strategy as everything, on release or every night. That's what we have so far. So a developer cannot make sure that their commit doesn't break anything until it's dark, until it's after hours. No, we don't have quick fuzzing for commits. We plan to implement it, but these quick fuzz runs do not happen for pull requests. I have a very similar question. Let me rephrase this on the go. Do you have any tools based on this schedule? Tools to determine specific changes and commits that have led to errors. You analyze entire batches of pull requests and commits, right? Do you then pinpoint specific offenders? This is a question about fuzzing, right? Fuzzing, SAST, what have you. Analyzers.
Вот, там можно посмотреть, где происходил крэш. Это не автоматизировано, это ручное.
It's not automated. You can look it up. The ticket will contain part of code. You can click into it and do blame. I think it's a pathway, but it's manual. And in fuzzing, it's the same as SAST. Code snippet. SCA, the tool doesn't have it. It's down to triage. If the OPSEC is diligent, they would specify some part of the code to the developer or can blame the entire library. What I'm getting at is that Google's cluster fuzz has some functionality for this. They try to pinpoint it down to a commit. I think you could look into that. Or try and leapfrog to commit-based analysis. You have your own infrastructure, a lot of computing power, so you can afford that. DCM and fuzzing in cluster fuzz, yeah, I know it's a good idea. It can be implemented, we don't have it. Our tests can be complex and can take a long time. So it can take an hour for tests after a single commit. So bisection is a pain point for us. Okay, my second question. So, to continue with this parallel, yourself and Google, do you have plans to launch something similar to cluster fuzz or OSS fuzz? Again, you have the compute, you have the cloud. We went for a simpler approach. At my previous jobs, I was responsible for things that are more similar to OSS fuzz. Here, we focus on security. There is no JIT infrastructure. This pipeline This is a couple of thousand lines of Python.
Что тебе нужно в узкой специфике в
If you know
компании, ты можешь
what you need in a narrower scope within your company, your fuzzing pipeline can be much simpler, and it will be tailored to the code that you are developing. You won't need this
иметь сложный агрегат, который там периодически там
complex machine.
ты плюс-минус можешь себе позволить в обычном CI все гонять.
You can do this within CI if you're confined like this. Point taken, but on the other hand, cluster and OSS fuzz are there for a reason. If you considered that maybe to come up with something similar so that there is no monopoly in the market
Я понял. Нет, тут
to compete with Google.
планов тут таких не было. Тут основная концепция
We don't
организации,
have plans like this,
что Google вкладывает
but it's an organizational
source компоненты.
concept.
Тут даже не сама
Google
инфраструктура,
invests
сама идея
into security of OSS components.
подфазинг компонентов.
They provide compute to do fuzzing.
Combined files, то есть это больше скорее про это, что
I think that's what they're
я
doing.
не знаю, то есть как будто разработчики open source часто заносят свои проекты туда, и тут как
So open source developers use that.
не факт, что
It's a one-stop shop. I'm not sure it's reasonable
рационально перепроверить.
to
Такой вот централизованный
give another alternative. If we don't trust them, we have a centralized thing.
здесь еще дополнительное электричество уже еще не
They burn their own electricity for this. Well, I wouldn't count on them. And it's great that you want to become vendor independent. But then again, any competition is further better than just one sole monopoly vendor. Last quick question. You mentioned SAST. What about fuzzing engines? Which ones do you use?
Flipfuzzer-like вещь. Это чисто связано с
Flipfuzzer, mostly, due to replicability and stability.
точная вещь, но мы пока
We have C++, but
считаем, что Flipfuzzer,
these
сверху для
are
программирования примерно одинаково запускали
ad hoc.
цели, иметь больше
We want fuzzing targets and goals to be stable and similar for different
вот этот фактор стабильности
languages.
играет даже
Stability is key here, and it outweighs
важнее атаки. То есть как это, если вы как
in terms of defense,
лучше развернуть IFI,
not as attack.
наверное, больше хорошо.
i5++ is better for you as an attacker, but for us as the defending side, the other solution is better.
Спасибо за доклад.
Hello, my name is Mikhail. Thank you for the presentation.
Вот ваш
I got curious about this vendor independence in SAST,
переход к open source
your migration to open source analyzers.
экономическую
Have you done the estimates
что ходит
for the economics there?
не такое дешевое развлечение.
People say that open source is not as cheap
Довольно
to
большой
be implemented in a company.
в доработку этих
It requires a lot of reworks and improvements.
потому что бесплатные правила, они
Adding rules, for example, because
мало, и они очень качественные.
free rules are few and far between, and the quality
Это я все, конечно, слышал, да, придется
lacks to be desired,
но пока что вот
leaves to be
практика,
desired.
что, точно так же
Yes,
экономические решения могут
I
быть
mentioned this,
сложные,
but
их нужно дорабатывать.
enterprise solutions require additional
Что как раз open
work
source
as well,
хотя бы
and it's more challenging.
хабы, мы не боимся
The
отправить
concept is that it's okay to send pull requests to GitHub,
моменты, бывает тот еще
but
челлендж,
then
чтобы
in a proprietary solution,
годами,
it's not
полугодиями,
easy to go through
и как бы
the bug pipeline.
экономический вопрос, то есть
They fix bugs at their own volition. So we've experienced more pain from enterprise solution,
даже на нашей стороне
and we do a lot of workarounds on our side there.
инструменты. Еще на самом
And in the open source case, we would be able to edit the tool itself.
очень активно развивается. Во-первых,
Open source is on the rise.
молодежь не становится там,
CodeQH is making strides.
анализирует кучу языков,
It
то
can
есть стоит
do
изучать
builds, different languages, something to look at.
вот анализаторы, которые
Analyzers for C++,
мощные, поддерживают все
they're
эти
quite powerful as well, and they are compliant with the Russian standard.
То есть тут
Then they have code checker, triaging markup interfaces. So the outlook is positive,
как вот на продукт,
and we consider our own internal tool as a product as well.
А не смотрели ли вы в сторону разработки своего open source SaaS
Have you considered developing your own open source SAST analyzer to make it available to our community. It doesn't make much sense. The level of developer there is on the compiler developer level. You can count all engineers like that in Russia with two hands. It'll be really hard to hire the resources for that. So it's not feasible. And there is an open source tool. It's being developed. You can contribute. We have a whole maintainer at Yandex of Clan Static Analyzer. They can develop a checker. That's what we're doing. Just like the previous presentation, you shouldn't compete in open source. You should all invest in good centralized solutions. Well, that's if they accept pull requests from Russia. But we have a maintainer. Okay, one last question. Hello, thank you for the presentation. My name is Evgeny. In CI, you mentioned builds that do not have access to the internet. How do you enrich this with the libraries? Do you have any pre-checks before libraries get inside? We have IP tables where they can only call eternal hosts. And then you have a registry within the perimeter. There is a tool by people for server infrastructure. As we download something to our internal repositories, they check for signatures, authenticity. We have a quarantine for Java. If there is a new dependency, you cannot use it for 2 weeks. It will not be downloaded. So there are defenses like that. Thank you. Thank you. Another question, if I may? A quick one. Looking at that slide, I thought of another question. Who develops shells or packages for fuzzing testing in your company? I looked at a Google presentation on ClusterFuzz, and they boasted with their team being just 5 people strong to maintain their fuzzer. Yeah, I talked to them. They suffer there being understaffed like this. On our side, we have salaried developers to do this. We just give them the tasks. If someone doesn't know what that is, we schedule calls, show them around, explain what it is, but they develop it on their own in their teams. Okay, good. Thank you. So for the most challenging part, the most challenging question, pick the best question. I like this one about from the guy in the orange short. Okay, please come up and get your book. Thank you.
Ну что, мы готовы продолжать?
So we are ready to continue.
Мне обещали, что будет минутка рекламы, но...
I was promised an opportunity for a plug. Can I make an advert?
Замечательно. Смотрите, значит, сегодня
Okay.
замечательный день, но завтра...
Today is nice today, but tomorrow is just as nice. We'll have various activities, IT networking, in this very room. You're welcome. Register and have fun.
Ну что, готовы слушать следующий доклад?
All right, are you ready for the next speech? I invite up on stage Всеволод Дергунов of Positive Technologies.
А микрофончик ты зря не взял вон там.
Do you have a mic? Your loss.
Спасибо большое.
Thank you. Thank you all.
Всем привет, привет. Рад, что вы пришли
Hi.
слушать мой доклад.
I'm glad to have you at my presentation. Thank you for the support.
Сегодня я хочу посвятить этот час
I'll be speaking throughout this hour about data sources for fuzzing API web apps.
Почему вообще я к этой теме пришел?
A few words about myself.
И почему хочу это рассказать?
How did I end up here and why am I sharing this? I have solid experience in working with API web apps. I used to do development, application security engineering, pen testing. So I've reviewed this elephant from many sides. I worked at big IT companies where I learned about larger conventional APIs. You cannot always check them manually. That's why I began doing dynamic scanning and automation. I do SAST as well. I develop different scanners for REST API and gRPC. I've even published on this. I prefer to publish the new vulnerabilities in our beloved Russian stack database. API is not just an interface in terms of security. It's an area of risk. If it's broad, it constitutes a large attack surface. To the right, you have some code. It's a basic controller. Just by way of example, hopefully, people do not call SQL through controllers. But at the bottom of the listing, you have a simple SQL vulnerability. It's just an example. We're not going to discuss vulnerabilities. It's just something that everybody knows. So we have an API handle where there is an SQL injectional vulnerability. To detect it, you need to do some testing, do the brackets, quotes, send the quote. But then this handle can have other parameters, not vulnerable to SQL, but still requiring validation. There is a lot of such endpoints in the real world. You have GET, POST, different HTTP methods, and it's continually developing in a large company. You can get 10 new handles, dozens of new handles, hundreds in a big company. It's hard to check, it requires automation. It seems obvious, but manually you will be overwhelmed with a large scope, or you can miss something due to a human factor. Here are some examples, not just SQL. In API, you can come across all sorts of vulnerabilities. There are different groupings, injections, comment injection, code injection, depending on the context. There are many misconfigurations where you don't process errors. The API spits out some useful data. You can do debug mode if access control is not properly configured. There are a lot of third-party API frameworks in modern development, a lot of integrations. You often have default settings as well that are not properly reviewed.
там, нового класса, который вы
You're not
используете.
aware of the keys that have to be
Большое, да,
sent.
история очень важная в API-тестировании. Это
And the big
access
group
control,
in
да,
APIs is
сломанные
access
роли,
control
когда
or
неправильно
broken access control,
модель или неправильно
where the roles are misassigned, the segregations are wrong, and it gives rise to abuses. From function level, where you have privilege escalation, then you have object level, where you get data that are not meant for you, like in IDOR, where you have an ID that's just brute forced in parameters to get other passports. And then you have mass assignments on the property level. You spoof fields in password resets, for example, as if you were an admin. There is a bunch of other vulnerabilities. We'll not be focusing on them today. Just to say that APIs are rich and rife with holes. We'll be discussing fuzzing overall today. We'll compare it to SAST and DAST. To stand up for DAST if you like SAST more. We'll look at key challenges with fuzzing, how to improve it, and we'll source at the data sources that can be helpful. At the end, we'll speak a bit about automation. Knowledge is power, but we want computers to apply them, to crunch numbers, for us to have some more free time. Fuzzing API of web applications. Fuzzing is automated API testing, where you send random or malformed data to APIs, hoping for a response that hints at an error, at a vulnerability, something that you can dig into. The basic idea is simple. Mutation of input data influences the response. That's Postman. You have a form in the request. If the value is as designed, then it's fine. If you pass some SQL syntax there, you have an error. And this means that there is a vulnerability.
Просто берем и масштабируем эту историю, то есть, соответственно, больше поверок, больше уязвимостей.
You just scale it with more data and more tests. We test for all endpoints, all methods, all the parameters, which we achieve through automation. We can add various loads. The example is for SQL, but for any type of vulnerability, these parameters would be different. It's also important how you do your analysis of the returns. It's not just that it says an error. You can look at the size of a response, status code, some other parameters as well that can be cross-referenced with unexpected behaviors. Some of such behaviors can be dangerous. A bit of a digression now. Let's see, compare and contrast static and dynamic scanning. Why bother with DAST if you have SAST? So static or dynamic? There are just a few parameters that differ. Static analysis has access to the source code, dynamic doesn't. This makes the target of SAST the code, some patterns calling for unsafe functions like eval, whereas dynamic analysis focuses on the behavior, query response. Now, quotes give you SQL mistakes. There are various tools to do SAST and DAST, SAMGRAB, CodeQL, PT Application Inspector for the former, both enterprise and open source. For DAST, you have Burp, Nuclei, PT Blackbox. It would appear that SAST is more effective and should give you full protection because it has access to the source code. You don't have to second guess it. You don't have to generate queries or requests. You scan the code for unsafe patterns and never bother with Dast after that.
Я полностью согласен, что SAS
I fully agree in obvious cases. SAST identifies most egregious errors. Here is a listing from SamGrep.
уязвимый код, в котором опять содержится SQL.
To the right, you have vulnerable code where you have SQL injection in the format code. Again, a very pedestrian example, and most analyzers catch this within their rule set.
Но давайте посмотрим на следующий слайд. Здесь
Here is the next slide, though.
менее очевидно.
To the right, it's not as straightforward, but there is a vulnerability still. Unlike the previous slide, where it's very simple, there is an API controller. This is not my code, it's an actual code from GitHub repository. It has 10,000 stars, it's written in Go, and it's a product that's critical and installed within your perimeter. For some weird reason, maybe it's a backdoor even, the developer transforms SQL queries through a buffer, not a line. They feed it byte by byte, they add some SQL structures, commas, for example, sorting, and then it goes to the database. Well, out of the box, SAST will not detect this. It's pretty weird, nobody's expecting this. It'll be missed. Yes, you can apply a rule for that once you've encountered that. But it can be implemented differently. Coding is creative. And developers have full license to come up with new things. And it's going to be all the same for Dast. It doesn't look at the code. It sends in a quote mark, the character, and the error will be the same, whatever is in the code. It means that the tools are different, that complement each other, not substitute each other. Will be more secure than using just one or the other.
Защитив, точнее, Dast, да, что как бы он нам нужен, и мы не можем от него отказаться.
Yes, we need Dast. I've made my case. Let's now assume that you use it and try to improve the performance of your fuzzing to make it more targeted.
Для того, чтобы проверять API-шку, нам нужно знать по-хорошему endpoinты приложения.
To test APIs, you need to know the endpoints, the methods in HTTP that it uses, the parameters that it takes, and the expected value formats. If you are screened out at validation, do not go to business layers. You'll just make the server racks spin, but you will not find any vulnerabilities. It'll be a DDoS attack at best. So where do you get the data? Get the endpoints, know the parameters, and the expected value formats.
И, собственно, и что является центральной темой моего доклада.
So this is the main section of my speech. Data sources for fuzzing.
Давайте начнем с самых банальных примеров.
Let's get to it. Here are some basic examples. I think you are all aware of OpenAPI. It's a format for description. It's not as much used in security, but in development. For apps, it's fine to have an API be published for other developers to engage. It's used by pen testers, by internal developers. It can be published on GitLab, GitHub, or available for docs, OpenAPI. It's all over the place. Two formats, YAML and JSON. To the right, it's in YAML. And it has everything that we need. Endpoints, parameters, and values. Values are not always there, but diligent developers have it included.
Есть еще такая штука, как Swagger.
That's something that you can use. There is Swagger as well. It's the same for us. It's just an older version, so let's skip it.
Вот это тоже Swagger UI, вы его часто видели на
That's Swagger UI. You've seen it across different services. That's for you to look at the API. It's YAML or JSON. This data structure is the same. Once you've seen this, you have OpenAPI.
Следующий чуть менее очевидный источник, но тем не менее
A less evident data source, but also common, is Postman.
стандарт в веб-разработке.
Basically, it's another standard for web development. Many developers use it.
Там по всяким API first
They use it to test API implementations
для тестирования
to
API-шки, он
develop
доступен бесплатно
under API first approach.
с большой популярностью. И тоже во
It's available for free. There is a free version, HTTP client,
можно найти Postman коллекции
and documentation is published on GitLab, wikis, or whatnot,
или другим
because they have the developers, they share it among themselves, and this is where you can get your parameters for testing. It comes as a JSON. The example is right. It has all the same parameters that we've been looking for: endpoints, parameters, and values. It's not one all and be all. There are similar tools. There is Insomnia, Hopscotch, other less frequently used products. If you know that your company or your customer has other similar things, do not overlook them. You can always convert Postman to OpenAPI. Their website has an endpoint. You send the request and it generates a file. You'll see why they need this a bit later. If we haven't found any available descriptions of the API, or OpenAPI or Postman, you can collect some traffic. Here I'm speaking about Burp Suite, a well-known security testing tool. It's become a standard. In our context, it's used as an HTTP proxy. You just run it. You run the app, and you proxy all of its requests through the suite. You engage all the buttons, all the functions, trying to generate all the queries, all the requests, go through all the pages, log in, register, to get a comprehensive picture. It's saved as a history in XML. The example is to the right. It has everything we need: endpoints, parameters, values. There is OWASP ZAP and other less common similar products. Do not limit yourself. You can choose. Look at the whole selection. You have the history in Burp. It's easy to export. You select the values or the entire history and just save it.
Proxify — это следующий инструмент, который...
Then we have Proxify, another tool I wanted to highlight. Similar to Burp, but it works as a CLI. It's easier if you want to automate the collection. If you have an intermediate proxy server to look at other requests as well. It's a free project by Project Discovery. This team is well known by its many web security tools. You just run it and proxy the requests from the app, the target app. It can save as JSON, Lime, or YAML. There are similar products as well, Meeting Proxy and others. The examples to the right, that's what you get out of it. It has all the parameters that we need. Once again, here is how it looks. You get it from the package manager or directly from GitHub. You run it, it gives you a port, works as a proxy.
сложный путь, но интересный, тем не
A
менее.
more
Большой компании.
complex
Это журналы
yet useful
всё равно
tool
компания, опять же,
is
разрабатывая
web server
разрабатывая приложение,
journaling or logging.
чтобы смотреть, как оно себя
You do
ведет.
logging as a bigger company.
Какие там
For any app,
ошибки
you'd have this.
возникают.
Behaviors,
Это используется не для
causes of errors,
но и для обычных
performance under load.
Соответственно,
It's useful for development, not just security.
мы знаем,
This is something that you can use.
мы можем там
If you know where the logs are, you can get them from the teams, or if you're an attacker, you get access to logs
взять то, что нам нужно.
and pull the information that you need from there.
Например, Elasticsearch, да, который является де-факто
For example, this would be Elasticsearch, the go-to solution in logging.
Есть множество там бесплатных или там каких-то
It has many
там всевозможных
free
тоже
add-ons even, or forks.
Он хранит документы, да, то есть
It stores a
JSON формате.
document in a JSON file.
Стандартизации какой-либо нет, потому что
There is no standard for this.
инфраструктура от конкретной компании.
This will depend on the infrastructure and the specific company. They can configure the logs. What goes in there, what fields are there.
С какими значениями
But it will mostly have endpoints, parameters, and values.
Если мы нашли Elasticsearch, то, соответственно,
If you have Elasticsearch present,
то мы можем это выгрузить. То есть на примере Elastic
something similar, you can export it. Export the data. You call an endpoint if you have access or you hacked it.
запросив специальные поля, которые нас интересуют, выгрузить их.
You ask for specific fields and download them for your future use.
Который там я, например,
I think this one is the most interesting out of the cases. You can do commands for load testing, or you can reach out to the load testing teams.
Просто хотя бы
You need to load test your APIs as well, on top of security, so that you are sure that all the functionality from the brief works.
времени они пишут автоматизацию, и с помощью этого
These teams try to automate tasks. They have infinite time. That's how they test the APIs.
заимствовать эти запросы у них. Например, есть
And you can take queries from them. Yandex Tank is an open source tool for load testing.
тестировщики.
It's free
Он
and used by testers.
специально сформированные запросы в формате там сырого
It takes in
можно сказать.
raw HTTP requests
Мы его видим на
as
слайде справа. И
instructions,
тоже будут содержаться все
and it'll
искомые нами endpoinты
contain
значения.
all the things that we need.
Тоже много каких-то in-house аналогов, то есть не надо на нем зацикливаться.
And then there are other products like this. You can look for similar solutions again.
Нашли несколько источников, там какой-то
So you have your data sources.
был на периметре компании,
You've come across something.
собрали сами, не суть. То есть мы собрали данные, мы представляем,
You've
как выглядит
received it as a counterparty. You've hacked into somewhere. No matter. You know what the API is, and you can start testing it.
приступить непосредственно к тестированию, нам необходимо сначала
To start your test,
какой-то сделать алгоритм, да? То есть
you need an algorithm.
тестировать
first.
приложение.
What you are going to do, and then what steps.
Лучше всего сделать необычно.
You need
не на проде, да, тестировать, а сделать какой-то стенд,
stage, bench, or rig. If you do fuzzing on production, nobody will be happy, especially if it crashes. So you have a staging environment.
да, чтобы как раз
It has to be as similar to production as possible,
очень близкие.
so that the data and values are as similar as possible to make your finds relevant.
какими-то способами.
The next step is to collect the data, as we've been discussing.
У нас есть уже стенд и данные, мы можем
Then you have your rig, you have the data, you can come up with checks.
будут уникальные, потому что у всех
They'd be unique to each company. Steps are different, development practices are different, patterns within the companies are different, so it's better customized.
там используется там один язык программирования или другой, у вас и
If you use this language or the other, your vulnerabilities would be different as well.
не будет априори. Поэтому нужно здесь
So you shouldn't test for things that are not there in the first place.
понимание, что мы хотим найти, да.
Having sorted all of this out, you can start fuzzing.
Первыми двумя пунктами все достаточно предельно понятно. То,
The first two steps are very clear.
до
and I've walked you through them.
настраивать проверки, да, и как запускать фазинг.
Then you come to the configuration of checks and launching fuzzing. Are there tools maybe that enable you to do this quickly without
Такие тулы есть.
working on it too much? There are tools, yes. It's called Nuclei, an open source scanner, an app security tool by Project Discovery. It has a number of advantages. The community is big.
Комьюнити уже написаны шаблонные проверки.
It has template checks developed by the community.
Хакеры с ним взаимодействуют, это комьюнити постоянно растет, и проверки расширяются.
They are engaged with hackers of all sorts, and they are expanding the
То есть раньше это был просто сканер уязвимости, да, он
the templates.
на ваших endpoint'ах проверял.
It used to be a vulnerability scanner, now it does fuzzing as well.
Карту приложения из источников.
Once it has
Он будет таргетировать
all the data from the sources, it has the map for the app, and by Recursion multiplication, it will
ставить кавычку и анализировать.
do, let's say, send a quote to each endpoint in each parameter with each value. So for all vulnerabilities.
Сразу несколько форматов значений. Это
It's good that it takes different formats of values, OpenAPI, burp-suite, JSON, Lime, and YAML. It can take those formats. To the right, you see a listing.
шаблоном для Nuclei.
That's a generic Nuclei template. You have a generic header. You set or configure the
Задаются какие-то
response analysis.
данные, да, те самые payload.
You do the payloads.
Для SQL инъекции это будут кавычки.
Again, you see in SQL there.
Параметры фазинга. То есть
And then you
тестируете
set
все
the
параметры,
fuzzing parameters.
находятся только в query.
You can isolate just the parameters and the query, for example. And then it has a bunch of other
Это прикольно и
finer
интересно, но это достаточно
configurations.
в то же время уже
It's fun.
крупный инструмент, поэтому
It's
я не
interesting.
хотел бы, да, превращать доклад в чтение его документации. Я призываю всех,
But it's
кому
pretty mature. It has a documentation, so I wouldn't want to read it out instead of my presentation. I have an article on this.
запустить
It
и найти уязвимости в приложении, как раз тем
takes you through the steps from just encountering an OpenAPI through to running fuzzing with Nuclei. They have their own documentation, and it's been there forever. That's there for your use.
что у Nuclei работает с некоторыми форматами данных, но не
So we know that it works with some data formats, but not all. It takes in OpenAPI out of the box, Burp as well, Proxify, obviously, because it's the same team that developed the tool. But not all data sources will be directly usable in Nuclei.
Если вы нашли какие-то данные из источника, которые есть,
Assume you have some data
которые вы там сами придумали, и они
from another source that are not taken by Nuclei by default. You can normalize them. It's not that difficult.
злосчастный перекладыватель
You just need
разработчики боятся.
the
То есть, соответственно,
JSON
просто пример.
converter that all developers are for.
Да, тех же ребят
You take an example from Proxify
и посмотреть, какие минимально необходимые поля.
and look at the minimal fields that have to be in those JSON lines.
Переконвертировать
You
это в
pull the data from your format into JSON line, and it'll be accepted by Nuclei
уязвимости.
to run the fuzzing.
Итак, реализовав такой базовый фазинг, да, который, в принципе, для
That's your basic toolkit for fuzzing.
дальше продолжить
It's all right if you're starting out, but then there are things to learn some more
и более серьезные, нестандартные.
to allow you to
Мы можем
find more vulnerabilities
шаблоны, да, я это уже упоминал.
and
У Nuclei
obscure vulnerabilities as well. You can develop your own templates.
шаблоны, ну,
Nuclei has good templates out of the box, but SQLs are
для авторизации, например, собственно.
not as tricky. You could develop templates for authorization, for example.
Ответ 200, но при
Let's say that it gives you 200 at all times, but in JSON, the status code would be 400.
шаблонах для того, чтобы не
That's something that you can account for in your own templates
под конкретную инфраструктуру.
to avoid too many false positives. You can customize it to your own preferences, your infrastructure, or a specific project. You can look at out-of-band interactions as well, where the app makes an external query and you can catch this. Project Discovery has a nice tool, Interact SH, and it's integrated with Nuclei natively. It can be deployed within your perimeter as well. Nuclei has nice reports, CRE for Markdown. Command line is nice, but if you have big sets of data, it's better to be exported to store someplace or to convert it into readable reports. This is integrated into CI/CD, as we like. There are example implementations on their repository. So any major list from your app will have a rig, a bench. It'll have a container for Nuclei. It'll take the data from where you want, all automated, and it'll run tests. What's not to like? Just like I said now, automation, getting sources of your data. This can be directly from your storage, or you have a crawler that goes to some neighboring system where you do load testing. And then, if you're still not happy, like I was when Nuclei didn't have fuzzing out of the box, you can develop your own shells or packages to run fuzzing, configured to the vulnerabilities that you want to check for, or you can develop your own scanner from scratch. Yes, Nuclei is not perfect, and sometimes you have to do this. So we've reviewed API fuzzing in web apps. It's not as difficult. Configuring Nuclei using community templates is easy peasy. We've discussed SAST versus DAST. Again, these are two different tools. The overlap is not complete. Some vulnerabilities are better found through dynamic scanning, including fuzzing. Quality fuzzing requires quality data. It shouldn't be random. You need to be targeted per parameter. You'll get fewer false positives and higher quality of alerts. We've reviewed the data sources, including OpenAPI, Postman, Burpsuite, Proxify, Yandex.Tank, load testing, or logging systems like Elasticsearch. The list is not exhaustive, obviously. Each tool like this has similar products, or you can find the same data in some other way. HTTP is very popular. It's used by many teams in many areas of development. So within the company, you can borrow this from your colleagues or steal it if you're a pen tester. We've looked at all the steps to automate this from scratch. If you've never done this, I suggest Nuclei. The barrier to entry is very low. It comes pre-configured. As first step, it's great. You'll see how fuzzing plays out with your infrastructure. You look at the finds, and then you can build this out, do custom checks, catch all the vulnerabilities. It's a rabbit hole. You can really put a lot of effort into this. You can do microservices with Nuclei, automatically initiated. It takes the data where it needs from, it converts it, it's triggered by events. So the opportunities are endless. You don't have to initiate a scanner in a command line each time. That's it from me. Thank you. I'll be taking your questions gladly. The mics are in the aisles.
Спасибо большое за отличный доклад.
Thank you for this great presentation. Once again, 2 mics are available in the aisles. Once again, the best question will be rewarded with a book. by Peter Publishing House, and to rank the presentation, we value and appreciate your feedback. Okay, questions? Thank you for the interesting presentation. However, you focused a lot on data sources where different parameters are already structured, so they'll pass through some preliminary filters. Usually, though, for payload to get to the required point, the database has to be in a specific state. It needs to have the values in it, specific values. You have a business flow, and we have requests that come in sequence according to the business logic. It's hard to automate, so you have to do some manual work. You have a sequence of templates to get to the point that's further downstream. Do you have any experience how to improve this? Yes, thank you for this question. It's indeed a challenge. I mentioned this, but in passing. In algorithms, for fuzzing, you have to do staging, and it needs to be as close to the production environment as possible. You have UIDs, they will not be validated if it's not in the table, for example, just like you're saying. This is something to aspire towards. That's why you do a staging environment. This can be automated. At bigger companies, there are already production, staging environments, and some more. And this is addressed through the staging environment being as close to production as possible. Hi, thank you for the presentation, very interesting. I have this question. So you collect the endpoints, paths, parameters. Is there a list that you compile? I tried to fuzz APIs. I went around public GitHubs, GitLabs. Is there a list that you have, and does it improve on what's out there in the public? Okay, I get the question. It's been solved many times. You have AssetNot, dictionaries, where public documentation is parsed and there are values. If it can be used to enrich your testing, I think it can. OpenAPI doesn't guarantee you access to all the endpoints. Some secret handles can be hidden there, and you can enrich the testing with additional parameters, yes. It's practicable. It's not basic checks from nuclei, where you have a URL. You can have your own templates, like deer busting, or some peculiar parameters. Hello, Sevlad. Over here, very interesting presentation, thank you. At the top of the presentation, you mentioned SAST, and you showed SMGraph. Did you consider it as a source for fuzzing, for example? In all languages, APIs are usually defined through templates. If you have a rule in SMGraph, with access to the source code, you'll be able to have all the APIs, Boolean, not Boolean, number, not a number, string or not string, as well. I think SMGraph can find hidden APIs for you if they're not documented or described anywhere. Did you try this? Thank you for this question. A great idea. I'd use CodeQL for this, because it's a declarative language where you can get all the parameters out of there. But I'm not including this in the slides, because I wanted to start with overall available data sources. OpenAPI is out there. If you need a code analyzer for this, it takes some additional effort. Different companies have their own frameworks, patterns. It's something that you can do, but it's a whole job in itself. Okay, out of curiosity, what are the types of vulnerabilities that you can find through fuzzing? Can we identify blind injections that manifest at a later date, or DDoS that cause delays? What are the applications of fuzzing? What types of vulnerabilities? Thank you for the question. You can find most vulnerabilities for fuzzing, if not all. So some things are easier found with SAST. If it's a bad pattern in the code, if you know this, it'll be okay. DAST and fuzzing is better suited for authorization. Multi-user models, it doesn't always come through for the code. Can you use this handle or not? In DAST, you have two tokens. You see user and admin, for example. Simple injections, if errors aren't handled, including blind injections. There in the slide on improving fuzzing. There are tools to catch blind injections and other SSRFs, like Interact SH. It's integrated easily. It'll exchange the data. Is it in the slides? The tool that you mentioned? Yeah, it's in the slides. I mentioned it. It's a DNS server HTTP. It logs whatever requests were there, a unique subdomain. Hi, thank you. Is it possible to configure fuzzing to check for business check and to identify blind spots that require manual configuration? In WAF, for example, you shouldn't add a check for SQL injections, but there are aspects of business logic that need to be checked. Can we do templates for this? Thank you for the question. Oh, yeah, really, why not? You can check for anything. Nuclei gives you an interface with YAML templates in configs, so you can send raw requests. It can send anything, and then it'll extract values, go to other handles. So it's non-linear. It's supported. It can be any logic. You go one place, you take something from there and the other. Yeah, it's community-driven. People are coming up with all sorts of things. You can execute shell commands from there, and it has entire pipelines. It's not like one query, one response. It asks for a CSRF token, it goes to the other handle, registers, and then it takes a cookie and goes to the third handle, all sorts of arrangements. Okay, thank you. Thank you. I see that we don't have any more questions. What was the best one? Which one did you like? I liked the question about the database staging environment. I can see that you've had this issue, so you recognize this. Yeah, we all did. Please come up for your gift. Thanks a lot. Thank you.
А теперь у нас небольшой перерыв в ожидании следующего
We have a short break until the next presentation.
Давайте
Yes.
поприветствуем с вами Сергея
Now,
Петрова.
let's welcome Sergey from Gostrach Insurance Company.
Добрый день.
Hi.
Однажды задался темой такой.
Once I had a question, how secure are our conveyors? Are there any vulnerabilities, problems, errors in what our DevOps are doing? What we can see here, I develop conveyors myself. We develop a lot of conveyors, I mean our team. Can we find anything bad there? And my presentation is about that, about peculiarities of how we audit the conveyors, which are not in the format of YAML files, who are met here and there. I work in a large insurance company as DevSecOps. I worked in different areas, and well, it's written who I am. Well, I developed OWASP prompt. Now let us look at the audit scheme that we can use for detailed auditing to find problems. Briefly, what we usually have. We have DevSecOps or DevOps, developers, testers, and some other members of the development team who can develop their own conveyors to automate something. They build a conveyor, and usually the conveyor is classical one. It's a YAML file, and it's in Git. And you can attach practices and check it. We use DevOps, and most of the conveyors are delivery conveyors, conveyors to deliver content to our servers. They are not stored in Git. I'm going to tell you later about it. We have a ready-made conveyor, then we can automatically launch the audit for such a conveyor and see the result. If we see vulnerabilities, we can do something about them. Each conveyor is a set of steps, a set of actions which are programmed there. And what is interesting for us, the scripts, because vulnerabilities or malicious things can be found in scripts. And some steps, it's not always the launch of the script, maybe an external plugin which simplifies interaction with something, because it may contain a functionality which contains a lot of code, and you can address a service to reduce, to shrink your conveyor. Conveyors can use their own variables for that particular conveyor. For simplicity, you store everything in one place, but conveyors can also use groups of variables, sets of variables shared between different conveyors for convenience, for simplicity. Accordingly, to understand auditing, to understand the process, let's look at it from a different angle. In our case, if we created a conveyor in UI, it is stored in the database in our CI/CD system, and we can take it only by addressing the API. So it's a bit more difficult than analyzing YAMLs in Git. What can we get from conveyors? The variables, the steps in the conveyors, and what else? Scripts of different kind. It's interesting that we can even take logs of each conveyor step which are formed in the process and see if there is anything interested in. For example, we can parse all the strings with error, security, vulnerability. It will help us to find problems because the developer doesn't care about the conveyor. For him, the main thing is the application. It works, it runs, he even doesn't go into that conveyor. So we get this information and let us think about what we can do, what we can find there. In general, we can find information which may be sensitive, logins, passwords, secrets of all kind, even IP address or name of a server is not very good if it is disclosed and not hidden in some variable. So we can find vulnerabilities and errors, which are not vulnerabilities, but we have to trace it. For example, an error when a trigger for the conveyor of the delivery to production is tuned to feature branch that we don't know about. So the corporate rules said that it should be release branches only that we know that are acceptable for the company. What kind of examples we can have? What kind of vulnerabilities we can have? Disclosure of secrets. For example, we can see that we can see a potentially dangerous instruction which uploads all the variables. It's useful for tuning the conveyor, but at the same time, we have a risk of disclosing secrets. So you may disclose the token, at least part of the token. We can see the variables of the environment, and they also can be disclosed here. The second variable goes away as a link. It looks as if it's secure, but what else can we see? In UI, it's nice. You can see application of deprecated plugins, which can be revoked by the developer because he deleted his GitHub account and marketplace account, but an intruder can recreate the same kind of account and then compromise this plugin just by publishing a new version, higher version, and we can download it without thinking that it may be malware. Besides, it may be some arguments which are delivered to executable scripts, and they can be transmitted through unsafe channels. There is a script which is called at one of the steps, step 2. It is called from Git. We cover it with our SASP. We can find vulnerabilities, but the variables are sent in an insecure way. And then plugins can have insecure parameters. For example, the password can be sent without masking. We mentioned it before. And the password entry form it doesn't have protection against overlooking. The password is not replaced with asterisks there. Then some dubious instructions, strange instructions. If we look at malicious codes, we can find such instructions. Then checking the certificate change, insecure algorithm of service-to-service interaction. What else can be found? For example, transmission of secret from vault in an open way. We see the variable there, a dangerous parameter. Some people may say that the continuation of step 2 that you can see now on the screen is not necessary if it's just a deploy of our application on 2 nodes. If it is crashed on the first node, why should we install it on node 2? Well, yes, you can manage jobs in that way too. Disclosure of login also can be dangerous in some organizations. Variables are stored in separate entities in the conveyor, and you can call them and you can store them in an insecure way. And this is an example of we forgot to close the lock and disclosed the secret. The interesting thing is that RGD Ops showed me that even if we found a secret, replaced it with a call from the variable where it is stored locked, but if we go to the log of conveyor, yes, you can see the secret openly, and this is the way you can see it. You protect it. It seems that you protected it, but actually you are not protected. You have to delete, you have to clean up all the history to be secure. Groups of variables, they can be stored in different conveyors, and this is an example of how insecure it may be. Look at this. Allow access to all conveyors. There is a click there. There is a tick there, and developers can create a conveyor and read all the variables even if they are secret, because this tick allows them to do that. And the intruder, the hacker, can create a conveyor with those in variables with appropriate rights. He can print all that and use the same variable in different conveyors. What about statistical code analysis? Well, if you have YAML, some steps can be omitted. Export from the database through API files of the YAML format. Then an interesting case is to get from YAML the scripts. Our steps can contain scripts, and in order for SAST to process them correctly, you have to take it from YAML to a separate file. You can see the example in Python, command line, and PowerShell. I tried to evaluate how realistic is this audit if you do it manually. 6,500 containers contains about 7,000 steps. You can see 7,000, 6,000. It's impossible to do it manually. As long as you do it, well, you will be tired a lot and you will make mistakes. You have to export all your conveyors. In order to export them to SAST, you can take all the entities that you know, we take them through APIs and put them into the file system as separate files. Accordingly, we can find most of the vulnerabilities in the files which contain scripts. And by putting scripts to separate files, you will find a lot of vulnerabilities. because bad parameters it's not the worst thing that you will find there. And there is an example of how you can get all the scripts. Our company uses a lot of external plugins. You can see only half of the result. And each script, each plugin contains a script. And you can spend a lot of time in Java DOps
плагинов в Ямлик я столкнулся с тем, что
by putting scripts to YAML.
нет понимания.
I saw that we cannot understand what kind of plugin it is. There is no name. There is only the IP. We need a conveyor with all the codes, all the scripts with their IDs, and realize what we can have. This is a file structure. This is what we get. We say we have YAMLs, we have scripts, and then we send all that to statistical analyzer, SAST, for analysis. And this is what we do. This is the last step on our scheme. So we sent it to SAST. I told you what we can find there, and let us have a look what kind of rules it may generate. For example, in pip or SSH, you can see a parameter that reduces security. Such parameters are not required often because we may have certificates at our servers, some other mitigating schemes, so we don't need such parameters. You can eliminate them, and this is an example of how to disclose such problems. We use a lot of builds with MS Deploy, and there is a parameter which I mentioned before. ChatGPT, for example, helped me a lot. You can ask him what kind of parameters we can have here and which of them are insecure. And from second or third iteration, it can tell you what is insecure. It's much easier to find insecure parameters in this way. You can see the JSON here. We are in DevOps, actually. It's not always YAML. Some rules are focused on JSON. An interesting case, as I told you, putting all variables into a log. On your left, you can see the log of the conveyor, part of our system token, and you can deploy anything if you get it. So in such cases must be disclosed and detected. How can you get all the parameters, all the variables from one point? Deprecated plugins. Some plugins do not have anything but IP address, and that's all. So you will have to spend time to download the plugins and create a rule for them. That is the rule. An example of the rules, vulnerable parameters of plugins. We can try to find what I show you in the screen. This is the way the plugin may look, and the string, the line where we make the rule. One rule for statistical analysis. To conclude, we can say that we have the following ideas for us to invent the rules. First, we must see what kind of languages we use in the company, what kind of software we use to build the trees for delivery. And then we must have a list and then see what kind of parameters they will use, which of the parameters are not secure enough. After the first iteration, it's necessary to look at all other constructions which are not covered by our SAST for a particular language. Look at several repositories, look at all the files, and see that because SAST sometimes can miss some of the vulnerabilities. Maybe we have something very specific for us. An interesting case is to understand what kind of normative documents and our internal documentation can become a rule for statistical analysis of the code. We make an interesting case when the basic image is changed, but all the rest is the same, and you don't have to use the same image all the time. It saves some time, and it helps us to look for the cases when developers use non-standard tags. It can be anything. For example, launching the delivery conveyor from a wrong branch. And we must look for such lines of code which would help us to disclose such cases. It's also useful to understand how DevOps automate the conveyors, how they generate the conveyors, what they use, what kind of requirements they have. Now, searching for secrets. Of course, vulnerabilities can be searched, but part of the vulnerabilities are actually vulnerabilities related to sensitive information. How we can find such information? What can we do? We have variables, and we have to export them into a text file. So variables, text, and search of secrets. For example, GitLeaks. We launch the audit, GitLeaks, and disclose vulnerabilities, and we can backlog them. And this is the method. We can download everything in the text file, and then each text file can be analyzed and searched. It's useful, actually, because we can read it. The variables should be such as they can be searched, they can be readable, so that later, manually, we could visually see what kind of secrets were missed. Talking about variable groups, they are separate entities, and it's interesting to have information about who created such group, who was the last to change it. Because this is a violation, and we can find the person who did it. And then we can delete all that and hide the secret under a lock. So it's simple with the method. We just send the file for scanning, run GitLeaks, and it's a simple conveyor. We launch it several times a day, and all information from all our network is downloaded. We can see how we work. GitLeaks is stored in the log, and each launch of the conveyor is kept for some time, stored for some time, so we can see what happened. If we don't have time right now, we can do it a bit later. Variables should also be stored for some time for auditing. It would be able for you to look through. We store them for some time. It's good for auditing. Now, how can we react to all that? We find vulnerabilities, but what can we do with them? It's only logical that the primary thing is to disclose vulnerabilities, and then we must correct them. This is the only case. We can fix some of the things easily ourselves, tell the users that they shouldn't behave that way. What else? Each person is to decide for himself, but as far as we are concerned, we send letters, and the letter contains information about vulnerabilities. If the statistical analyzer found a vulnerability, we have a letter, and we can send that letter to the person who made the mistake. A developer will look at the letter, eliminate the error, and it helps us not to increase our debt log, debt pipeline, reaction. This is, you can see the audit there. And in the letter, you shouldn't disclose the secret, by the way. So you go to the audit log, and then you see what happened, and then forget about it. Recommendations about statistical analysis is to regulate not only the development and code security, but also a responsibility for conveyor security. Otherwise, it's difficult to control it if you have no rules. When you build the rule for SAST, it's good to make it long. Links to internal requirements, links to best practices, recommendations, what has to be replaced by what. If you give it to DevOps, to developer, because you use a variable, it's false, change it to true, make it true. A simple recommendation will save a lot of time, because not all the people read those recommendations. They can say, well, it's false, let it be false, no problem at all. And this process has to be automated, otherwise it's not a process, it's just an audit, a manual audit. Secrets should be found everywhere, even in the places where you don't seem to find them, because any build can disclose any kind of secret information, and you must have a rule to find such information. This audit has to be carried out as often as possible, several times a day, very quickly, covering all the conveyors in the company. As I said, it should be readable as much as possible, and you have to store the audit artifacts for some time at least. From time to time, you have to check what you downloaded. If you developed a rule which found nothing, so let us see whether you need such rule or not. It turns out that you don't have to eliminate all vulnerabilities that you found. because you can say that they are of low level of criticality. There is no sense of eliminating them right now. For example, by
The second
switching
case is
on
where
the
you
certificate, it may so happen
include
that
certification
you don't have
validation
enough
and the chain.
certificates,
You're
and that's
lacking some
why
of the certificates.
Или в процессе, не знаю, отката может что-то произойти, и на самом деле уже звучит не очень хорошо.
So if you roll it back, that will not be as
Не говорим
preferable.
сроком. Команды сами разбирают
We are working through the backlog. Nobody is rushed.
уязвимости, и когда-то этот бэклог
The
будет
teams
разобран.
process vulnerabilities at their convenience, and they'll get through it eventually.
Перелистнулся, не перелистнулся? Да, перелистнулся. Примерно статистика.
Next slide.
Сложно
Here are
оценить,
some
оказалось,
rough
статистику
stats.
тех правил, которые вообще удалось написать, потому
It's not as easy for custom rules
хоп устранили на следующий день, и в статистику оно не
because it gets fixed overnight and it doesn't get included into the statistics because our analyzer for this doesn't export
начальной и конечной точкой того, когда мы вообще этот
if it,
начинали.
the data point if it's rectified during the audit itself. So some data points may be lost there.
Именно в сборке это в основном, как мы видим, большое
CI/CD vulnerabilities in builds
плагины устарели.
mostly
Мы постепенно ведем
occur due to
избавиться.
obsolete deprecated plugins. We are cleaning them up. And then there are vulnerabilities that have to do with certification chains. In delivery conveyors, most of the issues have to do with incorrect certificate validation. Insecure delivery of apps to production, that's what the conveyor is for.
Ну, если интересно подискутировать, есть контакты.
Here are my contact details if you want to start a conversation.
И необходимо оценить доклад.
And do rank my presentation if you liked it, like it.
Обязательно ставьте. Нам очень важна ваша обратная связь.
Do provide your feedback. We appreciate it greatly.
Вопросы можно задать
Now on to
у
questions.
микрофонов.
We have mics in the aisles.
Лучший вопрос, который нужно будет выбрать.
Best questions that you'll have to pick will be rewarded with a book from Peter Publishing House. You mentioned analysis of logs. Since it takes so many steps, do you have different sets of rules for logs, scripts? Have you considered some other tools to identify misconfigurations?
Пока не было такой идеи. На самом
No, we haven't considered a different tool yet.
отдельная тема доклада.
Looking for problems in logs merits a separate presentation.
Достаточно сложно, как оказалось. Ну, то
It's not as easy to export them in the first place. The API that is there
пока ты
doesn't
выгружаешь, и пока ты
support easy exports. So it takes some time to export, it takes some time to analyze,
Да.
they get purged and conveyors get fixed during that time. It's a separate presentation, but you have regular expressions for that. It's not that complicated. But it's not about misconfigurations mostly. You can get them from conveyor experts.
Или имелось в виду речь про мисконфигурации тех
Or do you mean misconfigurations of conveyor software? You had an example about secrets in logs.
Нет, нет. Там
No, no, no.
Netflix это делает за несколько минут, и все
GetLeaks does this in a couple of minutes across the thousands of conveyors. Okay, thank you. Hi, Alexander Gadai, WordPage Security.
Говорю, спасибо за доклад. Хотел
Thank you for the presentation.
про регулярки. Вот видел.
I wanted to ask about regular expressions that you come up with. They are pretty scary and complex.
И, допустим,
Do you have to modify them sometimes? And what if you delegate it to someone else?
как понятие прочитать.
You didn't write it, you need to first read it and then modify it.
Как ты
Is this practical? What's your take on this?
видимо, Речь была про вопросы, связанные с вообще применимостью.
This is apparently about
Да, не написать нормально.
applicability of regular expressions. Why not use proper SAS rules?
Длинный получается почему? Потому что тот же
The
пример
expressions are long.
allow and trust. Она как бы может быть
Let's take the example with allow one trust, the variable. It can be called with true or false, or one or zero. Sometimes it's JSON, sometimes it's YAML file,
зашито в конфиге какого-нибудь приложения.
sometimes it's embedded into a configuration in JSON in some app, so it's not called by the conveyor.
Написали для себя.
It's just a config that the developers have on their own.
Суммируя, получается такая длинная регулярка со всеми
So,
элементами, где каком
if you account for all of this, it's a long expression where this variable can come up at all.
Ну, кейсов пока того, чтобы кому-то передать
We haven't had cases where we delegated changes to the regular expressions. It's easier to do this on your own.
Был какой-то третий вопрос.
There was a third part of the question, right?
Размышления на то, что регулярки это сложно. Сейчас есть уже подходы.
Well, yeah, it's just that it's a bit too complex.
Приходите, послушайте в 2 часа дня.
There's a workshop on RAG language tomorrow. There are new approaches. It's human readable,
Более сложные, и не надо
and you can
легче вовлекаться
set
в этот процесс. Ну, я
minor conditions there. But I get your answer. Thank you.
Сергей, добрый день, спасибо за доклад. Было очень интересно.
Thank you for the presentation. Hi. Very interesting challenge and a great solution. You mentioned false positives. How do you manage output to prevent repeat false positives? Is there a centralization for this? The secret is still in the history of commits. You've discovered it, but you need to mark it somehow that it's a false positive. And when you recheck it, to exclude it, not manually. Do we have some centralized output management thing? How do you handle false and true alerts? In SAST,
Там есть функционал триажа простейший, да, отклонить или принять.
there is triage functionality, accept or decline. Very basic,
Если брать там поиск секретов, да, и
and it works.
использовать GitLeaks,
To your question of secrets, where you just run
каждый
git
новый запрос,
leaks,
который, как я говорил, несколько раз в день происходит, конечно, он будет
you launch it several times a day,
приводить к
and each new run
тех же уязвимостей.
will have the same vulnerabilities pop up.
Есть там условный JSON-чик, в который я вписываю все исключения.
In my case, there is a JSON where I enter all the exceptions.
Исключения там,
They are not flagged anymore.
вписываю ссылку на задачу
I add
команд, и таким образом
a link to the backlog, so I'm not seeing them
сработки.
anymore.
То есть я правильно понял, что как бы триажом у вас занимается инструмент
So you have
по САСТу, да,
SAST tool for triaging, accept decline, and in other cases, you have something in-house.
Что не используем там
Yeah.
централизованное управление
We
уязвимостью.
don't have a centralized system for vulnerability management. That's why it's like that. Okay, thank you.
Все, спасибо большое.
That seems to be it. Now you have to select the best question.
Был последний вопрос про
The
актуальность
last question
работы с
about
глазами. В принципе,
updates to false positives.
Хорошо, приглашаю автора вопроса
Please come up on stage.
слева от меня получить подарок.
To the left,
Спасибо большое.
you'll get a gift. Thanks a lot. Thank you.
А мы уходим на небольшой перерыв в ожидании следующего
We have a small break until the next presentation.
А мы тем временем потихоньку продолжаем. Но продолжаем мы с вами с минуткой рекламы, конечно же. Смотрите.
Advertisements. Competition of programming will take place tomorrow in this hall at 10 o'clock in the morning. But to take part, you have to scan this QR code and register.
Я думаю, язык любой.
Any language you like.
А про приз можно почитать, если вы
The
зарегистрируетесь.
prize, if you register, if you use this QR code and register, you can read about the possible prizes.
Ну а мы тем временем готовы начать.
Meanwhile, we are ready to begin our presentation, and I invite here to this podium our speaker, Dmitry Kuravin from Jet Infosystems.
Добрый день, уважаемые дамы и господа.
Hi, ladies and gentlemen. I am Dmitry Kuravin. I am team leader in charge of application security in Jet Infosystems, and I will tell you about our usage of secure development tools, about the problems we face, about cases we have, interesting and not very interesting anyway.
Итак, о чем доклад?
Now, what am I going to talk about? First of all, about the tools of SAS and SCA, it's their usage, obvious, non-obvious, different cases, and what do we have to pay attention to when you choose the tools for secure development? What kind of triggers you may have? How can you understand that the tool works in some special way? What are the peculiarities? What can be wrong? Whether it fits your environment or not? How can you evaluate the tools? SAST and SCA. So, at first, theory. We cannot do without it. First of all, you must understand what is SAST and SCA. Why do we need SAST? It's the search of vulnerabilities by templates, by source code, by signatures, how the data that we get from users, from external sources, move along the application, and what are the results. SCA is more trivial, collection of data about packets, and then we can map that information on the vulnerability base. The task of SCA is simpler. Nevertheless, it's important. What does the classical application consist of? At a high level, 3 blocks. The first one is the source code developed by the people. Second, methods of external libraries. That's important. That's why we carry out component analysis. And point 3, methods of the libraries generated by developers in the company. This is the stumbling block very often in many instruments, including commercial ones, because for your own libraries, you will never find information about vulnerabilities, no feeds. It's your base, it's your product, and it's up to you to find the vulnerabilities. Then, how can SAST look for vulnerabilities? First, templates or signatures. SINGREP is a classical example of the tool of signature search. It has certain rules and constructs, and he looks through the code and analyzes it. There is no deep logic, there is no cause and effect analysis, just search by template.
Соответственно, анализ того, как
We analyze data analyzes source code, analyzes methods and functions. Of course, there is semantic analysis. In real life, we never saw it, but it's one of the possible ways of analysis. It's the most complex analysis. I mean, semantic analysis, as well as tint analysis of infiltration. Application Spectre says they have such print analysis. Tint analysis is closest to OPSEC task. We have a task of taking the source code and use different methods and approaches to find vulnerabilities. What about SCA? It looks for packets, and the simplest way is to use manifest. There is a manifest inside the packet, and it shows what kind of versions of the packet the developer may use. The manifesto sometimes doesn't use the actual option. It may only indicate the initial version. And in the closed contour, your option can be different from the initial one. Second, it can use log files. So we collected log files, fixed the versions of the packets, and the SCA analyzer uses the log file and looks at dependencies. Dynamic resolve, it's a good result. We emulate the collector function. Hot scoring, for example, code scoring. Code scoring uses the dynamic analysis function. And this is the right way to collect such information. Container scanning, also one of the methods, but apart from vulnerabilities in the application, we can get vulnerabilities of the basic image of the container and the final image that we get after the build. The basic image is not always equivalent to what we have after the build of the container of the application. There may be some upgrades, some additional packets can be installed, some changes in the binary code can be done. So container makes some corrections in the final picture. Important point 1. Ideal tool is a myth. We talk about it on very rarely because we realize there can be no ideal tool. Each tool has its pros and contras, has its pluses and minuses, has its positive and negative things. You must understand what kind of languages or frameworks are analyzed or not analyzed by this tool, which tool is best for your environment. You must understand the tool. Second, the tool cannot replace your thinking. It's related to point 1. If you want to evaluate a tool, you have to understand how the tool works. Why are we talking about it at all? We evaluate efficiency of the tool in our tools and in projects focused on implementation of that tool. We have Axeinos colleagues who published a research. You can see a QR code. It occupies 10 or 11 pages. And they list facts which they considered important for security development, secure development. First, manipulation of vendors with the tests and benchmarks. Sometimes a vendor can say, well, our tool finds 100% of vulnerabilities. You launch it, and see something quite different.
Уникальные,
Each tool is unique. Each tool is a unique mixture of solutions, codes, features, and functions, and something can go wrong. Do not always believe the vendor. Limitation of statistical analysis. When the vendor says, I can find 100% of vulnerability, understand that the more languages does the tool support, the higher is the probability that the total number will be average. You cannot efficiently scan script languages and compiled languages. Of course, each kind of language and framework has its peculiarities that you have to take into account. One language may have dozens of frameworks, each with its own syntax, connection, and for correct analysis, the tool must understand all that. In some cases, my colleagues believe after 87% of misses can be shown by the multi-language tools. A lot of false positives and a lot of workload on the team. The more false positives we have, the more workload you have for your OPSECs. And OPSECs will go to developers without looking that developers have a lot of tickets, there is a problem and we don't understand what to do, and there is a bottleneck and a snowball. We have a lot of tickets, a lot of problems, but if we start dealing with them one by one, in reality, you may see that it is not a problem at all. It may so happen. It is not a vulnerability, it's something else. Then the black box method, it's also a problem. All those fuzzers and so on, they use certain template tests which do not take into account the context of applications and the methods of the applications. It's just a general purpose fuzzers. And the problem of integration. It often happens that when we implement commercial secure development tools, such tools block at integration, no matter how strange it may seem. It happens. Let's go deeper. How can we understand for ourselves? How can we understand that a certain tool is, that something is wrong there? First, suspicion one. The tool doesn't care about packets. You launch a scanner and it doesn't ask for packet managers, for libraries. So the ready-made application is monolithic. It's the code and the methods of the libraries. They are all together. And if the scanner doesn't have any options for updating and tuning the packets, it means that it doesn't analyze them. Otherwise, the libraries would have been used. This is an example. We have an application. It's the general top-level scheme. We have an application and the user input, a sanitizer library, which is the enterprise library, and it is used. We have our own internal methods of protection, security methods, and we have the output, which the user gets as a result. And the structure of the library is on your right. If the scanner doesn't take into account library methods, it will go the following way. It will miss vulnerabilities And if you have synthetic methods, you will have a lot of false positives. For example, we mitigate vulnerabilities, but if the scanner doesn't understand the libraries, it will miss quite a lot. Suspicion 2. The scanner demonstrates vulnerabilities by referring to any line or method. You cannot see where the data came from, how they move across the application, how the code is executed, which leads to the vulnerability. It means that the scanner uses templates. Take SyncGrep, classical application, on the left the signature and on the right code of the application that we use for testing different tools. We want to find the call, which is highlighted here, or system comment injection. When user input gets into the application and leads to execution of some codes. And this is what happens in the test script. What will the tool find? Or system method inside the function. It correctly finds the imports, like in the first example, but we use the rename function here. We get a method and rename it. In Python, this is possible, and users often use it. Developers often use it in order not to write long names. I use this method myself very often. SyncRep understands it, and for example, there are commercial tools which do not understand this trick. If you use rename, then application inspector will understand it. Some other tools will not. One more thing is interesting. Same functions as we saw in lines 8 and 11, but we address to the object by name. It's important to see what kind of globals and locals in Python the tool can understand. If developers like such methods of addressing the objects by name, in stat analysis we are not going to see that. It's one of the limitations. There is a third point, which is about the condition. In this case, in SyncGrep, doesn't understand the context. It takes the variable, its value, compare it, and take a decision whether to execute the function or not. Stat analysis doesn't have a mechanism. SyncGrep doesn't have a mechanism which can evaluate whether the environment matches this parameter. For secure development of commercial applications, the scanner doesn't have information about what kind of environment will exist in the production environment, and you will have a lot of false positives because it cannot understand the context. That's why suspicion 3, no context, no understanding of the context. It's important, actually. Why? Because of what I said, and we have such cases when SAS and SCA try to evaluate application, it may so happen. If the application is in ACD, there is no problem in delivery of those variables. Versions of the packets are delivered as variables. Automatically, we enter the values from CI/CD and collected without problem. But if it's inside the scanner, or if we try to collect it locally, all those variables should be on the host. Otherwise, the process of collection that the developers had in their minds will not be executed. We'll get an error. Or sometimes commercial tools do not see that you didn't collect anything and they do nothing about it. For a scanner, it may be a problem. Another example, when variable environments are like this. In line 6, you'll see the environment through CI/CD, and it's not a secret. We expect it, we add a variable, but scanners may correctly process it, or they may say it looks like a secret. Take, for example, this screener. It will correctly see that there is a secret inside and misses CI/CD variable here. The scanner understands the context and believes that it matches that what is to be done. Suspicion 4, a bit of magic. It's a deep question which requires research. Vendors often doesn't tell you about the methods they use to find vulnerability. They may say it's a commercial secret, it's in-house developments and so on. But for OPSEC, it's important to understand how the scanner looks for vulnerabilities. The scanner, in this case, is just the automation of our routine actions. We can find the vulnerabilities manually, but sometimes we delegate it to the tool. We write the rule, launch the scanner, so our eyes relax, and we get the result quickly. But sometimes the vendor says, our scanner will find everything, and we don't understand what is he going to find. And this is a problem. Unfortunately, we have example for open source only, which are open. In these tools, you can understand what kind of rules are there and what kind of libraries are taken into account by the scanner. What are the sources? What are the codes, code QL? In SAS analysis, for example, here it's a Java application. If we take a list of libraries and this table, and we can see the coverage of the scanner and understand which parts of the code will be scanned and understood and which will be missed. And those which are not in the table will not be analyzed by the scanner because he will not understand it. And classical problem, suspicion 5. Most of the tools have it. Unfortunately, technical support doesn't use the tool, and you have to support the tool yourself on your own. And now let's move to the second part of the presentation. How do we test the scanners, and what do we pay attention to? First, what do we test? Methods of analysis. It's not as important what the scanner will find at first iteration, but how it is going to find it. Signatures and so on. We'll launch it for the first time. The scanner runs, We scanned and got a certain result. This result means nothing. Before we understand how did the scanner found those vulnerabilities, what was the logic of the scanner, why did he decide that this is a vulnerability, then we're going to realize whether it uses templates or methods or graphs or data flows. It's important to understand all that. Second, customization and usability. The engine. You can develop rules, and that is important. The rules are the main requirement to security tools. If the tool doesn't allow you to write the rules, or if the process is very complex, then the tool is bad, because you will find only the vulnerabilities that the vendor indicated beforehand. And for secure development, you are automatically linked to the vendor, and you will require continuous updates, and the vendor cannot guarantee that it will find everything. Closed circuits, we told about it, but this is a serious problem for some tools, when suddenly it turns out that the tool works in a bad way with LDAP. Commercial tool, large vendors, but the tool cannot send letters, is SMTP. And we often find vulnerabilities within the scanners themselves. What do we expect from SAST analysis? We have certain applications, and on your right, you can see the methods used in the libraries which the developer inherits for the code. And the results of those methods go back to the application code, and we expect that the scanner will go that way, but it will not search directly in those libraries. Well, you can take a project, send it to the scan, and find 10,000 vulnerabilities. Do we need them? No, because there is no entry point for end user data here, because it's vendor volume, and less than 1% of that code is used in our applications. All the rest is false positives. But if you get 10,000 vulnerabilities, you will overload your scanner, and it will be a large workload on your OPSEC people, although you can avoid it. Search for secrets. It's a script that we use for secret search. There is a certain secret here which most of the commercial tools cannot find. But in Python, it's quite natural. Application inspect understands it and finds it, but upscreener doesn't. There are methods of search find for the upper line, and in line 12 we also have entropy. Inside I developed a script, and sometimes we use it, and by entropy you can confirm the correctness of secret search. We can recheck it, and automatically through entropy confirm it. Customization of rules. TrueFill-Hop uses it. What do we expect from customization? Exclusion or deletion of the rules. Unfortunately, we have it only in one tool, but although it's an important feature, because vendor rules sometimes produce a lot of falses. SAST analysis, you know, how many vulnerabilities it shows, which means nothing for you, which are not about your application code. And accordingly, it's important to switch off, turn off the rules.
Требования по написанию правил, важно это отметить. То есть
Well, you have to point out that you must have the capability to turn off the vendor-based rules and create your own rules. Sometimes you can write it directly in the scanner or develop it somewhere out of the scanner and then upload it. It's a better way that if you can write it inside the scanner itself. And there is a third option when you can write the rule inside the tool and check it inside the tool and debug it. Unfortunately, no commercial tools have such a capabilities. Debugging. Yes, debugging. Do we have to use special utilities or can you do it in the scanner as is? If you have the rule generation feature and you have to run scanning for secure design, you will overload your tool. The developers can have pipelines in CI/CD. Even in CI/CD, you need 2 or 3 minutes. If you have 10 iterations, pauses, lags, and the simple thing can take a lot of time. Well, and security. Is there foolproof capability?
And you have security. The scanner itself is foolproof. We made it crash with regular expressions, for example. We had DDoS, other such classical vulnerabilities, and scanners just go on an infinite loop. The rule developer can be a junior. They might be inexperienced, they might be testing something out. So if they have a rule that crashes the scanner, it'll go haywire. And the tool will not be usable commercially. Vulnerabilities themselves. We report them to vendors. These are the most fun ones out of those that we've identified recently. Vendors reply often that they don't have vulnerabilities. The scanners are not available to most researchers. That's one of the reasons. Vendors don't have them in their bug bounty, they're not publicly available. It's logical that you don't have reports if it's not out there. Then if it's a secure development tool, you cannot always start hacking it or crashing it, because there are other people who use it. And then some vendors do not know where to apply the load to find the vulnerabilities. Some of you might have seen this face. That's what we've been testing late last year, early this year. His name is Alex Burson. He found a vulnerability that is out there in the supply chain. It's a type of attack that we've been checking for currently. Here is the model for this attack. Some companies wants to execute untrusted code. If it is ran through a SAST analyzer, the scanner installs the packages. There is a malware script in the package, and then there is RCE in the scanner or its module. There was an example from Python. Here is how it
Вот
looks.
буквально там в начале года мы нашли в 2 коммерческих инструментах.
Earlier this year, we found such vulnerabilities in 2
Поработал над исправлением.
commercial tools. One vendor accepted it and fixed it.
Это
The other vendor told us that it's not a vulnerability,
ожидаемые последствия. Вот как здесь написано.
but an expected consequence, as they phrased it.
Как бы, если пользователь сканирует недоверенный код,
They claim that if you use untrusted code in
если вендор открыто не
the
заявляет
scanner,
о том, что
it's your problem.
предназначен для поиска НДВ, то нужно быть готовым к тому, что сканер сам
If
может стать жертвой при таком
the
сканировании.
scanner doesn't say expressly that it can be used for untrusted code, it can become a source of malware.
Приложений, которые вы сканировали.
And then this can compromise the source code of other apps that you've scanned,
Вот, поэтому
because
тоже к этому надо быть готовым.
there is a lot of data within the scanner.
Ну, самый первый — это критическая оценка. То есть
On to
нужно
conclusions.
критически относиться к тому,
Take a critical look
что говорит нам вендор. То есть
at what you get
всегда лучше
from the vendor
проверить. И проверить на своих
Double check.
приложениях, когда вы знаете уже какие-то заложенные
and check it against your own apps where you know the vulnerabilities,
и,
where
соответственно,
you know that they've been fixed.
тесты внутри у себя провести.
This would be a sort of safe independent test.
То, о чем я говорил, но чего нет у
Heat maps.
вендоров. Ну и понятно, почему нет. потому
That's what I've
что если
described,
начать
and
строить
the vendor
узловые карты,
just
то
offer it.
окажется, что
If you
большинство
start doing this,
приложений — это terra incognita
you'll see
сканера. Потому что,
that
к сожалению,
most
на
of the
сегодняшний день
apps
ни
that
один
you
сканер
scan
не учитывает
are
методы
a sort of uncharted territory
кода приложения.
for apps.
Есть методы
Not a single
кода,
scanner
такого
accounts for
поведения.
methods in the libraries that are
Когда мы на питоновских
added or
проектах
pulled by the
делали
source code of the app.
динамические, получается,
You can bypass it.
динамические эти библиотеки и
We
делали
had
из исходников. То есть вы
dynamic
говорите,
edition of the libraries where we presented them as part of the source code. You can export the code from there,
приложение, переписать динамические импорты, ну,
add it to the source code,
application inspector начинает находить эти
rewrite it dynamically, and then application inspector and other scanners would be able to catch it. But if it's in libraries,
Опять же, все вот эти методы,
no, this doesn't work.
соответственно, требуют доработок, то есть и они зависят
All these methods require additional development. It'll depend on the framework, on the programming language,
человека писать вот эти вот самописные
and
скрипты.
the willingness of your OPSEC engineer to do this development.
На самом деле это не мое утверждение.
Your
это
best
утверждение
test
коллег
is the one where you wrote the rules.
еще в те времена,
It's
когда
not
Маркс, в принципе,
my claim even, it was said by check marks
вот. Но
from the
на самом
times
деле
when
здесь,
they were used to be present in Russia.
большая доля правды содержится. То есть, если вы возьмете какой-нибудь
This
чекмарк
holds true.
и запустите его на там, ну,
If you run check
да,
marks
вы не увидите там, ну, какой-то прям тонны уязвимости.
in any simple project,
Базовые сработки по
there aren't going to be that many vulnerabilities.
но это не значит, что сканер плохой. То есть
It'll
очень часто
flag
проблема
some
поиска уязвимости, она,
vulnerabilities according to the rules under the hood.
первое — это
The scanner is not bad.
правил под капотом
The
сканера.
reasons can be
Второе —
different.
это, соответственно,
Lack of rules is one.
сканер ищет эти уязвимости.
Then
То есть
the
есть
methods
вероятность,
that
что
are
он
used for
при
scanning
анализе просто
is another
попал в
cause.
участки кода и, соответственно, ну, не смог найти там
The
уязвимость.
analysis might have not reached the parts of the code where you have vulnerabilities. And then libraries again.
Понимает, не
If
анализирует.
these are third-party libraries,
Здесь у нас
the
будет
scanners do not see them,
ну и лучший обсек — это тот,
which creates
который
major
знает, как
gaps.
работает его сканер.
The best OPSEC engineer is the one who knows
Коллеги,
what's under the hood in their scanner. Thank you, colleagues. That's it from me. I'll be taking questions now.
И тут микрофон, вот если что, есть в середине.
Microphones in the aisles.
Стоят в проходах, подходите,
Yes,
задавайте вопросы.
do come up and ask your questions. The best question will be rewarded with a book from Teacher Publishing House. Pavel Orlov, T-Bank, thank you for the presentation. You said when you spoke about secrets that you use entropy to filter out false positives. Why not use get leaks, which has it out of the box? Truffle, get leaks have different applications as tools. Get leaks has history lookup as well for past commits. If you're looking for vulnerabilities online, you have source code and you get a result. Then you need to verify it automatically. for secrets.
Проверка тем же трюфелем.
Then truffle or entropy checks will get you there quickly.
Какую-то продолжительную работу, когда нам надо привести,
Get leaks is for a slower pace. You have a repository, for example, and you need to clean it up.
Мог закоммитить вместе с исходниками, потом опомниться и такой типа, удалил из кода.
There might have been a commit,
Понятно, что в коммитах это осталось.
then there is recommit, and it's in the commit. When they saw that there was a secret,
И здесь скорее мы страхуемся от этого. А тут
that's where you'd be using get leaks.
понятно, что мы внедряем.
As an integrator, we do deploy tools,
То есть у нас как бы множество
but we have contracts to analyze code, to do code review. Different apps, different projects.
Поэтому здесь больше.
We need to do this on the go. So I've focused on the methods for online. It's about labor intensity, yes? Yes. So we are not looking for secrets, and if they were fixed, it can be an expert or a Git repository.
Дмитрий, спасибо большое за доклад. Было...
Thank you, Dmitry, for this presentation. It was very interesting. My name is Georgi.
Хочется услышать ваше мнение на стыке двух смежных...
What's your opinion
Вы сказали,
at the interface of two subjects?
различные вызовы, библиотечные, внутренние...
You qualified a good analyzer as the one that does calls and analyzes them transitively. And then you mentioned rules that can be customized and tested. It begs the question, how do you test custom rules without running a full scan of transitive functions so that it doesn't affect CRI, CD, and the full scans of all projects? A good question, yes.
Есть разные типы правил для разного.
You have to understand that there are different types of rules for different vulnerabilities. Let's look at Application Inspector. Template scan. It's a method there where you can set up your own template for vulnerabilities like mgrab. And then there are SAST rules. They are under the hood in the scan. But they don't let you write the rules in the recent versions. So you don't have to run a full scan.
Для того, чтобы проверить работу шаблона, вам достаточно одного правила.
You cannot write these complex rules. So to check one template, you have just one. You have just one rule. Okay. And what if you write rules for data flow, Dainful, other more complex things?
Нам достаточно вот одного просто какого-то кастомизированного микроядра.
Yes. You'd need just one microkernel from the scanner, which is customized. You run just one rule for one project. You don't have to initiate a full scan. You just initiate that one rule. It'll take much less time than a full scan, even if it's at an entire project. Okay, to follow up on this, what if there are dependencies between rules?
Если написано свежее правило, зависит от...
If a new rule is dependent on some other rule, do you mean something like CodeQL? Including that, yes. Or if application of the new rule depends on the output from the previous rule. Yes, you'll have to run a full scan, yes. It's down to the original capabilities of the scans. If it's just running the templates, you don't need a full scan. If the methods for analysis are more complex, you'll see that you'll have to apply the rule to the entire project. You're right. It'll require a full scan.
Спасибо за доклад. Меня зовут Илья.
Thank you for the presentation. My name is Ilya.
Сейчас все больше сканеров статических.
My question is this. There are more and more static scanners who used to have SCA.
Проверка компонентов на использование уязвимой
функции. They add components for calling vulnerable functions. It seems to hint that SAST will
Нет, да?
fully replace SCA as one of its new parts.
Там же все построено
No. Your example with TIE
на той базе фидов, которую
relies on the feed base that you get from the vendor. When you do component analysis, not a single SCA analyzer
в коде. То есть он говорит о том, что
will show vulnerable methods in the code. It has a graph of calls and it's reachable
те библиотеки, которые имеют известные
because it calls libraries with known vulnerabilities. But it doesn't mean that data from the code invokes these vulnerable methods.
библиотек, которые мы там, ну,
You'll have to then validate that hypothesis that through transitive dependencies you'd be invoking vulnerable functions. But there is no tool that will say if it affects you. You'd need a diff from the vulnerable version, then the fixed version,
верхнеуровнево, то есть понять, в каком
and then you'll need to understand where the vulnerability is, if it was fixed,
в этот регион исправления, тогда мы можем хотя бы хоть как-то
if your calls go to the fixed area of the code, then you can say with some probability that
это уже другие методы.
your code calls to the vulnerable part. But why would you need this information if you use the vulnerable component if you do not call the method? You're right in saying this. It's a common challenge. Everybody knows that SCA is needed, but nobody knows what to do with its output. We have information about transitive dependencies with libraries that lead to vulnerabilities. But then you have this on level 2, 3, and 4. This doesn't mean by default that the code will be affected by these vulnerabilities. If you have your own app and then it inherits components from some third-party thing, that's one case. Unlike your own library that you're developing that inherits some vulnerabilities. As you're doing quality Git, you'll need to go a level higher. If it's our library, well, we have an app, it uses our own app, and then that library has a vulnerability. It's transitive dependency, but if our quality gate skips everything that's transitive, we'll misdirect vulnerabilities in our own libraries. That is something to keep in mind as well. Our approach is this. First level of embedding in custom libraries are vulnerabilities, if flagged as such, and we fix them. If these are open source, we don't usually go, or it's reachable, if it's to send the third level down. On probability, you can just accept it as a risk. Another question about SAST. You mentioned writing your own rules as a criterion. It's a mature approach, very much so. Not all OPSEC teams can afford writing their own rules, which then means that teams have to procure expertise from the outside. And many vendors have trained their tools on most common projects. I come up with my own vulnerabilities and then test my scanners on what I feed it, not what was used for training. And open source sometimes is even better, like SimGrab. Do I have to report it to the vendor, in your view, my own vulnerabilities that their scanners don't find? Or just tell them that you're not up to our standards yet? Well, the rules are not confidential, so you can share, but this would be you doing the vendor's job. It's a question if you'll be willing to do that. We engage with the vendors a lot, and I try to push them towards opening open source rule marketplaces, contributed by users, tested by each other, exchange of rules. This would drive detection, and you'd be able to skip bad rules if they are voted down. But if I tell them that here is the code that your scanner didn't find, they'd write the rule and they'll fix it, and it'll be more expensive. Yeah, now it detects them. It's a well-known issue. But it's a philosophical question of what to do about it. You need to first determine what the problem is. If it's about the rule, it's easy to fix. Sometimes the scanners do not go to that part of the code that you wanted to. Hello, thank you for sharing. My name is Alexander. You said that you have a set of tests to see if an analyzer has different methods, aliases and other. Static analyzers are being tested now. AppScreener is part of it. FT is part of it. And they have an open set of tests for analyzers. It's published under GPL v2. So are you going to upload your rules there as well? Well, I think so. I don't know where to. I'll send you a link. Sure. There isn't anything confidential. We use the methods that scanners do not catch. Our system is easy. It's not about coming up with some code that the scanner detects. It's about edge cases. If it uses globals, for example, the scanner doesn't know. Yeah, sure, will do. Thank you, Dmitry. That was very interesting. You had a slide about CVEs, and then you had vendors. What's the quickest way to detect a vulnerability? Like, I'll take this scanner and it'll be 10 minutes or 1 hour detecting NRCE. What was the case where you did it the fastest? What was the fastest case? We had the license expired, we had to renew it, and it had a license download without an account. And the vulnerability was in that you could get XXE from that handle. It didn't decompile them correctly. We put a payload there, and in this licensing module in a commercial scanner, there was a vulnerability. They fixed it, of course. Thank you for the presentation. Here is my question. There is all this ML hype. You get different ideas about integrating it with SAST analyzers. Does this make any sense, especially as you're talking about custom rules? People can have different approaches to writing styles, and different products would require different rules. Could you clarify? Let's say we have a SAST. You can write custom rules. And then we have the products that we'll be analyzing. And it could be preferable to customize the rules for each type of the product. Similar checks can be expressed differently. So there are going to be differences in style and syntax. If you configure them dynamically, you could get better detection. Is it useful? Unique sets for specific apps. Let's call it that, yeah. It is possible only with SimWrap,
вряд ли вы будете под код
where
QL
you'd have templates. I don't think you'd be
Хотя по-хорошему
customizing code QL.
комбинировать на самом деле.
Ideally, you'd combine this two.
Понятно, что коммерчески вам так сейчас
Speaking about open source, commercial scanners would not give you this functionality. AppScreener lets you add and remove rules.
допустим, за реверс-прокси,
If your app is published with reverse proxy, so SSL or HTTPS detects can be
вот, и логично, что все эти
discarded because you have reverse proxy.
вот.
They become invalid as alerts.
Набором. А если брать именно
You can customize the rules set.
какое-то конкретное приложение, то, наверное,
And then if you speak about the rules themselves,
способ имеет место. Понятно, почему бы и нет.
this is something that you can do,
Код QL и
but I'd use code QL
какой-нибудь SimGrep, там OpenGrep, да.
and mgrab or opengrab.
Понимаете, проблема типа, что вы будете
You
писать
see,
эти
the challenge is that
Не, ну смотри,
you'd have to do this for each app.
и если мы рассматриваем разного
So we
заказчика,
have different customers,
то у разного
especially in your
заказчика
case.
свой
All customers
по поводу того, как надо
would each have their own guidelines for code development.
у нас будет
If you could
лучше.
tailor your scanners to this, performance would be better.
Вот надо найти
Ну, на
баланс.
тоненького, я
You
понимаю.
know,
С одной стороны, вы можете
it requires a certain balance. You can decompose the task
ну, там,
and make the rules as simple as possible.
такая-то имеет, ну, просто
If variable
имеет какое-то там строковое
is
значение,
present in the code,
кожаный секрет. Так можно
then
сделать.
you have a hard-coded secret.
Себя фолзов, но
You wouldn't have any false positives,
допустим, сегодня он называл там это
but there is no guarantee that today it's called secret password and tomorrow it's secret password 2,
То есть мы можем
secret password 1, and then the rule will fail.
Окей, спасибо.
So it takes away from the flexibility.
Добрый день. Я
Hello.
практически уже забыла свой вопрос, но на самом деле...
I almost forgot my question by this point while I was
Скажите,
queuing up.
пожалуйста, а какой сакральный смысл в этом докладе?
What's the actual,
Из этого доклада говорят
you
о
know,
том, что мы должны кастомизировать
main
правила.
thrust of this
Мы практически всегда
presentation?
всё должны
Your
кастомизировать,
conclusion is
поэтому мы от
that
этого
we
никуда не
have to
денемся.
customize the rules,
Проблема
but you
кроется
always
в
do
тех
this
компетенциях, которые эти правила
at some
будут
rate.
писать.
It's about the skill set that's required.
Что-то в лоб.
Assessed Analyzer is a very straightforward tool, and it's
Так мы с точки зрения
not
бизнеса
aware of the
определяем эти
context.
правила. А другой
So
вопрос,
it's down to the business logic and how they translate into the rules.
сюда искусственный
To
интеллект.
follow up on the previous question, why not use AI?
Включить в том числе и для генерации этих
As was
правил,
presented
компетенций недостаточно.
previously,
Расскажите, в
AI can be
чем
used to
смысл, потому что я
generate
слышала только
rules
то, что все
if you don't have the
анализаторы
skills.
это
Because
то, что нам
can
не
you
рассказывают.
recap your presentation? Because what I took away is that analyzers are pretty much useless. Well, no, they're not all useless. They all have their own limitations, and you need to be aware of those.
Там нет каких-то правил, да?
Oftentimes, it has to do with lack of rules, specific rules.
Если вы попробуете написать
When we go on to write our own rules,
для какого-нибудь
if you try to do this for SimGrab or Application Inspector, PVS Stereo,
Solar Screener, то вы внезапно
and Solar App Screener,
прям капец какой.
you'll see
И, то есть,
that
если вы
the process is entirely different.
думаю, что, ну,
If you did this for App Screener,
не бояться нечего. Вот.
you know, you've seen it all.
Вообще нетривиальный процесс, и у каждого вендора он свой. То есть
It's
нет
very unorthodox, and it's different vendor to vendor. There is no standard.
желательно понимать. То есть, когда вы, ну, там, внедряете
So it's preferable
ну, типа,
to
готовый к тому, чтобы приводить его
know
до
this in
и
advance.
выписывать правила.
Once you buy and implement something, are you willing to customize it? But we'll have to. We'll have to learn to do this,
в котором работает продукт.
Да.
and
Ну, все вендора вам
we'll have to learn the syntax. Yeah, but not all vendors let you do this.
написать правила, там,
It's
ну,
a
например,
different
на
question.
DSL, да,
In Inspector,
называется.
you can
Но SAS правила
use
ввели,
DSL, what they call
не
them.
знаю, 3-4 версии назад.
But
То есть, там
3 or 4 versions
осталось это
before,
но если вы попробуете
they don't have
разработать,
SAST rules.
теперь
The button is still in the UI
вы не сможете этого сделать.
for point 11. The new version doesn't let you set the rules.
И, соответственно,
It's been taken out.
по шаблону.
Нет, ну, без,
So you have templates, that's all.
автоматизации правил это, ну, на мой
But
взгляд, это не работает в
I
принципе,
don't think
потому что
it's any useful without custom rules.
и вообще, может быть, мы хотим
Our
искать
goals
какие-то, извиняюсь, матерные
can be
комментарии
different.
в коде. Это,
What if
конечно,
we want
изначально
to look
производителем
for
не
a
закладывается, но у нас есть
profane
определенные
comments in the code?
Поэтому рассматривать анализатор без кастомизации
It's not an
правил,
out-of-the-box
тоже вопрос,
functionality, but
Да, но
it's a custom rule that we might need.
понимаем. А
that disqualifies the tool in procurement. Well, we are on the same page there, but it's not out in the market. The customers do not ask for this. Until it's not required of the vendor, they see their job as developing a scanner that takes the code and spits out some results. OPSEC usage, developer usage is not considered. The end user of SEST analysis is the developer. OPSEC professionals use this, but it then goes down to developers to fix it, actually. So that's the end user. As long as nobody requires this of the vendor, well, we are constantly asked to provide this. For 3 years, I haven't had a negotiation where people wouldn't ask about custom rules. And I think that the room here is all competent. Yes, but the rules can be different. In 2022, for example, what scanner became the most popular? We don't have check marks. We don't have access to SNCC, other foreign solutions. Everybody went for SimGrab. They have CNT analysis, but you cannot use this from the console. You have to be connected to the cloud. That's their current policy. It's not free. You can write rules, but they will not run in the free version. It's not this problem. We could get Russian vendors to do this, but not all vendors are willing to open rules creation and test analysis. No, it's not available.
Можно, значит, наверное, можно написать.
Well, look, if we take a ready-made product, I'm not ready. Well, sorry, we can shift this discussion offline, off stage. Let's listen to the last 2 questions because it's an interesting discussion and you can continue it later. Hi. Well, first of all, thank you for the presentation. And the question is like this. On the one hand, a user of SAST wants customized rules. On the other hand, it doesn't want to do something wrong in doing that or significantly increase the time of analysis. Who should be responsible for that? And what is the difference between customization and over-customization? The vendor assumes the responsibility on itself, because when the scanner drops, when it is crashed, you go to the vendor. If you in Windows open the Windows and everything is crashed, it's the problem of Windows, not a problem of user. Maybe a user does something wrong, uses a wrong name and everything crashes. It's not a problem of a user. If a user can do it, if it has such a capability, then the vendor must assume that that a user can make mistakes. In Windows, if you use the site Windows 101, it always highlights in red how many iterations were used, how much time was used. You can have a regulator or a bad regulator, but the scanner will consume it. And you will have unlimited, infinite scanning, and you will never understand where the problem is. Because logs are also a big problem. There is no transparent mechanism for log collections, and vendors do not think that an OPSEC cannot always come to the host and take the logs, because they don't have access to the host on average. And very often OPSECs cannot go to the host and take logs. But the vendors do not think about it, and accordingly, a problem with crashes, well, you will never understand why, because the tool is not ready. It so happens that you would like the vendor not only provide the maximum customization capabilities, but help you to write the rules and correct the errors and point out the potential errors. That would be nice. The open marketplace of rules would be nice. If we eliminate competition between the vendors, that would be good. Because the vendors said, okay, I did it, and nobody else should know how I did it. If we omit it, if we install, if we develop a common standard for rules, that would be good. Then we can prioritize the rules, divide the good from the bad. The good ones will be voted for, will be published in the marketplace. So there should be something like a play market for such rules, where users of SAST and OPSEC can choose the rules, pay for them or choose them, and the vendors will see the popularity and the efficiency of the rules. Thank you very much. I got the answer. It was a good answer. Thank you very much indeed. Hi. Let's talk not about vendors, but about users and developers. Using SAST out of the box is impossible because you will have a lot of falses. Paid, unpaid SAST tools. The developer doesn't want to develop rules. The developer doesn't want vulnerabilities in his code. Yesterday, we heard that this is a problem which is not being solved at the moment. It's a problem of the program verification. So the problem can be solved by heuristics, and the rules, sets of rules, are actually heuristics. And for the here it is a set of use cases collected here and there. And the question is like this: how can we find the golden middle? OPSEC development is needed. On the other hand, it's a workload on the team, and teams are different. You can have a senior-based team and junior-based teams, and they will start developing it and will make the things worse. So what are your ideas about how to install this and what to do with the information that we get? Good question. Look, everything starts with what? When we launch scanning, the scanner gives us the result. What do we see there? Description of the problem and recommendations. If you take the average tools, descriptions and recommendations, you will see nothing useful, which is not related to practical life. If you have, SOC solutions, Russian-based, Russian-developed solutions integrated with AI assistance, if you launch our descriptions, then most of the models will try to fix your codes and offer a solution. But this is for open circuits. With the closed circuits, we can launch the model inside the enterprise. 32 billion models. We have open source, free models. Of course, we have additional risks related to the AI assistant, but for young developers, for juniors, if the code is not closed, you can download the description and ask for corrections. If we have complex vulnerabilities depending on different methods, then AI assistant wouldn't analyze the context. We have black box AI solutions, integration through plugin, but you have to send your source code somewhere. Not all the people would like to do that. Especially in enterprise solutions, not all the companies can allow that. So there are banks and government agencies, they cannot send their source code elsewhere out of their perimeter, but local models can be done. Build the right recommendations for the developers. I told you before that what is the problem? Vendors generate tools. The tools finds vulnerabilities and gives you recommendations, but the end user is not the OPSEC. For example, when I look the result, I don't need the what is RCE. I understand that, but what about the developer? Does he understand that? How can we explain it to the developer? How can we teach the developer? Then, of course, when we write reports, sometimes we attach the codes with corrections. The problem is clear. Something was done in the wrong way, and you can easily rewrite it. Why not doing this? Why not attaching this code? If there is no functionality, then you can add an example. Of course, it's difficult to do it for the whole project. If there is something fundamental, the violation of the role model, you have to redo the application on a large scale. Well, may I add, because we don't have enough time, answer me yes or no. Can we tune SAST in such a way that it will not give us false positives? Well, upscreen. Yes or no? Yes, we can. SAST or you can reprocess the results. SAST results. Thank you. I know why you close the section.
Но это еще не все. Тебе нужно вспомнить.
But this is not all. You have to recall all the questions and choose the best one. That one over there. Well, please come to the podium and get the prize. Thank you very much. That's all. Thank you.
И мы на этом завершаем. Спасибо всем.
And at this point, I can say goodbye to all of you.